All right. Hello and welcome everyone as you're coming back. We had a power outage here. Gonna go ahead and start rebuilding.
We could be back. We're mostly back.
Yep, so sorry about that.
So sometimes shit happens. And you live and learn. Your internet dies, you lose whatever. The co-host is supposed to be able to hold it for a little while. Maybe we'll ask Brian. He has super experience.
Yeah, so
What
anytime we've done it, the host leaves, it's a wrap.
Yeah, if the host leaves, actually leaves, and I think a power outage does it. I haven't experienced that one, but yeah, you can close out the app and still kind of refresh it a little bit there. But I think a power outage trumps everything. Man, it's a good thing these boys back in 1969 didn't have to deal with this 2024 crappy tech we deal with. Can't even keep connections and stuff. Whatever. We're going around the where are they going around? We lost them. That'd be weird. Refresh the app. Refresh the app.
And we're back. That's cool. We need to do it. So I didn't have audio, so I couldn't hear anyone talking in my bed. But I think I'm really back now.
Welcome back.
Oh, immediately tinny. It was good sounding for like 4 seconds. I had it.
Come back.
Dude, why does it immediately go audio driver crappy? Or whatever this tinny thing is.
Yeah, so I don't know. That's the problem I've been having the last 5 weeks of Twitter. It's been unbearable.
Yeah, I just get used to it, I guess, is what happens, and then I think everyone else hates it, which is fair. Which is fair to
What are you
subject.
hearing? I don't even hear anything.
Well, when I'm listening, it sounds fine. When become a speaker, it sounds immediately different and hollow and tinny and echoey. Like if you didn't know any better, I thought there was an echo, but it really just makes everyone's voice super tinny sounding, like you're in a metal room or whatever.
Hmm.
It's terrible, and then you're streaming a terrible audio to everyone. So I guess we can send out mics again. Sorry, everyone.
Yeah, I sent out mics. What up, Kat? How are you this evening? This lovely flat Earth Friday night.
Doing absolutely wonderful. It's a flat Friday for sure. Haven't seen any curve in a while.
Do you feel like everything's moving around you, or that you're whipping around aimlessly through an endless hail of mysterious objects that always change?
Ooh, that's a tough one. It's really tough, but I can lay on the ground. I can stare at the sky and close my eyes. I can open my eyes. I think the sky's moving, Shane. I really do. I think I'm standing still and the sky's twisting around above me.
That's amazing. That's what it looks like for everyone. I wonder why. I wonder why that is. Well, you know what? I'm going to adopt the philosophical belief that it can't possibly be that out of humble hubris and the rejection of the divinity of human life. What do you think about that? Therefore, you know how you live on a balloon? We're going to pretend that everyone's expanding everywhere and you couldn't actually tell from anywhere, and therefore you're meaningless and have no soul. How do you do, guys?
Oh, that sounds horrid. Who would
Right?
believe like an awful tale like that? Sounds like a sad way to live your life.
Right. But say, like, if you
I
wanted
feel
everyone to
sorry for those people.
if you wanted everyone to believe that, right? Like, what you'd have to do is to trick them into as a pseudoscientism or just science, and then get people to to worship at this altar of science while unknown, practicing, ancient Nazi beliefs, tied to, say, Kabbalah. What do you guys think about that?
Did someone say
trickery and the
Kabbalah?
Kabbalah.
Kabbalah.
Is that like a Mexican dish?
Kamala.
The root of all, mysticism, the old practices, dude. It's like where atomism actually got birth from materialism, and how they extrapolated modern quantum physics and the back doors to science, where things come from nothing and everything can facilitated by a big bang, where all of a sudden everything came from nothing and no one and nothing caused this. Don't worry about it. Totally trust me, bro. A whole bunch of nothing coalesced into something that then birthed into something that was so hot and heavy and earthy that it attracted other nothing into the something, that then the something became a rock, which then became gravity and got round, started spinning, wobbling through the universe, attracted another collider, ran into it, created the moon, always galactically created around it to create a super stationary lunar locked, phase locked moon that never rocks synchronous orbit, rocks and rocketing around the universe though in super synchronous orbit with you. So you sick. I mean, come on, dude. I love fairy tales, but that shit's whack.
One of the greatest stories told to man.
Right, but so to get people to believe this wild, wacky fairy comes from nothing, there is no God, humans aren't divine, and nothing is meaningless. You have to have the scientism back of the Big Bang, evolutions, monkeys, retarded fish, frog thing. Have to have the giant expanse provided by carbon dating and the giant years of evolution. Have to put out the generation of a planet over billions of years, so that tiny micro changes that could be described as adaptations can be used to trick people into thinking of monkeys became people and fish became frogs, all that nonsense, just to get rid of God and the divinity and that geocentric look that when you look at the sky, everything revolves around you. I mean, think about that.
And you forgot gay. It's gay monkey fish frog. You can't leave the gay out. You can't do it.
I was quoting Mr. Garrison. I didn't even know it, man. Dude, how South Park shaped my adolescence.
Absolutely, dude. I love it. I'm glad to know that, Lake Pontchartrain did nuclear space. I was like, really, dude? Really?
Ooh.
Yeah.
So earlier when I said that God hates Esau, I actually don't know anything about that, but Tammy Lou posted some scripture quotes if anyone wants to read about that. The way she asked the question made me think that God loves the guy. Send you a mic, Tammy, if you want to come up and talk about that.
Yeah, if you have any questions about scripture, hey, don't you mess around. She'll send you a flip book with everything you need to know. Nah, she's good for that. She's good for that research.
Awesome.
Tammy
Hey.
may send you the information, but Lynn does the talking for.
Hey, quick question, Alan, if you don't mind, if you're gonna cover this, because you said you were gonna go over Aries a little bit, just never mind. But can you give me the TLDR on the final response that you had to our favorite physicist that works at CERN?
Absolutely, bro.
So
Absolutely.
the Malcolm Bodum video, you guys had a quick back and forth. So I'm just focusing at the end. What did he mean, and what was your response that he has yet to reply to?
Yeah. So give me 1 second. Let me see if I can fix this audio glitch by reconnecting. So we have nice clean audio. Connect. Testing 1, 2. Okay. So the final summation of what had happened was, right? If you use relativistic velocity composition, meaning the rules for adding c plus or minus v, 1 second, it has to agree with the classical theory as well. So when you do that, they both predict that when you add water to a telescope, the angle will increase from 24.5 to 27.5 arc seconds. And when you use that ratio with the velocity of Earth on its assumed 30 kilometers a second orbit around the sun, that's the angle that you can get. And you can backwards derive one from the other. So if you introduced water and you got that increased angle change, it would be very significant proof that the Earth was actually the cause of aberration, right? Because remember, the purpose of the test of introducing the water is to introduce a change in the angle to substantiate which is moving, either the earth or the sky, or some medium in between the earth and the sky, right? Because it could go either way with just the measurement in air isn't enough to tell you those things. You have to introduce an asymmetry in the system. You have to manipulate an independent variable, right? We're all familiar with the scientific method. So we got to introduce a new variable. So anyway, when you do that, like I said, relativity, when properly applied, makes the same prediction, but they just apply an additional term in their equation. The classical equation is identical, but they just add a little gamma term, which just means they're adding an additional v squared over c squared, which is just going to move the decimal place back about 10 or 12 places. So it's just agreeing with the classic theory down to 2/10 millionths of a decimal place. Now, because they didn't make that measurement of the increase, the implication is that the Earth is stationary, and you have to introduce some reason why, right? So what Franco was doing was he was actually saying that the math was being done wrong, and when you apply his interpretation of how to do velocity addition, he was multiplying the refractive index with the speed of light, which would increase the velocity of light proportional to the refractive index. So if you look back at the Michelson-Morley paper, the first thing that they say on page 1 is how they did the math wrong for the theory that calculated that light would have to move faster in water to have a decrease in angle change, and that's not what was measured, and that theory is wrong. And then when they do the math properly and divide the speed of light over c to reduce it so that it's moving at 0.75 c, you predict the correct angle change. But then you have to make the absurd hypothesis that the water is being carried in the opposite direction of motion, which is, as Michelson says, absurd. But mathematically, what Franco did, even though he was considering light as a wave the entire time, like the functionality of the math that he applied would made it accelerate in the water, which is preposterous. And that decreased the angle that would be predicted. So he predicts that there would be a 15-degree angle change from the normal measured 20. And that's not what was present. That's the wrong prediction anyway. Not to mention that it accelerates the light to do that, which is an untenable position. So there is no answer for this. You can't change reference frames. I've been asking for an equation that shows that when you introduce a medium, that there will be no angle change. There's not a single equation on this earth that will produce that for them.
Yeah, I noticed he tried to invoke the Lorentz transformation, but that doesn't negate, like you pointed out, a refractive index in water. So how does he deal with that? That the transformation doesn't negate that, and he still has to deal with velocity differences with supposed moving reference frame.
So the one iteration of the transformation he was trying to do, because he went over like 3 different arguments, but one of the transformations would have been a velocity vector summation, where he's assuming the Earth's velocity in the x direction, and then he's transposing that into incoming light and making the Earth stationary, which could be a valid way to do it, but that would contradict aberration in air. If you're going to give the light the same velocity, then it's going to come in with no angle difference with Earth's velocity. So you're not going to have a ratio for the comparison. So it contradicts air right off the rip. But basically what they would do is they would say, okay, if we take the reference frame of the sun and we look at an observer on Earth, yeah, you would see the angle change to 27.5 arc seconds. But because you're in the frame, you can't tell the relative motion, blah, 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 right? Now, that's not, that's again an untenable position, because we have aberration in air. You can't have one and not the other. Every solution other than the classical derivation, showing that there's no angle change, makes the wrong prediction. So like the implication is just that the Earth is stationary. You can't get around it, because you'll if trying to use aberration in air as substantiation that the Earth is in motion, and it contradicts all other uh, math when they added the water. They can't have it both ways, so just leads to contradictions, which is what we're dealing with now.
Definitely agree with you there. I think Sacred puts it like succinctly, and I like that. It is, how does starlight slow in water yet accelerate to stay centered in the water field's telescope? I mean, it's a simple question, and they're going to have to invoke their magical reference frames. So it just puts that to the listener's ear, and hopefully there's a light bulb that goes off. Like, wait a minute, reality doesn't care what reference frame you're you're looking from, but
Exactly, right. And the key point on that is that it's really interesting how, going back to when Witsit was on with Tim Pool and that guy's, what's his name, Astronomy Live, was like, the water's not sentient, it doesn't know, right? But it's like their claim is actually that the water is sentient and it's carrying it in the opposite direction of motion. Like, unironically, that is their position. And we had to go on like a 4-month back and forth with Franco to get there, to realize that physics hasn't advanced on this in over 100 years. He gave mathematically the same inadequate explanation that was originally proposed, and is now has to carry on without saying it directly out loud that the light is being carried in the opposite direction of motion to give a null.
Yeah, I like how you hold him to his feet to the fire. So what does that entail? That, and then he just, like I said, he won't lie. He won't always tell the truth, but he won't lie. So he just bails on the conversation. But anyway, thanks for the answers to the question, bro. That was awesome.
Yeah, no worries. There's actually going to be a podcast that I recorded with Kat where we go over like a recap of it, following that AI summary that was done. I thought that was a really nice way to like relay the key points and go over it. But the AI summary was kind of off on some of the key stuff, so we wanted to do a correct version. That'll be coming out soon. I'm working on editing the video for that now.
An Alan and Kat podcast coming? Oh, this is gonna be fire.
A cat cast, if you will.
That was fun to do. It definitely was an interesting conversation to follow. So, and when Mr. Xavier asked a minute ago, I was like, hey, that was my question.
Yeah, it was hard to follow, cycling through 3 different arguments and all the gaslighting. And then, like, 3 months into the conversation, he was like, yo, I finally read the paper. You were right about Snell's law. Like, okay, dude. Thanks. And then we got Hap, who shows up every week to be like, the aberration in air is the same as in water. Airy measured aberration, the Earth is in motion. And it's like, oh, you sweet baby boy. Is he?
Yeah. I sent him a mic request. I figured he's going to come up here and school us.
Dude, Hap.
Show us where all that.
Hap. Where is he at? I do not see him.
Oh, he was
Yeah.
down. Sent him a mic request. Did he leave? He didn't leave. No way he left.
He
Well-
left. You opened your mic and he ran away. Hey, unrelated. Tim Pool posted something yesterday. He posted a survey and he asked, "Where should I move?" And there were 4 answers, and somebody just responded, "Israel."
Who wasn't
Nice.
thinking Israel, man? Seriously.
I heard
Thinking
Izzy's nice this time of year.
I mean, all that beanie is a really large yarmulke.
Yeah, it's been shrinking too. It's been shrinking too. It really is.
Some say a
What do they call that,
beanie
a
is just a
kippah?
large yami.
Yeah, it's my really warm kippah.
A yarmulke is just a tiny hijab.
Never heard it put like that, but yep.
Man, I can't believe Hap up and left.
Dude, so
He's
check this out. Hap shows up every week, right? And he's like, he links this quote that says that the aberration received is the same as the nautical aberration, right? So what he's saying is that the aberration in air is the same as the aberration in water. And he's like, he thinks that that is confirmation of the Earth being in motion, as if he's completely unaware that if the angles are the same, then that immediately implies that the Earth is stationary and the starlight already comes in at that angle. It's so bizarre, dude. When I started the space earlier, right, that was the first thing he posted, a big screenshot of that, and it was like, he's like, look how stationary the Earth is, Alan. I'm like, right on, brother, right on.
I don't know why it's so hard to get that through his head. I mean, they had to tilt the telescope to begin with. Seriously.
Yeah, well, to be clear for like accuracy, they didn't ever tilt the telescope, but the expected position is always off from what it should be, or like, from their idealized position. When they look at it, it's never in the center. It's always off a little bit, but they don't actually tilt it.
Are we 100% sure they didn't mean to put water into a kaleidoscope? I mean, it's still a scope. Like, at this point, it makes about as much sense.
Yeah. Yeah, there he is. Yo, Hap.
Yo.
Yo, 1 second. Let me reconnect here. The audio did the thing as soon as you spoke. Mute. Connect. All right, Hap. Been listening in? You know my position? What do you got? Hello?
You there, Hap?
Yeah, I'm here.
Can you hear Alan?
Say something, Alan.
Testing 1 2. Testing 1 2.
Yeah, I got you, Alan. So do me a favor. Well, I mean, if you want to talk, I guess you do. You asked me to.
Yeah.
And that I know nothing about aberration. Explain to me what aberration is in air. Why do you say in air?
Aberration in air is using they're not using a different velocity for the speed of light. They're using the vacuum speed.
Okay. And that's how light from the star arrives to us at a deflection angle, yes?
Comes in with a horizontal drift, yeah.
No, it's not a horizontal drift. It just comes in at a different angle.
Comes in parallel to the telescope, but it's always off center.
A telescope in space, so you're still in the vacuum. Assume that's possible.
Okay, sure. Okay.
Well, aberration is all you have to do is tilt the telescope away from the star's actual position in order to center the star, because it's coming in at a deflection angle because of the proposed motion of the Earth. Yes?
Yeah, I will acknowledge that. If you will not acknowledge the equivalence of the Earth could be stationary and the starlight could be coming in due to the angle of it being apparent already.
What you mean? Why would it have a different position in space if Earth isn't moving?
Because the sky would be rotating above us, it would create the same thing, and that's flat or globe. Like that's model. That's not dependent on how we're conceptualizing it. For our intents and purposes of the conversation, we can continue assuming globe, and then sky moving around us. Did you understand that there would be an equivalence between the two?
I used to do planetarium shows for people, and one way to make them understand it better is to say we live inside a giant beach ball, and
Yep.
the beach ball's rotating around us, and all the stars are painted on it. So yes, there's an equivalence.
Okay, cool. Okay, perfect. Yeah. So yeah, we could go either way with the aberration that's measured, right, in air, because there's no.
Yes, there's a motion that's causing the
Aberration, yes.
angle of aberration deflection. The aberration, yes.
Yes, sir.
Now, when the starlight enters air, it doesn't really change the aberration. There may be refraction from being in a different medium, yes?
Possible, but I would say it's very slight. I think we have the exact figures from the early 1800s when they first figured out how they could use an interferometer to measure the differences in air versus moist air. You know what I'm talking about? With Fazal and Foucault and all that.
That'll change the refractive index.
Yeah. The index at your vertical, like 90 degrees, is way less, and I don't remember the specifics on it, but it's pretty negligible. I agree that there is some, yeah. Hello? Are you there, Hap?
Yeah, I've got you, Alan, but I don't hear Hap.
Okay. I was worried that power went out or something again.
I don't even see. I see Hap down as a listener right now.
One sec. Let me refresh.
I see him as a speaker. I might want to pop in real quick too. I don't know. No, he's down now.
Testing 1, 2.
Yeah, we got you. Brian is always super quick, dude. He sees people drop out faster than anybody. He's like, nah, he's a listener. I'm like, dude, I see his mic open. Nah, he's gone.
All right.
Well, hopefully he comes back up. I just want to say this real quick while we're waiting on him. One of the things I appreciate about the way that you approach stuff, Alan, is saying, okay, well, for all intents and purposes, the conversation, I'm willing to throw it out here. It doesn't matter whether it's flat or globe, but we're gonna assume globe for you because it's gonna turn out the same way either way. Presenting things like that, I don't know, man. Presenting things like that, I think for people listening is important, but also for somebody that's quote unquote trying to debate you, I think that it's good to put them in a place where they feel a little bit more comfortable. I don't know. Ari's back up.
Yep. Welcome back, Hap. Thank you, Orwellian. Let me refresh again real quick. It started doing the audio thing. This is freaking insane. All right, I'm back. Okay, Hap, where were we? We were at the equivalence between the two systems for aberration. So we have aberration could be air or could be motion of the sky, could be motion of the earth through the sky.
Wait, you brought in air again. I don't understand why you keep bringing in air.
Oh, because that's what we were starting with for the original premise, and then you disconnected.
Yeah, okay.
We were talking aberration, just like the normal measurement.
But the angular deflection from aberration is due either to the beach ball spinning around an observer at the center or the Earth spinning.
Sure.
It has nothing to do with air.
Right. But when we introduce a different medium, right, we're going to be able to manipulate one of the variables that we're using as a ratio to derive how much the angle should be to correspond to the velocity.
That's assuming. Yeah. Okay. So did you ever hear that example by Paizo about dropping balls into a moving or into a moving garbage can?
Yeah.
Okay. So that's my model of light and capturing it in the telescope. And I'm perfectly willing to hear why you think, in the case of the garbage can, and you'll probably agree with me on the garbage can, and you'll say that light should be dragged by a moving reference frame. But let's do the garbage can first. If I have a moving garbage can and I'm dropping in a horizontal plane, I'm dropping balls that are moving at the same rate as the garbage can, the balls will drop right down to the middle of the garbage can. Yes? Now, if I fill the garbage can up with water, when the ball hits the top of the water and slows down because of the water, the ball's not going to be deflected because the garbage can is already moving. The horizontal movement of the balls has been eliminated because I'm moving the garbage can at the same speed. So slowing the ball dropping through the garbage can won't affect.
Yo, Hap, your mic cut out for me. I'm gonna reconnect real quick. I can't hear you. Testing 1, 2. Can you speak, Hap? Oh,
Just
lost
show
him.
this to me.
I think it's Hap, not you, Alan. Honestly, I think Hap.
Yeah, I think so too. Yeah.
That's okay. Twitter's being really lame tonight. I keep getting the audio thing where it'll randomly just start echoing when people talk.
Yeah, I was also going to say Elon apparently doesn't want this conversation to happen.
Yeah, he doesn't.
No, he definitely doesn't. But yeah, I think that I think it's on. I don't know if you got an unstable connection or what the deal is, Hap, but yeah, sort it out, man, because we're all in here waiting with bated breath to hear this out. So please
Yeah, you
fix it.
might just need to exit the app, refresh it, and come back in. Solves the problem a lot of times.
Yeah. Good shout out to Hap. Oh, there he is. I see him. Let's see if I can get him back up. Shout out to Hap though for coming up. He does at least do that.
He does do that. Sometimes.
Who else is in here? I see Peter down there. I see, I think, Galatrax.
Got Mystere down there.
What's up, Mr. Luke from Australia, my brother. Shout out to Luke. Still living under tyranny. Still kicking. Love that guy.
He's upside down, but he's all right.
Yeah, I mean his turds swirl the opposite direction of mine, but we're still human, so.
A good book on physics, Jane Evelyn asks. I would recommend what was that one we read for kinematics? That was a great introduction.
Anybody there?
Yo, what's up,
Yo.
Hap? Welcome back, sir.
Back for a minute. Garbage can. Shall we go?
Yes, let me reiterate. So you were saying that you got a moving garbage can, right? And you not filled with anything yet, and it's moving at some velocity, and you're going to drop a ball in the center of it. So you have to account for the timing difference when you release, and you're going to hit the center of the moving trash can, right? And then when you said you add a medium, you're going to do the same thing, and you're not going to have to account for any timing difference because it's going to be carried with it, essentially, right? Is that what you're saying?
Well, no, I wasn't saying timing differences. What you do is you just make sure the balls you're dropping and the garbage can have the same horizontal velocity. So the horizontal velocity component is canceled out.
Oh, so you're canceling out the timing difference by adding horizontal velocity to it. Okay. So if you were to do that, then you wouldn't have an initial angle change to begin with or aberration. The incoming light velocity is the same as Earth's velocity, then there's going to be no change. You won't have aberration.
No, I'm not saying Earth velocity. Let's go back to the garbage can. So since the ball,
it's analogous. Like I get what you're saying. It's analogous,
But
so
you-
we could go either one. They're interchangeable. The trash can is the Earth. The ball is the starlight. Or this analogy is directly interchangeable.
Did we lose him again?
Possibly. Yes.
Man,
Yeah, he's out. I saw him that, like, I don't know. The fucking app's acting weird. I saw his mic open and then him just go flatline. So yeah, it's not you, Alan. It's definitely on apps then.
glad to see it happens to other people other than me. That's all.
Oh, hold on. Leave a spot open for Hap to come back. I think we're almost full. Okay, we got 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we can have like 2 more, but leave one open for Hap.
I like that Hap acknowledged the equivalence earlier, because now, before he cut out, I was interesting to see would he acknowledge that you could just treat it as stationary with this garbage can example. I mean, you would have to. You acknowledged it earlier. I would, hopefully he doesn't double speak, but these technical difficulties are convenient for him right now.
Yeah, they are. It's time to regroup, right? He can double back and check his notes and shit, right? Maybe run this back real quick if he's recording it on his own, like that type of shit. But again, shout out to Alan for going, look, bro, like there's an equivalence here. So what's the deal?
And right when he gets asked, is like that's when I was like, I'm over here kind of listening and scrolling the time. Like, did he? Oh, he dropped out again, huh? Okay.
I wouldn't go as far as to say that he's dropping out on purpose.
I wouldn't say that.
No, definitely not.
No, I'm not. I think he's definitely having technical difficulties. I'm
All right.
giving him credit where credit's due. Yazo's up in the room. What's up, bro? I ain't heard
What
from you in a
up,
fucking minute.
Yazo?
What's up? I'm just walking my dog. I was hearing that happening there, and I'm like, wait. So he's admitting that we're just going to arbitrarily apply the same horizontal velocity to the light ball as we do to the telescope Earth trash can, right? Well, Alan was perfectly correct. He said, well, if that was the case, we were just able to do that, then there wouldn't be aberration to begin with. There wouldn't be aberration in air. Like, not to mention that's already granting them the ability to do that. How do you, by what mechanism do you just add 60-something thousand miles an hour to the ball? You know, like, it doesn't, it's non-mechanistic, it's non-physical. It's just, you're postulating if you do this, you can explain it. Okay, that's a big if statement. Why would you do that? How would you do that? And then even if you did, you wouldn't have aberration.
Yep. Welcome back, Hap.
We'll see how long I last this time.
Inshallah,
So-
it's longer than 30 seconds.
Well, what's interesting is the last time I dropped out, I checked the speakers and there were no speakers at all. So all the speakers from my end look like they all dropped out. And yet there are 10 there now. But anyway,
Yeah.
I don't know what that means. So you keep bringing up a timing difference with the garbage can example. There's no timing difference. It's only about the horizontal
Okay.
component of velocity.
Well, let me ask you this,
Yeah.
Hap, real quick. Okay, so suppose you don't add a horizontal velocity component to it and you're trying to drop the ball in the center of it as the trash can moves out from underneath you. Now, you want the ball to hit the center of the trash can, right? You have to do what when you drop the ball? You have to make a judgment on what time you're going to release it so that the velocity of the ball as it falls down meets the center of the trash can as it moves through. So by you adding a velocity component to cancel out that effect, like I see what you mean, or like, you know, how you're trying to assert it, but you understand that that's exactly like the equivalence of what you're doing is the same thing, right?
God damn it. You just left.
Can you hear me?
You just cut out in the middle of a sentence.
Can you
Was
hear
it?
Al?
Bet you can't hear me.
No, I can hear you now. What was the last thing you heard?
Everything's gone.
Can you
No
hear?
sound at all.
You can't hear Alan?
Huh.
Can
Drop
you hear
him
me?
down. I'm going to
Can
drop
you
him
hear
down.
me, Hap?
Oh my goodness.
Hello.
I can hear you. I
Yeah.
can hear Alan, so everybody can hear. We can hear
I
each
can hear
other.
everybody.
Here, I'm bringing.
Yeah, again, I can hear everybody. It's just, again, more evidence. Hap's having some problems.
Yeah, I dropped
Man, they
him
didn't
down
do
and
any
I'm
of
trying to
this
bring
on
him
the
back
moon,
up.
I just can't believe this didn't happen on the moon.
Wired telephone call to the moon, with the picture already hanging behind him while he's talking, talking to them with people.
With a picture of the boys on the
Nothing
moon.
to see there walking on the moon. The symbolism will be their downfall at some point. But yeah, it's happened. I'm eager to actually hear this
Yeah.
come to
Well,
its fruition. And for some odd reason, like Hap's technical difficulties don't seem to want to allow that to happen.
Can I ask a quick question?
absolutely. What's up?
Well, what is the point of? I checked out on Grok on Ether Cosmology. What are you hoping to try to achieve here? Is this an intellectual debate, and for what purpose, if I may ask?
Yeah, it's a discussion on modern cosmology and the evidences for or against current interpretations. So one being heliocentrism, that the idea that the Earth is in motion around the sun. Right now we're discussing mutually exclusive evidence in the form of the change of an angle of stars in the sky when you add water looking through a telescope to substantiate whether or not the Earth is in motion.
And what is this going to do for me if I know the answer? And I don't mean to be sarcastic. I'm working on my own. I'm working on
Well-
my own book, Sacred Metaphysics. I'm also now going to write a paper on AI totalitarianism, which this week came into my mind, totalitarianism. So I did some research that I've done 3 years ago, and it seems that's the anyway. There's some real. Actually,
Sure.
I typed it in Grok and AI totalitarianism came up, and kind of you can almost check all the boxes. So I can imagine where we're going to be in the next 2 to 110 years. But I want to stay on topic here, so I'm just trying to figure out if I listen to this, what am I going to learn?
Yeah, so you're going to see the implication of current cosmology and everyone, you know, adhering to the idea that the Earth moves around the sun and all the equations that describe the motions of the heavenly bodies, being Kepler's laws and Newtonian dynamics as applied to the sky. You're going to see that those are physically meaningless, and an entire religion has been constructed around the mathematics to support ratios of movement of the sky to assert, you know, dominance over how you think and conceptualize the bodies in the sky. And what you'll get out of this is you will see that, you know, you're going to have to interpret things for yourself, and what you've been given, what's been handed down to you, has a certain philosophical bias to it and has no physical connection to what you would call measurable reality, right? You can certainly watch things in the sky and produce ratios for predictions for when they'll return to their original position that you started with, but no one has any idea why they actually move, how much they weigh, what they're made out of, or anything like that. And the whole paradigm falls apart with water and a telescope. And when you go through this argumentation, what you're going to see is that the answers that they gave 100 years ago that were completely insufficient to keep the idea that the Earth is in motion after they added water to the telescope, you're going to see that there's no advancement. And Why?
Okay. All right. Well, first of all, everything is an illusion if you study the Vedas. I mean, if you look at the absolute and the relative, is everything in the material world is just relative. It's subjective. It's there's a yeah. So see, I've actually writing on the logos, which is the absolute, objective, eternal truth, which always leads to God. So my premise I'm working on, and I'll stop right there, is if God exists, God would be the universal God of every
Yeah.
soul in time and space. So I'm interested in this. I don't want to get away from your subject, but it seems like all metaphysics, you're going to go in circles. And I've been through a lot of those, and I don't see any. Anyway, I'll listen. I listen. You got a great vocabulary, brother. I congratulate you on that. Even I didn't follow. I did and I didn't. It's not my thing, but I'll listen for a while as long as there's some intellect. Do you know 53% of Americans can't read at the grade 6 and lower levels? Only 14% of Americans actually can read at a grade 9 level. So this is way beyond all Americans. All right. So, and that number also expands into, I'm from Canada. It's globally. So can imagine 53%. And when you discuss with people about reading, they say you don't have to read, which leads you to a whole other thing. But
Yeah.
God bless you, brother. God bless you, and everyone else in the room.
You too, man. And I don't mean to cut you off, but we'll definitely come back to you. But Hap, welcome back.
Okay, can you hear me?
Yes, sir.
I'm on a different device.
Nice. Hopefully this one works out better. All right. So where were we, Hap? We were discussing the timing difference and how to account for that. And I was telling you that there was, if we treat the trash can as, if we don't add a velocity component to the ball as we drop it and we just have the trash can moving out from underneath us, you're going to have to account for when the best possible time would be to release the ball so that by the time it gets to the bottom of the trash can, it'll be in the center. So you're going to kind of have to judge out the ratio of when you're going to do that. So that's the timing difference, right? But when you add the horizontal velocity component to the ball, you're doing the same thing. So like when you say that you're not accounting for it, correct, you're not accounting for a timing difference of when to drop it, but you've added the difference of what it would have to be in the velocity component horizontally so that it'll work out. So you would be canceling out the effect of any sort of deviation between the relative motion between the two. So you wouldn't have any aberration. He definitely cut out again, didn't he? Is anyone there?
I hear you. Are you there, Alan?
All right, I'm back. I can hear you guys now. Man, this is a nightmare tonight.
What
All
the
right.
hell?
Can you hear me, Hap?
Yes.
Oh, okay. Welcome
So
back. Did you hear my recap
Did
of
you
your
hear me
position?
talk about the axis of the garbage can, not just the bottom and the center of the garbage can?
Nobody heard anything each other said, guys. Got to start over.
Okay. All right. No, we didn't hear any of that. Let me start over and then you do yours. Okay. So what you were saying is that there's no timing difference required, right? And I'm saying that when you add the horizontal velocity component to not consciously account for the timing difference, you're accounting for the timing difference because you're canceling out that effect, right? So the equivalence there is the same. And then, so you would be canceling out, your position would be that there is no aberration in air because the timing difference between the light coming in for the moving object would be the same because the light also has the same horizontal component to it.
I don't think that's what I was saying. Or that's what I was trying to say. What I was trying to say is in order to get the tennis ball to drop down the axis of symmetry of the garbage can, not just hit the center at the bottom, but down the axis. There's no timing involved with that. The only thing that's involved with that is making sure the garbage can is moving at the same rate as the ball you drop, horizontal component. Now, if you want to do the timing difference, you could tilt the garbage can so the tennis ball goes right down the center, down the axis, the center of axis of the garbage can. So there's no timing there. You either tilt it, the garbage can, so the ball goes right down the center from the top of the garbage can right down to the bottom, or you cancel out the horizontal component so that they're going the same speed. And again, the tennis ball with respect to the garbage can has no horizontal component.
Okay.
And if you tilt the garbage can, you have to, do the horizontal component of velocity perpendicular to the center axis of the garbage can. Am I making any sense at all saying that? I know what I'm trying to say.
Absolutely. Let me ask you this.
Thank you.
So, suppose we don't have a horizontal component for the ball, but we got the moving trash can, and we drop the ball, right? It's not going to be at the axis of symmetry or hit the center of the trash can unless we account for a timing difference because we don't have the horizontal velocity, right?
But how is the timing difference going to make a difference there? I would say if you tilt the garbage can, you can get it to go right down the center from top to bottom.
That's the same position that I'm saying, right? There's still a timing difference. No matter how you account for it, that's what's being accounted for. So if you're attributing a horizontal velocity component to say that you don't have to account for the timing difference, then you're just making it match to cancel out accounting for it.
Okay, but for the garbage can,
but that's accounting for the same effect, right? Because like we just said, if you don't do that, it's not going to be in the center when you just drop it normally.
Okay, and what do you mean when you say center?
The axis of symmetry, the dead center of the trash can.
Okay, so if I've got a tennis ball and I'm dropping it straight down, and there's a difference in velocity between the two of those objects, the tennis ball and the garbage can, there's no way to adjust the timing such that the ball will drop down the axis of symmetry of the garbage can.
Yeah, when I say, I see the point of confusion.
Okay, good.
When I say account for a timing difference, I mean when you release the ball. That would be equivalent to adding a horizontal velocity component, because when you release the ball, based on how fast it takes to hit the center, is going to be a ratio of how fast it, or you're going to have to account for the velocity of the trash can. So that timing offset for when you release it is going to be quote unquote accounting for the timing difference. That's what I mean by that.
Okay, but you do agree that there's no way, unless I tilt the garbage can, that the tennis ball is going to go down the axis of symmetry by adjusting the timing?
Oh, absolutely not. Those wouldn't be mutually exclusive, and you agreed to that earlier between the equivalents, right? Because one would be the starlight's already coming in at that angle, and the other one.
Yeah, but I'm talking garbage cans. I don't want to talk about stars yet. I'm talking garbage cans. Just understand that example.
No, I do completely understand it. And like I said earlier, your analogy is entirely analogous, where the trash can would be the earth and the starlight would be the ball. So it's entirely analogous either way. Any way we play this out, we're already there. We're already discussing it at the same time simultaneously. The analogy is 1-to-1.
But you keep talking about a timing difference, and that doesn't apply to the garbage can.
Oh, it absolutely does. You could apply it for tilting it, like you were saying, if the garbage can is the thing in motion.
Tilting it isn't a timing difference. If I don't tilt it, there's no timing difference I can make to get the ball go down the axis of symmetry of the garbage can. Can't do it because there's a horizontal component of velocity that's different between the ball and the garbage can. So there's no timing difference I can make
You
to get the
already,
ball.
that would be the way that you would correct it. If you're not going to add a horizontal velocity component, but you're going to say that the Earth is in motion, or that the trash can is in motion, rather, you would have to tilt it. That is accounting for it,
Yes, you
which you
have to
already,
tilt it, but
which
there's
you,
no timing difference there.
dude,
The timing doesn't matter.
dude, that is accounting for it on the reverse end of what it would be when you time it to drop it. The equivalence there, which you already agreed to. We're on the same
Okay,
page.
sure. I'm assuming that you don't have to worry about the timing. You know you're a second above the garbage can, so you always drop it a second before you want it to hit the garbage can. But as far as the garbage can and the tennis ball goes, there's no timing other than, yeah, you got to synchronize it so that it hits the top of the garbage can in the center. But unless you account for the difference in horizontal velocity between the tennis ball and the garbage can, there's no way you can get it to go down the center of the garbage can with a timing difference, unless you tilt the garbage can.
No, not if you account for it when you release it. That's the equivalence between the two. You can't deny one and say the other is mutually exclusive. Now, what we really need to do, though, right, is now that we're in agreement on velocity component exchanges, right now we need to introduce a medium to have manipulate the actual timing difference in a way that isn't a tilt angle or assuming that there's a change in the release timing, right? So can we add water to the trash can yet?
Can we forget about aberration for a minute and starlight and velocity equivalences and just go back to the garbage can? Because I'm clearly not explaining it to you the way I understand it. And there's no point in going on unless you understand my garbage can example. There's no timing that I can do to make the tennis ball drop down the center, the axis of symmetry of the garbage can, if there's a difference in the horizontal velocity. Can't do it.
You already agreed that it is when we were talking about aberration. And the analogy that you're using is analogous to aberration. So you can't turn around and have it one way, but then trash can out of it. Hello? Are you there, Hap?
Shows down to the listener again.
Son of a gun.
Man, I tell you. I don't know if he just left again. Maybe he's trying to refresh again. I just sent him another invite.
Dude, I don't know what's going on or who's saying what, but I heard that you can't trash can out of this, and then I heard a defiance, and then I heard nothing for a long time. So I don't know. Like, is that what the sound of trash canning out of something sounds like, or is there more to it
No,
going on?
no, he's having connectivity issues.
So is he trying to make the trash can, the telescope, and the ball starlight?
Yes,
And
that is the analogy.
that's that's what I figured. And he's saying as he drops the ball, the trash can's already moving. Is that what he's saying? Because that's why it's hitting the center. And he's somehow that's I don't see how that's is. Are we going with the atmosphere?
He's saying
Right in my back.
He's saying if you add the equivalent velocity that the trash can has to the ball, that you wouldn't have to account for any difference. But anyway, he's back real quick. Yo, what's up, Hap? Welcome back.
Hi. Yeah. Can we just talk about the garbage can and not go?
Sure.
Man, I think we lost him again. Unless it's me.
Dude, no way we lost him 2 seconds into his sentence.
2 seconds, man. I heard
Jesus,
it
man.
It was a hard click off too. It was like
I hope he's not still talking.
He could be. Hey, Hap, he got dropped again. Just remember, it's your satellites up there doing it, not us.
Well, while he's sorting out his microphone situation, I'm going to go grab some water. Shane and co, you guys take over for a second.
Roger.
You want to go and tempt some other people to step up? Do we have enough people to be antagonistic yet? What do you guys think? I saw Piezo up here. Does that mean you're ready to defend some stuff? Like, if I lay some shit down, Piezo, and I get myself into trouble, you wouldn't come and back me up?
I mean,
take that as a yes.
Who's down there? Is anybody good down there?
No, but
you guys hear me?
Hey, nice. There he is.
Yeah, I was just gonna say we need a. Sorry, real quick. I was just gonna say we need a strawman or someone assume the position.
Yeah, so I saw the confusion that was happening, and I had the answer to clarify it, but I realized what was happening, but I was on my phone, so I had to get to my PC before I could come in here and like speak. But basically, what Hap has been trying to say, and this is the disconnect. Hap was basically like getting stuck on a point, which he was correct about this point, by the way, but it wasn't the point of contention. It was just an adjacent point. His point was that unless you sync up the speed with the ball moves sideways and the trash can moves sideways, unless you sync those up, if those are different, you'll never be able to get the ball to hit the center of the trash can unless you drop it early or unless you tilt it, right? And he's correct about that. See, remember, we're presuming that the ball is entering the far end of the trash can in the center, right? So that's equivalent to the telescope being pointed right at the star. So the ball enters the trash can in the center, and we want it to land in the center, right? So in order to do that, if the trash can's moving, you have to tilt the telescope. So about that part, Hap is correct. Now, that doesn't matter though, because when Alan says the word timing difference, whenever you hear him saying that, Hap, when he says the phrase timing difference, what he's speaking about, he's specifically meaning a timing difference between let's say 1 second. Let's start with 1 second. Let's say it takes 1 second for the trash can to go from the top end of the trash can to the bottom, for the tennis ball rather. So it takes 1 second for ball to fall from top to bottom.
Well, real quick, wouldn't it be though the if the ball is the starlight, it's already coming down, and we're basically adjusting the trash can to the ball at this point, aren't we?
Yeah, hold on. So we're saying that we're treating the star as at the zenith. So we're saying that the star is 90 degrees above, right? If it's not 90 degrees, we have to make small minor adjustments for ease of our conversation. We're treating it as 90, okay? So it's coming straight down. Now, when it comes straight down, okay, it's going to have, and the trash can's moving, If the ball enters in the center, it's not gonna land in the center at the bottom. It's gonna land slightly off center because by the time it gets to the bottom, the trash can will have moved out from under it. But anyways, I've already explained that. When I was talking about timing difference, okay, I'm assuming Hap's still there. When he says timing difference, we're talking about going from the original 1 second, right, in air. It takes 1 second, let's say, to fall through the trash can in air. When you add the water, it now takes 1.333 seconds, right? It goes from 1 second to 1 1/3 seconds. So that extra 1/3 of a second, that's the timing difference he's speaking about. So since there's an extra 1/3 of a second, that trash can will slide out from under the tennis ball an extra amount, which will require an extra amount of tilt to get it to fall in the center. That's our whole point. So I hope that that's clear enough for you to understand what the distinction is that we're making when we talk about a timing difference.
Yes, I understand that.
Okay, so you understand that when you add the extra window of time for the ball to fall, it also creates an extra horizontal distance traveled, which creates an extra angle.
Yes, but my garbage can example, I'm saying you have eliminated the difference in horizontal velocity component of the ball and the trash can. So we're not talking about tilt now. We're just talking about having the garbage can and the tennis ball at the same speed. If you eliminate the horizontal component of velocity, it doesn't matter how fast the tennis ball is traveling through the garbage can or whether it changes its vertical speed because of water or whatever. It will still drop directly down the center of the garbage can because there's no horizontal component of velocity difference.
I agree, Hap, but what you're talking about here is simply a thought experiment. That has no bearing on reality because we know, right, if we take the heliocentric position and we say 66.6 thousand miles an hour.
So can anybody speak so I know I'm still here?
Hap, you were hearing me
a
just
single
now.
word?
Can you hear me?
Can you not
anything?
Can you not hear piezo, Hap?
A cough?
Yeah,
a
I'll
sneeze?
All right.
Why is he bugging so much?
I don't know. I dropped him down. I'll bring him back up.
My goodness.
Dude,
Maybe he needs to
everyone bugs
restart his browser or something.
Maybe everyone bugs in a different way, dude. I go tinny all the time, and I just accept it now like a chump. So maybe everyone else has their own struggles or whatever.
Yeah, I've had to reset about 48 times since we went live, so I'm not gonna.
Oh, wow.
Yeah, not gonna judge the man.
But hopefully he can hear from the listener section right now while he's waiting to get brought back up. So the answer, Hap, is that what you're doing, I agree with you. If the ball was moving sideways and the trash can were moving sideways at the same speed, it wouldn't matter if it took 1 second or a million years to fall to the bottom of the trash can. It would always fall in the center. We're in agreement. But the problem with speaking about that, with even bringing it up, is all you're doing is bringing up a thought experiment, right? Because we know in reality, if we presume the heliocentric model to be true, that the Earth is moving sideways with a very specific velocity, which is 30 kilometers a second, roughly 67,000 miles an hour. Now, the light is coming straight towards us from a star. It's not coming straight towards us and sideways. It's just shooting from star to us, right? There's like a radial cone of infinitely many photon streams all traveling in straight lines outwards. We encounter the end of our telescope encounters one of those photon streams, right, traveling straight down. And at the moment it encounters the top of the telescope, that's like the ball entering the trash can. So there's no physical mechanism that can be invoked to say, oh, we're just going to take that 67,000 miles an hour sideways and we're going to add it to the photons. Like that doesn't work, right? That specifically, if that was the case, there would not be any aberration to begin with, right? We would just be able to point straight at stars, and some magical, unforeknown effect that automatically applies 67,000 miles an hour sideways to the light would apply to all the light coming in, and we would just point straight at stars, and we'd see true positions all the time. But that's not what happens, right? We know aberration's a thing. It's actually a phenomenon. It exists. So if you want to maintain a paradigm which allows aberration to happen, you can't just say that, oh, let's just cause the photons to also have sideways velocity that matches Earth's. So there has to be another explanation for it. You would have to have another mechanism to cause it to fall to the center. Now, it just so happens we do have another mechanism to cause it to fall to the center. It's tilting the trash can or tilting the telescope, because since there is a horizontal velocity difference between the trash can and the tennis ball, or between the Earth telescope and the starlight, that will create that angle, because now you can tilt, depending on how fast that trash can's moving sideways, you can tilt it a certain amount that will match the time it takes for the ball to fall through, and that will give you a centered tennis ball. But when you change the timing from 1 second to 1 1/3 second by adding aberration angle formula, by the way, that's the formula that we use to predict aberration. So that formula correctly predicts it. It predicts the tilt, and it's based on the two speeds, the two velocities. Now, our position, as I'm sure you know, but I want to clearly restate it, is by adding the water, you add more time for the light to get through the telescope, and since it's taken longer to get through it, the Earth is spinning longer going sideways, and it shifts out from under the telescope more and more, requiring more and more tilt. That is mathematically required. We presume the same cause, the same effect, the same mechanism, and the same formula to predict it, to calculate it. And when we do so, we go from about 20 arc seconds to close to 27 arc seconds on our angle. When Airy performed his experiment to take these measurements to see if he could demonstrate it, he found that he could not, and he received the same measurements with the water in the telescope as without. This is why it's so destructive to the heliocentric paradigm, because one must needs tilt the telescope in water if there is a velocity component to the Earth. The only way that the angle would not change would be if that horizontal velocity was not that of the Earth, but it was that of the starlight. Because if it was that of the starlight and the starlight was already coming in at an angle, it would not matter how long it took, because it gets slowed down in all directions when it moves through that water. So since it's getting slowed down at the same proportional ratio as it's coming in at this angle, it's still going to hit at the same spot. This is why the only position that can correctly predict no angle change when water is added is that in which the Earth telescope system is in fact stationary. The dynamic asymmetry from the water proves this unequivocally. But that's our position.
Well said. Well said. And also, right, if you were to use the V over C ratio for the velocity of Earth and the aberration and attribute that, right, and then also do the same thing in water and say, produces no change, well, then you would have an absolute velocity. Well, even if you don't do it in water, but just having it in general for in air, they're using that as an absolute velocity. And in the relativistic paradigm, that's not even supposed to be possible. So like they should always inherently acknowledge the equivalence between the two at the very least, that the starlight would have a horizontal velocity component. But when you add the water, like it ruins everything because it shows that it's one way. But yeah, there we go. Welcome back, Hap.
Am I here?
Yep.
Wow. See how long I last this time. So my position is that with the garbage can, by setting up so the horizontal component is equalized, adding water, now it doesn't matter whether it takes a second or a million years to get to the bottom, it will go down.
And he's gone. Yo, peace be upon you, Hap. So unfortunate, man.
What's unfortunate? I had to step away for just a moment.
Oh, Hap's mic cut out 2 seconds into his explanation again.
My goodness, man, that's sad.
And
Hap, have you tried to actually completely close out your browser, clear the
bro,
cache, remove the cookies,
bro,
all
bro,
that?
bro, he's tried everything. He's even tried different devices. It's not his fault. But yeah, it
Wow.
sucks.
Somebody else has a hand up or whatever.
Yeah, sorry, we're gonna have to. We can come back later, Hap, and try again. But the discontinuedness of the conversations kind of ruined the mood, if you know what I mean. But shout out to you for coming on. Much appreciated. We'll definitely continue it on. And if you want, what we can do is do a Discord call or something where you might have a more stable connection, and we could kind of go over this in detail so you can get your full position out. Yeah, anyway, what's up with our boy Jeff Shield over here?
Hey, Alan, how you doing?
Doing good.
Okay, to me, I'm not a scientist. I deductive reasoning, but it sounds like a Coriolis effect vertically. But what about the Red Bull drop? The guy took off from New Mexico, and several hours later, he still landed in New Mexico. Isn't that the same thing as dropping a ball in a garbage can, which is just like 2 feet away from you?
Yeah.
He went super.
Yeah, so like if you do the analogy right, where like you're attached to the system, or like we're like giving him like the maximum benefit of the doubt, where like, you would be disconnected from the ball drop situation, you know. But yeah, you're right. Shout out to Felix Baumgartner though. He ended up in the wrong direction too. Wasn't he off by like 30 miles in the wrong direction too?
He was off by an absolute shitload, and yeah, there's so many so many revelations that came from that quote unquote stratosphere jump. And I don't think I don't know, man. I don't think they intended for as many people to ask as many questions as they did. But there's many. There's so much wrong with that jump.
Yep.
I'm back on device number 1. I don't know how long this will last.
Welcome back. Try and send it. If it cuts out again, like we'll revisit this later, or we can do like a Discord call or something at another time, and we can do like a recording and get your full thing out.
I appreciate that. So my position is the equivalence between the garbage can and the tennis ball is making the horizontal speeds the same, and you'll get it down the center no matter how long it takes to go down the center of the garbage can. By tilting the telescope to meet the oncoming photons from the starlight, that eliminates the horizontal component of light. And so it doesn't matter any longer how long it takes the light to go down the center of the telescope. You've already accounted for the horizontal change in that light direction of approach by tilting the telescope. So you've eliminated the horizontal component of the light. And unless you want to say that the water in the telescope is dragging the light, it will still go down the center of the telescope because you've eliminated the aberration angle by tilting the telescope. In the title page of the Michelson-Morley paper, they talk about what a ridiculous idea that is, that all of a sudden the light will know, which way to drag the light to eliminate the fact that you slowed down the light. But they were talking there about ether when they thought ether was dragging the light. And that is not true. Ether doesn't drag the light. There is no ether. But yes.
Were you able to hear me when I gave my I actually answered this because this is what the
Well,
kind of
you
response you
answered
gave.
most of it, and I agreed with all of it. But what you're missing is that by tilting the telescope, you're eliminating the horizontal component of the light that's coming into the telescope. So since that horizontal light component is eliminated, just like in the garbage can, it doesn't matter how long it takes it to go through the telescope,
Yeah, so let me
unless
address
that's
that.
the ridiculous fact that the water's dragging the light. Go.
Yeah, let me address that point. Now, you would be correct if the only thing that was being measured was the aberration in air, because basically what tilting the telescope is doing, tilting the telescope is accounting for the velocity ratio or the differential between the tangent theta angle of the tilt will neutralize that velocity ratio to get you basically centered. But
Correct.
if you change that velocity ratio, it would change the tilt required to neutralize it. And so
In-
once you put because the angle is predicted by the ratio. So if you change either of the two velocities, you now have a new ratio.
Incorrect.
Bro, let me just use real basic numbers. We don't even have to use units. We'll just say that the vertical velocity is 1 and the horizontal velocity is 2. Okay? So it's 2 over 1. So you got 2 on the horizontal, 1 on the vertical. So we got 2 over 1. If I now make the vertical 2, we go from 2 over 1 to 2 over 2. That's now a new number. We now need a new angle.
You're missing a very important point. At the top of the telescope, when you've accounted for the velocity ratio to get the correct angle, you've already eliminated the vertical component of the velocity with respect to the telescope.
Okay, Hap.
So slowing down the light in the telescope doesn't change that V over C ratio, because you've already accounted for it and gotten a 0 horizontal velocity with respect to the telescope. So at that
That is
point,
incorrect.
okay, why?
Because I will answer your question why by pointing to the formula and asking you to use it. So, how do you know? What do I need to plug in to the formula to know how much to tilt the telescope? When I say tilt it by this angle to neutralize the velocities, how do I know how much to tilt it?
It's the ratio of velocities.
What are the two velocities?
Speed of light and motion of the garbage telescope.
So the speed of the tennis ball and the speed of the trash can, right?
Yes.
So if I change the speed of the tennis ball, I now have a new ratio, right?
Correct.
So therefore, I have a new angle.
Correct.
So that's why you would have to tilt it more.
No, because when you've tilted this telescope originally, you've already taken that velocity difference into account. When
The
you
velocity
say
difference in air.
In air.
Once you
In air.
change the velocity, you have a new velocity difference, therefore a new tilt.
Okay, so it's in air, right? So now you've tilted the telescope in air.
To match the velocity difference in air.
In air. So now you have in air, you have that the photon is going to go straight down the center of the telescope, right? In air.
But in air, yeah.
So you've tilted the telescope already to account for that velocity ratio difference.
Yes.
So now you have no horizontal component of the light as it goes through air right down the center of the telescope.
Now let's add water, since we accounted for the difference in air. Once we add the water, what happens?
Well, since there's no horizontal component of velocity with respect to the telescope, and you slow the light down, going down the center of the telescope, down the axis of symmetry of the telescope, unless you're going to say that the water is going to drag the
photon off of the center of axis, it's going to continue down the center of axis.
The tennis ball never had a horizontal component, Hap. The trash can did.
Correct. Well, the tennis ball and the garbage can didn't have a relative difference in the horizontal velocity. Yes.
The trash can was moving and the tennis sideways, and the tennis ball was moving vertically. The only thing moving sideways was the trash can.
The tennis ball also has a horizontal component of motion.
Do you really not see? Do you really not see that you are using the same formula in one way for air and in a different way for water? Like you're self-contradictory in this moment. Do you not understand that? I don't know if like you're purposely not realizing or if you actually don't see it.
I think he genuinely didn't see it until just now, bro. He just realized it right when you were going through the 1/2, 2/2.
Yeah.
No,
so the way that we know how much
Say
we have
it
to
out
tilt
loud,
it-
Hap.
Say it out loud. Sure. The way you know how much you have to tilt the telescope in order to have the light wave hit you vertically in air, perpendicularly in air, so it goes straight down the center of the telescope. You have to tilt the telescope based on the ratio of the speed of the telescope and the speed of light. Goes right down the center of the telescope. So now that it's going, say it goes halfway down the center of the telescope, right? And it hits water.
Yeah.
It's still, with respect to the telescope, the photon doesn't have a horizontal component with respect to the telescope.
Okay, let's try it this way.
So
So
slowing
maybe
the
this will
light
make you get it.
down isn't going to all of a sudden magically add a horizontal component to the photon any more than it does in the garbage can when the
okay,
tennis ball drops right down the center, halfway it hits water. But since the horizontal component's the same, it doesn't matter whether it takes a minute or a million minutes for it to reach the bottom of the trash can at the
This
center.
is incorrect, and
It's
I think
the
I have an
same
illustration
with
to show
light.
you why.
When you tilt the telescope, you're accounting for that angle that the aberration causes.
The original
The
one,
aberration
one.
occurs because of the difference in. So am I gone, or can anybody hear me?
No. You can you hear me?
So I'm gone again?
No, we can hear
Somebody
you.
say something.
We can
Cough,
hear
We
you.
can all hear
sneeze.
you.
Shit.
I have the illustration to make him understand. I'm just going to wait for him to get back up here so he can get it because he needs to hear this.
Yep.
He's dropping down.
I got you. I'm bringing him back up. We're trying to.
It sounds to me like he can't understand that the water slows down the light. Does he not?
Yeah.
Does he
So
not get that?
So you know how earlier he referred to Michelson stating that they have to make the absurd hypothesis to state that the water is being carried, or that the light is being carried, that the photon's being carried in the opposite direction of motion, right? He's literally doing that right now without saying it.
Well, it sounds like he's just using it at the first part of the experiment.
No, I have the illustration to show him like the problem here, but I want to wait for him to come back up to give it.
Yep, I got
I
you.
figured out where the disconnect is.
Well, while we're waiting, go ahead, Jeff.
Yeah, you guys are knowledgeable in science a lot. I feel like the Larson cartoon. Can I be excused? My brain is full. But I build swimming pools, and the refraction. I don't look at night, but when you lay in the bottom of a pool and look at the sun, it curves. It's distorted. So I don't even know why this telescope technique is used to try and prove the Earth is moving through space, because air and water refract light totally different. The light slows down, it bends and moves in the air and water into the water. Just lay in the bottom of, look at the sun. It's not right above you. It like shifts, So I don't know why this is important to try and prove when we have other techniques to prove the Earth is not moving, right?
We do, and this is starting with the history of it, and it's one of the most significant ones because this led to the more definitive measurements where they were using the wavelengths of light. But the fact that there's no answer to even this is just a great illustration of it, because when you try to answer it, you start contradicting the initial measurement that you're asserting as proof of the model.
Okay, here's Hap. Hap. So I just need to make sure you can hear me real quick. Can you hear me, Hap?
I can hear you. Can you hear
Okay.
me?
Yes, I think I have the illustration to help you understand, but I just need you to let me get through the whole thing. I'm going to ask you, like, I think probably 2 or 3 basic questions, but just follow me. It's not gotchas. It's like very, very basic. All right. So you stated that basically you have, let's use these numbers. Let's say that it's the horizontal velocity is 1 and the vertical velocity is 4. So you got 1/4. Okay. So you're going to create an angle of tilt basically in order to neutralize 1/4. And what you're saying as I was like, okay, let's put water in it. Now it becomes 1/3 because of the water. It's no longer 1/4, it's 1/3. But your point was that because the angle's already been set for 1/4 and the horizontal component's already neutralized, we don't have to make any further changes, even though the timing becomes longer. That was your position, right? Hello?
We've lost him again.
Oh my goodness.
Okay. Hap, just give me an emoji. Just react. If you can still hear me, just give me an emoji.
Think twice if you hear us, son.
Okay.
All right, he's got us.
So here's my answer to help you understand. What if we start out with water in the telescope first? Because if we just start out with water in the telescope, now we're starting out with a 1/3 instead of a 1/4. Now we know the angle for 1/3 is different from 1/4. So if we just begin with the telescope with water, and then we remove and we tilt it to neutralize the velocity angle differential for water, we now remove the water, and now we've got air. Now do we have to tilt it backwards in order to correct for the air? Right? Because if you're being consistent, you would say no, because from air to water you said no, so therefore from water to air you'd also have to say no. But the problem is we know when we do the initial tilt angle setting, the setting for 1/3 has to be different from 1/4. So the initial angle setting for water has to be different from air. Do you see the problem here? You can't get away from the fact that there are 2 different angles. He dropped down to listeners, and oh, he's giving me a thumbs up. Okay. Now he's giving me a thumbs down.
I sent him a mic to see if I can get him back up, so we'll see what happens there.
But I mean, that was his position, I mean, because the angle's already been set, it doesn't matter if we change the velocity, it's already been set. Okay, set for what? Well, it was set for air, which is 1/4. So if we set it for something different, right? If we start with water, we set it for water, which is 1/3. It's going to be neutralized for water. If we just start out, let's pretend we never did an air measurement. We're just starting with water to begin with. It's going to be set for water. It's going to work. It's going to be neutralized.
Pretty
And then when we
straightforward.
take the water out, go to air. It's now different. And we know that the 2 initial set angles are different, because all we have to do is look at if the numbers 1/3 and 1/4 are different. It's very elementary. And some people find this hard to believe simply because they're like, it can't be this simple to show how wrong it is, right? It can't be just so simple that we just use a formula with 2 variables, can it? It literally is. That's actually the formula for aberration. That's what's so sad and so ironic about all of this.
Am I back?
I hear someone. Who is that?
Yeah, so Hap is back.
I don't
So I
see
asked-
him, but I hear him.
He's here, man. He's here. Trust him.
Now I see him.
Well, maybe it's better I'm not seeing her.
Welcome back, Hap.
Yeah, so I heard most of what you said. I agree with most of what you said. The angle that you tilt the telescope is going to have to be different, whether it's air or water. But once you've accounted for it, whether it's air or it's water, you've eliminated the horizontal component with respect to the telescope of the light. So it doesn't matter if halfway down the telescope you change from water to air, or whether you change from air to water. At the top of the telescope where the light is entering, you've accounted for the aberration angle difference. And unless you assume that putting the light in a different medium is going to somehow add a horizontal component to that light that you've already accounted for at the top of the telescope, whether it's air or water, you're set. And it doesn't matter what happens to the light as it goes down the telescope, whether it speeds up or slows down. Did anybody hear that?
Yeah, we heard it. Do you hear us?
Yeah.
Okay.
good,
Okay.
good.
So
My
so
position.
what I don't understand, Hap, what I don't understand now that this has been explained, you agreed that depending on which one you start with, your initial angle that you set is going to be different. You agreed with that part.
Yes.
Okay, now pause right there. So we're in agreement on that part. We're all on the same page so far. Okay. So if let's use those numbers 1/4 for air and 1/3 for water. Okay. If we use these numbers, you agree that this initial set angle, if we start with water, that's a 1/3. And if the initial set angle, if we start with air, that's a 1/4. And we agree that those are different.
Okay,
Hello?
Hap, I'll drop you down. Give us
Cut
emojis.
out.
My
Looks
goodness.
like I'm still.
We hear you. I don't. Can you hear Piezo, Hap? I don't
Yeah.
know.
Hap, we lost you. I dropped you down. Do some
Had to drop
emojis
him,
if you can hear Piezo, so he can finish his point, and then I'll bring you back up.
Yeah. Can you hear me, Hap? Let's get those some kind of emoji if you can hear us. All right. Well, at this point, I feel like we've
kind of reached the peak of it because it was already acknowledged that there would be a change, and then he just kind of nuh-unned, which is
I mean, so just to recap for the audience, he acknowledged that depending on which one we start with, if we do the initial angle set for water or the initial angle set for air, we're going to get two different initial angles. We're going to get the 1/3 angle for water, we're going to get the 1/4 angle for air, and those are different. But then he said, if we then just take the water out or put the water in, it's not going to make a difference. How can it not make a difference when the two angles are different that we started off with? He's saying, this is what he's saying. We start off with 1/3 and it's water. We take the water out, it's still at 1/3, but it's in air, but it'll still be centered. It'll be centered in air at 1/3. And then he says, if we start with air, it's 1/4. It's centered on air at 1/4, and if we put water in it, it's still centered in water at 1/4. But now we have centered air at 1/4 and centered air at 1/3. How can we have centered air at two different angles? You can't have it centered at two different positions. So, like, there's quite literally an extremely blatant, obvious contradiction in his reasoning. And it's either not clear to him or he just doesn't want to accept it. But I'm pretty sure every other person listening can see that.
I think I know how it works with air and water. I think I know how you can do it. If the Earth is stationary.
Yes, of course, Ken. That's the answer. You're correct. Hap, I hope you heard that. Just to recap, just in case you didn't, you acknowledged that the initial set angle for water, it would be 1/3. The initial set angle for air, it would be 1/4. Those two are different. We agreed up until that point, and then you said, but once you change the medium from water to air or from air to water, you don't have to make any more corrections because it's already been set. The problem with that is, Hap, if we start with water, we've got 1/3. That's the angle. It's set. It's not changing. It's 1/3. We take the water out. Now there's air in there. It's pointed at we've got air and it's pointed at 1/3. And you're saying air is going to be centered. But just a second ago, we started with air, and air is 1/4 and it's centered. So how do we have the telescope centered with air at 1/3 and centered at 1/4? We're talking about the same star here. How can it be centered at two different angles at both times? It can't be centered at both.
Started with water. Said it
Because
backwards.
initially, when you tilt the telescope, you're accounting for 1/3 or 1/4. Once you've done that, you've already eliminated the horizontal component of the photons coming in with respect to the telescope. So at that point, it doesn't matter whether you speed the light up or slow the light down. It's not going to suddenly magically add a component to the horizontal component to the light. You've already accounted for it when the light initially enters the telescope. You've tilted it so it's going down the center of axis of the telescope. And at that point, slowing it down or speeding it up isn't going to change whether the light continues to travel down the center of axis of the telescope. Can you
Okay.
still hear me?
Yes, I can. You can hear me, I'm assuming. I'll tell you what. You're decent with math, right, Hap?
I turned off Bluetooth this time. I was hoping maybe that would make it.
Yeah.
All
He was
right,
using
No.
Bluetooth the whole time?
I'm gone. You're gone.
Can you hear us now, Hap? All right, well,
Another
that's
time, gentlemen.
Yeah, rest in pieces. Go ahead, Pizio.
Just drop it here. Hap, I'm going to drop you. Well, can you drop him down?
I already dropped him.
Okay, just hasn't updated for me. So, I was actually going to say this for his benefit. I was going to talk to him for his benefit because I'm almost positive that just about every other person in here understands this by now. It's like very elementary. It's actually somewhat like I kind of have empathy right now that he's continuing to not understand this point, and it has to be Cogdis. I mean, the only way that you don't apply it to Cogdis is if you apply it to dishonesty, and I'm not going to make that stretch right now. I'm not going to accuse the man of dishonesty. But he's really not getting it right. Like, he's saying that the air could be centered at 1/3 because it started at 1/3, and the air could be centered because it started with water at 1/3, and the air could be centered at 1/4 because we centered it at 1/4. Bro, if it's 1/3 and it's centered, it can't be centered at 1/4. If it's 1/4 and it's centered, it can't be centered at 1/3 with the same medium. Like, those are two different numbers. 1/3 is not equal to 1/3 is not equal to 4. Those are two different numbers. Like, this is the most simple logic that you can almost possibly get to when we're talking things that deal with math. 3 is not equal to 4. But for your benefit, Hap, I really want to make you get this because at this point in the conversation, it's no longer for the audience. Like, this is for you, bro. So I think if we do the Socratic method very basically here, I'm pretty sure we can nail this down. Just please be patient with me. All right. If we start with water, you agree that if we start out with a telescope with water in it, we're going to tilt it 1/3, right?
Can you hear me?
Yes.
Okay, I understand the point you're trying to make over and over again. And what I'm saying is that the initial
Hap,
set of
please.
the telescope,
Please.
whether it's 1/3 or 1/4,
I know, Hap. Please,
Okay.
please. I will get you, bro. Just please trust me. I will get you there if you will let me talk to you with the Socratic method. Just please, let's run this through once and just try. Okay?
Okay,
If at the end
1/3 and 1/4 are different. Go.
Okay. So, yeah, but we got to do the nuance part to address what your point is, right? So we're going to piece it together. You agree. We start with water. We're starting out with water to begin with. When we tilt for the water to be accounted for, we're going to tilt 1/3, right? Right?
Oh, yes. 1/3,
Okay.
1/4. I understand.
Okay. And then when we take the water out, now there's air in it, but it's still pointed 1/3, right?
Correct.
But you're saying so far you're saying that once we took the water out, now the air's in it. We don't need to change that 1/3 angle, right? 1/3 is still going to work for the air, right?
Oh, wait. Was 1/3 for the water?
Yeah, it had water in it, and we had a
No,
1/3 tilt.
A different medium in the telescope, you have to tilt it differently.
What? Are you serious?
No, my point is.
Wait! Whoa! You just literally took our position. You said there's a different medium in it. We have to tilt it differently. That's our entire position, Hap.
If the
You just
telescope,
understood it. You just got it. You're there. You get it now. You
yeah,
have to tilt it differently when you change the medium.
you're,
Airy did not have to do that though. When
you're,
Airy changed the medium, he didn't have to change the tilt.
you're missing my point. When you set up the telescope initially to receive the starlight right down the center of the telescope, you set it up for whatever is in the telescope, water or air. Doesn't
Yeah,
matter.
so
And those
water,
are
let's
going
say
to be,
water, 1 over
those are
3.
going to be different. Once
Okay.
you've done that, you have set
Yeah.
up the
Yeah. Once you've done that, you've set up the angle.
I think we lost that.
Oh my God.
Did everyone just see what just happened? He literally acknowledged our position.
Well, then he wanted to start
I
off
heard it.
on the telescope with water, and that's not how it goes. You start off with no water, and then you
Well,
adjust the
well,
star.
yeah, but either way, like we could apply it analogously.
Well, that's why I
Whoa.
did it backwards. So we start with air and go to water, then we start with water and go to air, because there's going to be a difference there. Like you can't have it both ways unless you want to say 3 is equal to 4. Yeah, I mean,
I'll drop half and try
I'm
and bring him up real quick one more time because it would be worth it to continue that now.
dude, I couldn't believe my ears when he's just like, yeah, it'd be different. I'm like, what are we arguing about then? And then he went back and went like circled back around to the position right before he said that.
So yeah, we're about to eliminate the horizontal velocity component, guys. That doesn't mean anything.
Or are we eliminating it pointed at 1 over 3, or are we eliminating it pointed over 1 over 4? Because his position is once you point it and you eliminate it, it doesn't matter what medium you got in there because it's already pointed. It's like, okay, but what you're saying then is I can point it at 1 over 3, take the water out, it's still centered on air at 1 over 3, or I can start out in the first place with air and I'm going to point it at 1 over 4. You're in both cases, you're saying the telescope is centered on the star at 2 different positions. It is a contradiction. I think that we have a serious case of just classical cognitive dissonance when it comes to this topic. Because I mean, when it comes down so simply to 3 is not equal to 4, like, I mean that is like we're talking about single digit numerics right now and an equal sign. I know everybody here's like listening. The listeners are smart enough to see the distinction here, but like I'm actually genuinely doing this for the benefit of this man at this point. Cognitive dissonance is almost like a spell, bro. It's almost like you've got like blinders, like a blindfold wrapped around your head, and you got your hands tied and you can't take it off. It can be cog dis can be a heck of a thing to break free from, man. It is rough for some people.
I just can't believe that he doesn't realize that his argument only works if the Earth is stationary. You know, I don't get it. I mean, I don't math as good as him. He can math. He's done it before in the threads with me.
Hello?
Welcome back.
Hap. Before you run out of time. Oh my goodness. It's like I think we got like.
Let me speak, okay? I understand what you're saying over and over again. What you're missing is from my point of view, and maybe you can correct this. From my point of view, once you have corrected for the 1 over 3 or the 1 over 4, you've got the photons traveling straight down the center of axis of the telescope, whether you start off at 1 over 3 or 1 over 4. Once you've accounted for that tilt to get the light coming straight through the telescope, it doesn't matter whether you slow the light down or not. It's going to continue straight down the telescope because that's the only component of velocity you've got. Straight.
I can correct it. I can correct it. I got you. Bro. It's 2 steps. Step 1. We start out with water and it's 1 over 3. We take the water out. We're now in air, but we're still pointed 1 over 3 in air. We're pointed 1 over 3 in air because that's what we started with water.
No,
Your track.
no, that's not what I'm saying.
But
at
wait,
all.
well, hold on. Wait. If we start with water and we
That's
point,
not what I'm saying.
what do you mean that's not what you're saying? I'm asking you a question. If we start with water and we point based on the angle for water, we're going to be pointed 1/3, as you already agreed. So we've never even there's never been air in the telescope. We got it from the factory with water in it, bro. Like it's just a water telescope, okay? We're going to point it at the star, and we're going to have to use the aberration formula for the speed that the light travels through that telescope. And based on the water, it's going to be the angle is going to be the 1/3 angle. Now we're going to take the water out, and now there's no water in it. But we already tilted it. We already pointed it at the star with water. So now that there's air in it, according to you, it should still be centered, right? Yes.
No.
He said absolutely not. So, I mean, that's a no, I guess. But, that is so interesting how every time we're on the crux of a question is when his mic cuts out, isn't it?
Yeah, unfortunately. Yeah, unfortunately, I can't keep doing the bring up mic thing, talk for 2 seconds again. So we're not going to be able to have a conclusion on that, unfortunately.
He said absolutely not. As he said before, you'd have 2 different angles. And then I was like, exactly. You took our position. He's like, hold on a second.
Is he related to Franco?
Dude, Taylor, it gets to the point to where you're right on the crux of a pinning question, and you ask them, and it's like yes or no, and then it's like, oh, my mic cut out. That can only happen so many times within the realms of general statistics, right? I mean, like coincidence theory. Yeah.
So weird.
Yeah, so weird. Yeah, that's what I thought as well. But hey,
I've never had that happen to me. Why? Either it never works or it works, and then maybe every now and then, every few hours, it might cut out, but not every 5 minutes
you
or
see how
something.
hesitant he was to answer that question, right? Like you could see he realizes like the implications of giving an answer either way. Like either a yes or a no screws you either
He
way.
seems like he's doing the same thing as Franco. Whenever you were talking to him, where like every time you would pin him on a point, he kind of like jumped to another point, and he never actually had an inherent point to begin with. Is that kind of what he's doing?
Right. It's. I said, just give me a yes or no. It's either a yes or a no, right? Like, oh, my mic died, right? Because the secret here is neither of those answers will help you here. A yes, you're screwed, and a no, you're screwed. I say, is it still centered in air? If you say no, great. You just agreed with our entire position. We win. Thank you. If you say yes, then all I have to do is say, well, okay. Now let's take the other situation. Let's assume that telescope came from the factory with air in it instead of water. And I pointed at the star, and I used the formula for aberration based on the speed through the air. I'm going to have to point it at 1/4 to get it centered. So how is it that I have this same telescope being centered with 1/4 with the air, but when it came from the factory with water in it, I centered it at 1/3, took the water out, and it was still centered in air? That means in 2 different situations, I have it pointed in 2 different directions, and it's still centered on the same star at 2 different points, right? You're screwed. You're stuck either way you go. That's why his position is untenable.
Does he actually have a position unlike Franco?
Not
really.
Not one that's not contradictory, right? So like someone said in the chat, so what if you had 2 zenith mounted telescopes, one water filled, one air filled? Are they going to have the same correction angle?
Right. He said no. He already said no to that.
Am I back?
Unfortunately.
Are you going to be here for 5 seconds and drop down again?
Hey,
I just need a yes or a no on that question, man. Once you have it centered 1/3 on the water, once you take the water out and now it's filled with air because the water got removed, is it still centered on the star when you remove the water?
Of course not.
Okay, you just agreed with us. You just took our position.
Okay,
Thank
now
you.
I'll repeat my position back to me. My position is whether you account for tilt at 1/3 or 1/4, once you've accounted for that angular difference you need to get the starlight to come perpendicularly down the telescope, and see, aberration occurs between Earth motion and the starlight coming in. It doesn't depend on air. It doesn't depend on water. Once you have tilted the telescope to meet that incoming wavefront perpendicularly, then it doesn't matter whether or not you slow the light down or speed the light up in the telescope. You've already adjusted the tilt so that it's going to go horizontally straight down the telescope.
But based on whichever velocity you were using, the air velocity or the water velocity?
The initial interface that the light meets, yes.
Yeah. So once again, you agreed. You just agreed with me. You said no, it would have a 1/3 in water. It would have a 1/4 in air. If you started, you agreed that they would be different because I said if I start with water, 1/3, it's centered. I remove the water, it's now air, but it's pointed 1/3. Is it still centered? You said no, absolutely not. So you're acknowledging that by changing the medium, we change the ratio. That's all there is to it. Like, if you agree with that, then you're taking our position.
Well, then please try to repeat back what I'm trying to say. I agree with everything you're saying, except for the following. Once we've tilted the telescope to account for the initial medium the light hits.
Which one? Which one? Water or air?
Doesn't matter.
Well, they're different.
Exactly. So the tilt will be different.
Okay. So that's what I asked you though, and you said no, but now you're saying yes. Do you not see how you're changing your answer?
Well, but you're not understanding the point I'm trying to make.
I perfectly understand it, Hap.
No, you do not. Obviously
Okay.
not.
Okay. If I start with air, then let me just ask the parallel question, because we got your answer for starting with water, going to air. I said, would it still be centered? You said no. If we start with air, then it's pointed 1/4 for air, and we pour water into the telescope. Is it now still centered? You have to say no, right?
So
you have to say no, right?
You're correct. Yes. The answer to that is no, but you're
okay. That's what our position is, Hap. It starts 1/4 in air. It becomes 1/3 in water. If we start with air, we pour water in and it has to change. That's the position. You agree with us?
No, I do not agree.
You just said yes.
Oh my gosh.
But who are you?
You are clog dissing so hard right now in front of all these people, Hap.
Paizo, repeat back to me if you can what my position is on that. When you tilt the telescope filled with water, it's 1/4, whatever. When you tilt the telescope when it's filled with water, it's 1/3. In either one of those cases, you have now tilted the telescope such that it meets the oncoming wave front perpendicularly, and the light is going to go straight down the telescope, correct?
And then we're going to change the medium.
And then we're going to change the medium, and then what happens?
Well, once the light is traveling perpendicularly down the telescope, right? There's no horizontal component to that light. It's going straight down the center of the telescope. At that point, why does it make a difference whether you slow down the light or speed up the light? We've already accounted for the initial entry of the light into the telescope.
I know that this is your position, which is why I asked you those questions. So I think you're not realizing that you're contradicting your earlier answers. Here's why.
I contradicted my earlier answers. I misspoke. I'm sorry. Repeat back my position to me now.
Okay, so your position is that it doesn't matter whether we start with water, which would be pointed 1/3, or if we start with air, which is pointed 1/4. Once we point our telescope for whatever medium we're starting with, and we point it at that direction, you are saying that once we do that, then it doesn't matter if we change the mediums, that we could change it from water to air, from air to oil, from oil to plasma. It doesn't matter. It's going to stay centered. That's your position now, right?
Why is it going to stay centered from my position?
Because you're saying that we already accounted for this horizontal velocity component in the initial medium.
Right. So the light is traveling straight down the telescope.
Oh, okay. I know that that's your position. I've known that 30 minutes ago, bro. So check this out. This is why I asked you this question. And it's not a stupid question. It seems monotonous, but the reason it seems monotonous is because you're flip-flopping without realizing it. And you should apologize for it. I get it. But now we need to clarify. So we start with water. That's a 1/3. It's pointed at that 1/3. It's centered. We take the water out. According to the position you just clarified, now it's in air, but it's still centered because we already adjusted at 1/3 and it was centered before. So now it's centered in air at 1/3. That's your position so far.
You're missing an important point.
Just say yes or no.
But you're missing an important point.
Okay, but I need you to agree with me. Is it now centered in air at 1/3? Yes or no?
Okay, so the initial experiment, it was air.
Bro, it's a yes or no question. Just before you pivot and try to run away, just answer. Is it still centered when we take the water out and it's pointed at 1/3 in air? Is it still centered? Yes or no, Hap?
But you're changing the experiment. You're saying now.
No, all I'm doing is taking out the water. All I'm doing is taking the water out, and now it's air. That's the only thing that I'm changing. Is it centered or not in the air at 1/3 now?
Well, you've got to change the tilt of the telescope to account for the initial medium that the light meets. Once the light has met that medium, the tilt is correct for the star. The light is
Okay, so that was water. That was 1/3. We adjusted it according to water, which was 1/3. It was centered in water at 1/3. We drained out the water. Now it's air. Is it still centered on the star? Yes or no?
Of course not.
Okay, Hap. That is our whole point. So vice versa, it would work the same way if we started with air. It's 1/4. Since we're starting with air, it's 1/4. It's centered at 1/4, accounting for air at 1/4. Now we're going to open the valve and pour the water in. Is it still centered in the water at 1/4?
Of course not, but that's not.
Okay. You don't need to go any further. Here is our position. Wait, before you go further, that's our position. If it's centered at 1/4 in air, then once we pour water in it, it will not be centered anymore. You just agreed on a recorded space for everyone to hear. Of course not. And by the way, you're correct. You're correct, Hap. That's the right answer. But that's not what happened when Airy performed his experiment. He had it centered at 1/4 for air. That's what he had it on. It was centered. It was fixed. It worked. He poured the water in, and guess what? It was still centered when he poured in the water.
That is not what Airy did.
Bro, oh my gosh. Y'all have been arguing for 2 months about this without even knowing what's going on.
Have you watched the
That is not what Airy did.
Bro, Hap, you started off the night of the space by sending me a picture that said that the aberration received is the same as the aberration in air. So that's exactly what was done. That was exactly the purpose. That's why all the references to the experiment are in regards to the implication of it being stationary and the starlight already comes in at that angle. You can't say that the purpose was different now.
Here's where you're missing what Airy did. Let me go over my point again. Hey, I've got a long time this time. About time for me to cut out. So what you're talking about is totally replacing the air and the water in the telescope. You go from one to the other. It's 1/3. It's 1/4. I understand all that. And then can you still hear me?
We can hear you, Hap.
Yeah, continue. You're good. Go ahead. You got the floor.
What you're saying is set up the telescope for 1/3 or set up the telescope for 1/4. It's different. Complete agreement. That's not what the experiment was. The experiment was to tilt the telescope so that the wave front of light was coming perpendicularly down the telescope. All right? So once you've done that and it's traveling perpendicularly down the telescope, and
there is no horizontal component to the light, and that's for air. Now, when it hits the water interface, say halfway down the telescope, the horizontal component of that light has already been eliminated for air at the top of the telescope, but there's no horizontal component of the light in the telescope anymore. So slowing the light down or speeding it up doesn't make a difference at this point. The
entire telescope's filled with water.
What?
The entire telescope's filled with water.
Correct. And the light travels through air, and the aberration numbers.
Where's the air?
In the atmosphere.
No. The atmosphere is irrelevant. The atmosphere is not relevant for the calculation. I don't know if you're missing that point too.
Well, I don't see that point. Maybe you could explain it. If the
okay, because
if the telescope is filled with air, it's the same air as the atmosphere.
Hap. The star shoots out a radial, we'll call it a radial cone of photon streams traveling vertically outwards in every direction from the star. As Earth is flying through space, at some point, a photon stream will reach the telescope lens. So it'll be a different photon stream over here in space as opposed to over here in space. But regardless, wherever we are in space, we have our own personal photon stream, right? Okay. So now it reaches the lens, it goes in the lens, right? And it travels down through the tube of the telescope. During that time, that's when the shift happens horizontally, and we have this whole illustration we've been going over for an hour. So all of that's a non sequitur. You're still stuck with the fact of the 1/3 and 1/4 being different numbers. What we know is the point is we predict different angles. We predict different angles for water and for air. We have Airy's paper. He is stating that the angles he got in his experiment with the water telescope matched those of the nautical almanac, which are for air. The nautical almanac's for a regular telescope, which is filled with air. So the water measurements matched the air measurements. That's what his experiment was. He didn't need to do the air measurements because they've already been done hundreds of times, right? They're established already. They're well established historically. He has an almanac for those. So he's like, I don't need to test the air part. We've already got that down. I'm just going to test the water part because we know 1/4 and 1/3 are different numbers. So once he did the water part, he expected to have a different set of measurements. But in fact, he did not. They were all the same. That's the entire point. That's why it was called a failure. That's why it's dubbed Airy's failure, because he failed to measure what was expected under the heliocentric model. It has that moniker because the measurement did not match the expectation. And that formula for the expectation has not changed. It is the same formula now as it was then. Back in even before him, back in the 1700s, the formula for aberration has been the same for 300 years. But I'm glad that you agreed with us that the angles would have to be different. Your reason triumphed over your cognitive dissonance in that moment. You understood the logic there. After that, you hit the reset button in your head and had to try and placate your contradictory paradigm that you had believed in order to maintain some type of coherence within your own psyche. I get that, but you agreed that there'd be different angles. We agree as well, at least under your paradigm. Airy agreed as well, which is why he set out to do this experiment, because Klinkerfues claimed to have measured different angles. So he's like, oh yeah, let me verify that with a real Royal Observatory level experiment instead of your little homemade setup you got claiming you did. He went and did it on the big scale and found that he had the same angle in water as air. The only way that can happen is if the Earth is stationary, because that means the two numbers you got, v over c, velocity of Earth over velocity of light, it's not actually v of Earth, it's v of the starlight coming sideways. It's already coming in at that angle, right? It's not based on the velocity of Earth. That's the only way it would work, because the Earth's stationary. Anyways,
Can
no, I
I,
don't feel like we're beating a dead horse at this point.
can you hear me?
Unfortunately, but you got cooked. Before you get into that, Hap, let's
Oh, no. Give me just 2 seconds before I cut out again. Paizo, let's do this on posts. I'll go to your thread and talk to you there about this.
Then it'll never end. That y'all been doing
Yeah,
that forever. He's trying to get down to the crux of the problem here.
But doing it on texts, on posts helps. It's written down.
No,
and
it
you
does
can refer
not.
to it.
How has it helped in the past?
You're cooked.
So Paizo, do you agree to that? I'll post you my.
Hap, respectfully, we can get so much more information out so much more quickly and efficiently here than in text, because in text I've done the same thing. It has not worked. That's why we brought you here. You agreed with us that the angles would be different. We know objectively that ARRI tried to measure the angles in water and found that they matched those in air as recorded in the Nautical Almanac, over hundreds of years. So air matched water when he actually measured it in real life. GG, that's our position, that the only way that can happen is if Earth's stationary. You agree that they should be different. We agree as well. They weren't different. They were the same. That's the whole point. That's why it's called ARRI's failure. It was dubbed a failure because he failed to measure what was expected. That's the whole argument, bro. It's super clear. It's easy, simple, and short. All right.
Yeah, I think he's down there again. What's up, Dave?
No worries. Yo, shout out to you, Hap. Much appreciated. Dude, we got Stone, Taylor. The boys are back in town. What's up, lads?
I was just gonna ask him a question, so
Oh,
if he's gone, that's perfectly fine.
Hey,
yeah.
before we go any further, let's do this just to make sure that we can clear whatever might be wrong with the space. Let's do a real quick little mute all and unmute and all right. Can you guys talk again?
Yeah, sure
Yeah.
thing.
What's up?
All right, sweet. Hopefully we won't have any more problems.
I honestly think Cap was. He said he was on Bluetooth. I think he kept on connecting with some other device. What's up, Ken?
No, I would just I'd actually just wanted to say something to Hap, but I don't see how he doesn't see it, because if the telescope is moving and you set it at 1/3, you remove the water and it should be 1/4. If the telescope's moving, it's not going to hit the center. The only way you can put water and center it, or put air and center it, and then add water and still have it centered, is if the telescope isn't moving. I mean, he's literally making the argument for a stationary Earth, and I don't know. I don't see why he can't see that.
He was agreeing with our position all the way up to the point Tori was going to say we were right, and then he just couldn't do it.
Yeah, and there
Hey,
was
these things are spiritual in nature, though. You got to understand that it's a spiritual thing going on, man. It's maybe not everybody here believes in that. I'll just tell y'all straight up, it's spiritual. Because when you have that level of truth just in your face, like, hey, 3 is not equal to 4. We can agree with that, but wait a second, that means that they're right. No, they're not right. Well, and then it just starts. It starts.
Bag, dude. We just watched it like 4 times in a row.
Yeah, it was pretty wild. there was even a quick deflection to, well, that was about testing the ether. And just real quick on that, it was to test Klinker-Fuse's hypothesis, which is derived independently of ether. There's no ether variables in his equations. It's all based off of Snell's law and cosines. So there's no ether mechanic there. It was based on the hypothesis that, the Earth is actually in motion. There's going to be a change when you add the water. And Klinker-Fuse said that he measured that change. And so when Aries says that he finds that Klinker-Fuse's hypothesis is untenable, that's what he's referring to, that there wasn't an angle change, meaning the velocity component that they thought was responsible would have to be coming from the sky instead of coming from the Earth.
Well, Piezo, you did not waste your time tonight because you helped me refine my argument. I don't know that you could have explained it any simpler.
And I'm glad that it was clear for you guys. That is my number one goal. Is I understand these things, but it's one thing for you to personally understand something. It's another way to break it down for other people to get it. And especially when you have different levels of understanding in different people, you kind of have to try to find a format that will work for everyone, and that can be difficult. So if you guys all understood that, I am very happy. Glory to God. Because he's the one I want you guys to be pointed to. Just to be clear, he's the one that made all this. So,
well, then he kept on acting like just the starlight itself traveling to the telescope, whether it's filled with water or not, was making it's the same either way.
Yeah, Franco actually brought that up. Franco actually tried to. I realized he was trying to do that when I read one of his recent replies, and that doesn't matter. The aberration does not occur on its way to Earth, right? Because we're not seeing here's the thing: if I shoot out let's just whether we use a wave or whether we use a photon, it doesn't matter. For empty space, we'll use a photon, right? For the vacuum of space, it's photons. They would say, if I shoot out a photon towards where Earth is right now, all the way from the star, by the time the photon gets there, the Earth's not even anywhere near that. It's like on the other side of the solar system, bro. It's not even touching. It's not going to see that photon, right? So the effect actually begins when the light enters the telescope.
That's what I'm saying. The whole distance, wherever to the rim of that telescope, it's the same either way.
You can imagine a giant like cone of photons going outwards, and it doesn't matter where Earth is at any given point, it will be in a photon stream. And for that particular photon stream, in the fraction of a second it takes the light to go through the telescope at that speed, it's going to be on the order of probably like picoseconds or femtoseconds or just something crazy. So on nanosecond, it might be nano, it might be pico, I don't know, very small, right? During that amount of time that it takes to go through from the far end of the telescope to the eyepiece, that's where the aberration is occurring. It occurs inside of the telescope. There's no aberration in our eyeball, right? When we look at a star with our eyeball, right, we're seeing it, right? But it's when we well, I take that back. When we look through our eyeball, there's still a lens effect because it goes in like where our eye is, and then it goes back to the back of our eye, and there's still a travel time difference because we have to orient our eye based on it entering the end. So it is kind of like a little baby telescope. I shouldn't say that.
But we can't the medium inside our eye.
Yeah, and there's also a medium inside of our eye too. So there's still aberration. But I mean, you can't really measure it with your eyes, right? There's no way I can draw micrometer screw and put micrometer screws in my eyeball and put a screen over my eye, and I can't really do that, right? So you wouldn't be able to prove it either way. But it definitely happens in telescopes.
Yeah, I thought that was not a very good argument. You should reconsider your position, Hap.
I didn't know what his position was at all.
And what's funny, man, is it's actually not funny. I shouldn't use the word funny, but I kind of mean funny, just odd or ironic, I guess. We that attempt to seek, learn, and spread truth, since we operate by default in good faith, we tend to look at others in similar ways that we evaluate ourselves. That's just the natural human tendency, right? Uh, and when you do that, since you operate in good faith, you tend to give other people the benefit of the doubt, right? And because that's, I mean, and to be fair, that's how you should operate, right? That's the way that's proper. But when people are not, and just to be clear, I'm not, if you're still listening, Hap, I'm not accusing you of anything right now. I'm speaking in general. But if people are not operating in good faith, it does not matter how well you explain it, how correct you are. If you're literally able to just break it down on a whiteboard and your whole argument is, hey, 1 is not equal to 2, or 3 is not equal to 4, and that was your argument, it wouldn't matter because that person is not interested in learning something that will break down their worldview.
They just want to be right. They just want you to be wrong.
Right. They want to continue in what they already believe in. And spreading their voice becomes an exercise in what, in my opinion, is self abuse. Because it's taking something that is demonstrably and objectively false, reifying it in your mind so as to deceive yourself so you can continue to believe in that which is false, so as to comfort yourself from the implications of what if it were this way, right? Because what all of this boils down to is I have yet, and I'm not saying they don't exist, I mean, maybe there is, out there, but I have yet to meet an anti-geocentrist or anti-FE person who was not a naturalist. And all naturalists, if they're strict naturalists, all of them, if they're truly a strict naturalist, are either atheists or agnostics. Okay? Mostly atheists. Maybe 5-10% agnostic, but almost all atheists. They do not want to have a worldview that incorporates God, because the implications from that involve accountability and other things. Therefore, it's much easier to say this all came from stardust and nothingness and does not have any intrinsic meaning and it doesn't matter, and be nihilists and be hedonists. So that is the actual primary core foundational reason they will not accept your words nor listen to truth, because they are willfully ignorant of the truth. Romans chapter 1. But I'll get off the soapbox. I'll let y'all have your space.
Oh, dude, you're right though.
Lynn has had her hand up for a long time, by the way.
Lynn Fox, what's up?
Not that long, but if y'all aren't finished, I'll wait because I'm gonna change subjects.
Go ahead, Lynn.
Okay.
You've been waiting so patiently.
Well, I have a question. I asked it in another space, but all of y'all weren't in there, so I'll get y'all's opinion. The next town south of me is about 30 miles. 7 miles south of my town, there's a high place where at night you can see the lights of that next town. So that's about 23 miles. And I have checked the elevation with an online website, and the elevation is really, really close, like within less than 10 feet. So if I get a photo at night, because I can't locate anybody with a camera good enough during the day, I think I can see the water tower if I had a P900 or P1000. I have seen the water tower not far from that high place. But I don't know anybody that's got a good enough camera, and you can't get it with a cell phone. and the day that I saw it very clearly was like very low humidity, not very hot, super blue skies, no chemtrails at all, no clouds. So I've waited like, I don't know, seems like a couple of months. I think it was like before Thanksgiving when I saw it in the daytime. So I thought, well, I have seen it. I have seen the lights of that town at night. So is that going to be a good observation to get a photo of that? Or as long as as long as I know that the humidity is low and all that, are they going to yell, and no clouds? Or are the Globers gonna yell, "Oh, refraction," or something like that? I have not seen any, nighttime observations like that, and that's why I'm asking. Would I be wasting my time to drive out there and get a picture one of these nights? Anybody?
I think you should. I think you should.
Okay, so nobody sees any reason, like, objection they're gonna make and just poo
Yeah.
poo.
What do they call that when in the desert you see a oh God, I can't
Mir
even think.
It's a mirage. Is that night?
mirage?
Mirage, yeah.
Well, how can it be a mirage? I mean, maybe it is. I'm just not
I,
understanding.
I don't see how it could be a mirage at night.
Well, it sounds like nobody else has had any experience with it at night either. Maybe I should just do it
Hey,
and
Lynn.
just see. Yes, huh?
So you can look over and look at the lights in the town, right?
Now, it has been many years. This is a town where I grew up. I just remember going over that hill before, and at night and seeing the lights. Yeah, that next town. I don't know if they were shining off the clouds, or if we actually saw the lights themselves. I don't know. I do know there are, and okay, in that town, if I can see the actual lights, they're not going to be way up in the air because the tallest building in that town is at the most 4 stories tall, and I think the tallest is probably 3 stories tall. So, you know, they can't say, "Oh, well, you got to subtract so many
Uh-huh.
100 feet or whatever," because all the lights are going to be down low to the ground.
Exactly. Yeah, go check it out. Try to get a picture of that. That'd be really cool. I know you don't have a P900, but even on an iPhone or whatever, just try to get a picture.
Yeah,
But
I
you
will.
know how people are with how high is the ground level? How high is the building, you know?
Yeah. Well,
And
I've
it's
already
hard to
checked.
figure that
Yeah,
sometimes.
I've
Yeah.
already checked all that out. I called the city water manager of that town to get the height of the water tower, and according to the height of it, I shouldn't be able to see that at all, not any of it. And I could see the whole round ball, of the tower, and at least part of the legs. And according to the Earth curve calculator, I shouldn't be able to see any of it. Um,
They're gonna ask you if that town, because I've talked to so many Glovers, they're gonna say, "Oh, you need to figure out the survey data on that town to see if it's like higher than your town, like if it's on a big, hill per se, you know?"
well, it is, but the hill is according to the website that I checked online for elevation. It's within 4 feet of the elevation of the hill right outside of town.
Hmm.
And so, that's not enough to make any difference. And I measured like because I figured I would take a photo. If I took the photo, I would be sitting in my vehicle rather than standing up. So I measured, from the ground to my eye height, that's 4.5 feet sitting in my car. I've got all those measurements. I've got the graphic ready to go if I just could get a picture of it. And I thought, well, in case I don't ever get a daytime picture, would a nighttime picture work about as well? I
It
just
should.
I would just leave out mention of the water tower. I just take that part off the graphic. I guess I'll try to get one and then we'll see. If I get one, then I'll
Yeah,
post it next week in here and let y'all decide.
that'd be cool. I can't wait.
Yeah. Well, I hope I get one. I hope again, like I said, it's been many years since because I don't drive at night anymore, but I'm okay with driving that far. It's not that far. Um, but I do remember several times being able to see it. And I have spoken to the guy he owns a helicopter business. He lives on that
The
hill.
Earth is
And I've
fucking
spoken
flat.
to him, and he says, yeah, he can see he
Hey,
can
please
see
don't
the town
interrupt.
at night. So, well, I'll let y'all go. Thank y'all so much.
Yep, no worries. Coming on. All right, Jeff, what's up with you, brother? See, you got your hand
All
up.
right. Thanks again, Alan. All right. This telescope thing, is it done the old fashioned way, or is it done electronically to where it moves with the star? Because you know how the stars go around time lapse in a perfect circle, which I think if we're moving at negative 66 or 66.6 degrees angle and then traveling at 66,600 around the sun, it should be oblique, right? The stars instead of circular.
Yeah, so
The
the
only thing
the
oblique's your
aberration.
mom's ass.
Oh, I got you, bro. 1 second. Got that oblique ass. Okay. All right, so the answer to your question is there's a latitude dependence to the aberration, right? So if you're closer to the North Pole, the aberration makes a circular pattern. As you get further out in the latitudes, it becomes an ellipse, and at the equator, it's pretty much a straight line. Now, the important part of that is like the maximum dimensions of the length of that curve, right? Now, that angle to produce that comes out to be 20.5 arc seconds, which when you ratio that over the speed of light, you get 30 kilometers a second. So that's why they were taking that measurement as good agreement to their model, because they don't have an idealized position of the stars. They've never used the zenith mount telescope and put a star in the exact zenith position. They always have to, it's always off a little bit, right? So the difference in what they're talking about there is like their expected idealized position versus like where they're measuring it, and the difference in that over the year. They're calling this aberration that they're attributing with that specific amount of deviation to the ratio for the speed of light to get 30 kilometers a second. And this is done with an old telescope, like the old fashioned way, as you put it, using a zenith mount with a spindle on it that could be rotated 180 degrees to itself on the horizontal axis. And it had a micrometer screen at the bottom on the eyepiece, which is like little wires that are 1/1,000,000th of a meter wide. And they made a grid out of that. So when you're looking up, if you relate the width of the micrometer wire to an arc second for, relating the ground to the sky, you can measure out like where it would be expected in that grid if it had that true idealized position, and then you would have the exact measurement in arc seconds for where it's actually at with using the micrometer grid. So that's that's how they did it. It was one of the most precise technological feats done at the time. It's very impressive. Actually, if you want to see a really good breakdown of it, Manus Stone, if you go to his BitChute, I'll post a video here for everyone. He breaks down the technical specs and precision of it in about a 3-minute video, and you can really see what was done there, because it was pretty significant, especially for the time. It was quite a feat of engineering.
One other thing, I lived in Key West for a long time, 10 years, and the boat going away from you disappears, because of vision. But if it goes left or right, say a horizontal line, you could see it further to the left and further to the right, because it's like everything's level. But when it goes away, it disappears. But to the left or the right, it takes a lot longer to disappear. And that's also what proved to me, or shows to me, that the Earth is flat, because left and right is much wider than away from you. There's no curvature left or right that I could see.
Well, the curvature is always out to the left or right because you see in a sphere, right? So like that'll always be a little bit curved or whatever. But yeah, that's just the radius of your vision, essentially. Like optically, the curvature would be in your eye versus on the ground. Because when it comes to curvature, like really what they're talking about, like everyone likes to kind of mess around and talk about horizontal measurements and whatnot. But when we're talking curvature, we're talking positions of stars in the sky. And that's what, that's what all geodetic surveying and everything is in reference to. So when people do horizontal observations and it matches the radius of the globe and all that is based off of your radius of vision when applied to the sky to make the map and all that. Like you don't actually measure curve.
Did you see the latest X takeoff? I watched it, and when the one portion coming back down to the Earth, it showed the camera was showing a flat Earth, and then the one still taking off, it showed a curved Earth, the radius. But when you looked at the shape of the rocket was curved inwards and like a fisheye. The fisheye that
right.
The Earth was round, and then the ship that had a slight curve to it too. But the portion that was going back down to Earth was level, and then the angle of the Earth that showed it was being flat. Did anybody see that too?
I haven't seen that one specifically, but I know what you're talking about with that. And like, yeah, those are all just different optical effects based off of the different types of lenses and the motion in relation to the horizon. Yeah, they always like to try and present it as if it's like, this is mutually globe. And it's like, well, how about ones where you can make it flat or whatever? Like, it's all the same. Just an optical effect. You would have to reference some external way to distinguish between the two, because we're just kind of using what's in question as proof of either one. So that's where my position is. You have to use something else that gives mutually exclusive outcomes, because optical equivalences would be the same. You would never, if you never see too far on a globe, then you're tacitly agreeing to a plane, which is you're making the globe equivalent to the plane and vice versa. So. Does anyone else have any thoughts or anything to talk about that they want to bring up?
Well, I could say another thing that's something in a different direction. I was searching the internet, and they have a lot of web pages on how to debate a flat earther. There's and it's funny as hell. It doesn't give you any information. It talked about a pizza, and with pineapples, it'd be different and stuff like that. And they don't give any examples except satellite imagery. Now, how come rockets can take pictures with live cams like X, but satellites still have to do digital to where it can be manipulated? And they always use that. Satellite imagery proves the Earth is round, and it doesn't.
No, it certainly doesn't, especially when you get into verifying the chain of custody for the data, because when you are processing raw data, how the outcome of it is going to be highly dependent on the like how you what programming is going into interpreting the data, like how the pixels are being aligned and all that. And we don't even have access to that. We just have this output of this image with no metadata on it. If you were to go and access the highest publicly available data set that can be given to us from NASA, it's there's one from the Discover satellite where you can download the raw data and compile it yourself using a Python script. And when you do that, the data has already been sanitized, and you don't even know what all went into interpreting the data. Because what I found when looking into like using satellite imagery for court cases and stuff, especially when it comes to international things, like suppose there's we're in the Middle East, we got a satellite or what have you, and we're doing some surveillance, and we see some suspicious shadows on the ground, and we're like, oh, well, that's supposed to be a desert there. There's not supposed to be anyone there. How do we know what's going on here? when we take a couple passes and we see these shadows, and we start saying like, okay, this shadow must be, you know, a building, right? You start building a compound and just attaching all these structures to it and stuff, but you'll actually never know until you go and send people on the ground to confirm that, right? But the process in which you're analyzing the data, and that's going to affect like how shadows and stuff, for example, will turn out, and how you interpret those things to, you know, authorize like a military strike or get clearance for something, you know, to go investigate it further. All of that stuff is dependent on the interpretation of the raw data, primarily. And then obviously someone has to look at it and then verify it, and, you know, give their weigh in and give their opinion on what the, you know, is the interpretation that the computer gave us, is this like, does this correspond to things that we've done in the past and got, you know, and found an actual structure kind of thing. So anyway, there just comes a lot into verifying the data and all of that. And none of that is present or publicly available. You couldn't present satellite images like that from space to in court without attaching a chain of custody and verifying testimony from someone to like verify it. We don't have any of that. We just have raw pictures from with no data on them. So
that's archaic. That's like the alien bases on the moon splicing. And I love the blue marble, how everything's different colors from different countries and different sized continents, you know?
yeah.
No one? Alan, can I ask you another question?
Absolutely.
Have you heard of DACALA?
Never met her.
Brazilian organization?
Nope.
Okay, it's an organization that's funded by the Brazilian government, and they put out 7 tests to prove the shape of the Earth. Half of them were globalists, half of them were flat earthers, and the globalists even, you know, admit, wow, the Earth is flat. You know, the farthest was 2 buildings that were 1,885 miles apart, which was like 3,335 or something like kilometers. At the base and the tops, they were exact within a centimeter.
Oh,
And
wow.
yeah. And people tried to debunk it and say, oh, they're crazy. They talked about ghosts and stuff like this. Well, that's because they were researching phenomena in ancient buildings and stuff. They're doing a thing on ziggurats now, how the ziggurat puts out 3 hertz. I can send you the, or put it, is DACALA, look at DAKILA, DACALA. They're doing the ziggurat paths and shapes and energy right now.
Give me 1 second, I'll look it up. What was it called again? DALIK?
Yeah, DALAK. Wait, DALIKA. DACALA.
Gotcha. Docular. I got a YouTube channel. I'm looking for.
I think it's DAKILA.
Yeah, DAKILA. DACALA. Now they did their flat Earth thing was called the convex Earth, which they show like a rock floating in space, but they don't really think it's a rock floating in space. That's just the artistic rendering. But the Earth and the continents are not shaped the way even on our flat Earth that we go by. It's totally different.
It is a
Because
rock floating through space, though, in their paradigm.
well, they don't know what space is. Okay, nobody knows what space is because we're not allowed to go there or travel there, and we can't go past the Van Allen belt, which is actually, I feel, the firmament.
I just put it up in the jumbo. So if anyone wants to check out the Docula there.
Was that Globe Newswire, or is there another one coming up?
It says Globe Newswire.
Yeah, that's it. São Paulo, Brazil.
Hmm.
Here, I live here now. I'll post a picture of what do they call that? The purple pill on the left of what it looks
Yep.
like here outside of where I live. It's beautiful.
Nice, I'll check it out. Oh, nice. You took that from where you live now?
No, I didn't take the photo. A professional local photographer did. Takes photos of the Chapada, which is like the a plateau, the flat range with all the special flowers. We got more medicines here in the Chapada than they do in the rainforest, which is amazing. I mean, this holistic medicine has been shut down by the Rockefeller medicine, which is all pharmaceutical oil products. That's why they're culling us, but or how they're culling us. But the natural holistic material things that are out there are incredible. It takes longer to get healed, but you do eventually get healed. You build up your immunity system. Beautiful, huh? Look how close that zipper is.
Yeah, that's nuts. I saved it into my wallpaper directory. Very cool.
Yeah, the town is called High Paradise. In Portuguese, it's called Alto Paraíso.
Aren't they the same group that went to, I think it was a lake, and it was like
Lake
20,
Titicaca. Yeah, in Peru, Lake Titicaca.
where they did the microwaves?
Now they did radio wave, and I think they did a laser over Titicaca.
Yeah, I know
You-
the one video I watched, they used microwaves, which I think they were saying that the microwaves has to travel in a straight line.
Yeah, it can't.
Yeah,
They can't. It can't be bounced off the atmosphere like some say. Yeah, go
right.
straight. Yeah.
And they laid that out well. They laid that experiment out well, and it was successful.
Yeah, all their tests are verifiable and provable. It's just that it's not publicized because they're a foreign country. Like I came down here and I saw flat Earth videos that I never knew existed up in America. Because you have to type in Portuguese.
Well, I imagine there's a lot of them that don't, but I know that their experiments I've seen them because I do remember them going to different lake. I remember them talking to some guy that they were on his boat. He ran he had a boat, and he was taking them, and he was telling them it's like a really long ways across this lake, and he's talking about how they can see across it. And the guy was saying, yeah, it's flat.
Yeah, 80 kilometers. What the thing is it all depends on the atmosphere, humidity. Because if it's really humid, it distorts the evaporation above the water, and you start to see a mirage, and you can't see the other side. But you do it at night, and you do it on a cool evening with no humidity or low humidity. The laser travels that far.
Yeah, the building one though, the two buildings being over 1,000 miles apart,
Oh,
that was
that's
pretty
amazing.
phenomenal.
Yeah, they used engineers to do that from another government agency, and they were amazed that it came out identical. There was no distance separation of the top and the bottom, and they were both the same distance from the sea because they're on the beach. And yeah, that got me. Provable, all provable, no curvature. If you want, I can find the one that's in Portuguese and has English subtitles.
Yeah, that'd be awesome.
Can y'all hear me?
Yep, yep.
Is anybody talking?
Nope, you are.
Cool. Okay, so I just had this wonderful idea. Okay, so you know how I'm going to the Salt Flats? Well, on the way up there, I'm gonna stop at Ice Lake, which is like a hike in Colorado I didn't get to do. And so I'm gonna try to get like a hotel maybe near the mountains. And you know how I'm not near any mountains, so I never get to like look at mountain ranges, but apparently the mountains never change throughout the day because of refraction, et cetera, et cetera. Basically, there's no way that a mountain can look shorter because of atmospheric conditions. Well, maybe I'll just spend one entire day, like in a hotel room or something with a balcony looking off at the mountain ranges and trying to document the change in the mountain height throughout the day. Because I've seen other people do it, but they didn't really take any measurements and they didn't even have like a tripod. I actually posted a video of it. Somebody was showing the mountains in the distance getting shorter throughout the day. And so I actually want to like measure that throughout the day on like a steady, with steady measurements, like maybe a time lapse or something of that nature, just to see if that actually happens. What do y'all think?
I think it'd be awesome if you can show a mountain changing angular sizes throughout the day.
Mm-hmm. I just thought of that. That'd be a good idea.
Well,
Colorado is pretty, anyways. I've got pictures from when I went there. Colorado's nice.
Yeah,
the
I'm
one
having to
thing,
start saving up now because I'm trying to go in June.
Taylor, the one thing I would change about your plan is I wouldn't plan on just going one day. That if you strike it just right, it would be maybe a 3 days stretch that you're there looking out your window. And day one, you've got really cold, really dry, really sunny. You know what I mean? And then a couple days later, you've got maybe really humid, really hotter. And that would probably give you a larger data set.
That is true. but I have limited time and money. So, I'm also I could also try to do this near the Salt Flats. I'm gonna be looking for hotels there soon and like trying to find one near maybe like I don't know how many mountains they really have in the area, but maybe one facing a mountain in the distance.
Well, how about you pick 2 days that are like maybe 4 or 5 calendar months apart?
So
So
I
you've got
can't do
what?
that. I barely have enough
See,
resources to go
well,
once.
that's what I mean is you're gonna go once now-ish, when it's cold-ish, and then plan one for maybe July when it's really hot-ish, and do 1 day then, and you'll have completely different
I can't
data
go
set, I'm
now.
betting.
I
But you know what I'm saying,
wish.
right? This whole thing might all be delayed by 6 months just to line it up
Yeah,
for finances or whatever.
I see what you mean. Well, I am thinking about taking your advice on doing like little weather stations in between the
Cool.
laser experiment salt flats. I just don't know if I'll be able to have connection to them where they can read me data. Like if I'm have no internet connection, like will they be able to like submit that feedback to me?
I
I
don't
don't
think
know.
they need to, they just need to be able to log it over time, and then you just collect them and read them back and superimpose them.
Yeah, that's a good idea. I don't know if they hold memory like that, but I'll look for one.
Yeah, save you some money.
Or I can just get some volunteers out there to help me. Andrew said he might be able to come. Yeah, that's always helpful.
Alan, I have one more question, then I have to go to sleep. Do you have time?
Yeah, what do you got, big dog? I just got back. What's
Okay.
up?
I've heard about mountains disappearing in photographs. Now, I don't know, is it like maybe it depends on the elevation and the noble gases and their density because some gases are more denser and they reflect like blue? Is the noble gases in our atmosphere at their elevations, they could change visual effect too, yes?
Uh, yeah, but I'm not quite sure how you're relating the two.
Well, one noble gas is like blue. So that's why we say a blue sky. But say you're at a high elevation and normally on a non-dense day, you can see the mountain, but then on another day, you don't see the mountain because you just see blue sky. I've heard of people, I've never witnessed it myself, but I've heard of other people witnessing that where a mountain range disappear and they just see a dark blue sky.
Yeah, I have no idea, bro. Never heard of that before.
All right. Y'all have a good night and I'll see you again soon. Okay.
Better G.
Oh, I posted the Docula convex Earth. The waters are flat, but the continents are convex. That's what that means, not the
Nice.
Earth being convex.
Nice. Little convexity to the plane. Very nice. So I like how it's a mixture of all three. Very cool.
But anyway, that's a really good idea. Either way, no matter where I'm at, there should be some type of mountain ranges. And like I'm gonna see if throughout the day they change. That'd be really good. With some like measurements or maybe a time lapse. I'm not sure which camera would be good for a time lapse. What do we have? A Sony 7 II A7 II. So I have a Sony A7 II. I'm not sure if I would need like a new hard drive in there or whatever to make that time lapse work, but that would be a good idea too.
You taking some laps of Taylor? Horizon or?
I guess I'd be looking off into the distance to see if there's any like mountain ranges or whatever.
Nice. What did you what's the plus or minus for a theodolite? You said it's in infinity?
Plus or minus? I don't know.
For the accuracy of the angle applied over
Oh,
distances?
it depends on how far you're looking. I have a book that has the like standard deviations.
Nah, I was just kidding. They use it for infinity.
Yeah, the refractive index is infinity.
Just plus or minus all.
Well, I've been trying to figure out how much refraction would be needed to see the Canigou Mountains, but I have not got around to it.
Yeah, you need to cite that book because I've only found one time and I can't find it again where I was looking for I was looking for it under error margin and it gave me a table, but it started at 100 yards and it went every 100 yards for up to 500 yards. And I don't remember the in-betweens, but it stepped up incrementally. I just remember that, like, at 100 yards, it said the error margin was 3.2 arc seconds, and at 500 yards, it was 10.8. And I couldn't figure out, if it's 3.2 to 10.8 with an additional 400 yards, and you start looking miles. It's 400 yards is what, 1,200 feet? That's not even a quarter mile. And people they're making
60
observations that,
miles, 70 miles.
yeah, even 27 miles, which is the one that Peter likes to use all the time. 27 miles, that error margin's got to be huge.
Jesse did one at 105. That's the one I featured in my video. Surprisingly, Jesse just couldn't seem to find anything wrong with that decision.
Unlucky.
But am I wrong if I were to say that 10.8 arc seconds at 500 yards is nowhere near what 10.8 arc seconds would be at 27 miles? Even if it was the same error margin, wouldn't that be a much, or am I getting that wrong?
No, it's going to get bigger over distance.
Yeah, it's got to be big over distance.
It doesn't get smaller, right?
Here's something I found. Standard deviation. So like there's like order classes of leveling, like how accurate is your theodolite, and like over 1,000 meters, for example, you're gonna have at least, let's see, 1,000 meters, you're gonna have at least like 1 arc second issue. on this chart. This wasn't from my book, but this was just something I found. So in 100 miles, you're going to have like 160,000 meters. And then what did I just say? Way. It's going to be really high. I think that's just the standard deviation just of the machine, like without even considering refraction. That's a whole different calculation. Here, I'm gonna send this little picture to you, Ken, and you could check it out.
So, Alan,
What's up, big dog?
when's the last time that you did a layman's rundown of the Sagnac effect in a space?
Oh, are you talking about when you split a coherent light beam around a closed loop to itself clockwise and counterclockwise and how it recombines and it'll be out of phase proportional to the rotational rate that caused it to be out of phase?
Yeah, but that's not the layman rundown. That's the like technical rundown. You know what I'm saying?
Are you talking about, okay, yeah, I haven't done a, help me out here. What do I need to say? So here's my analogy. Tell me what you think of this, right? Suppose you're gonna tie your shoes based on the constant speed of how fast you can tie your shoelaces, right?
Mm-hmm.
So you start off with the midpoint of your shoelace, and then you start lacing your shoes up, right? And when you complete the lacing, you should have a nice equal bow, right?
Yeah.
Well, what if you were moving, what if you were walking while you were tying your shoes? And when you tied the knot at the end, the left and right side of your shoelaces were offset from its symmetrical position proportional to how fast you were walking. How's
That's
that?
decent. That's decent. Yeah. Yeah. It doesn't overlap on all the points, but it's pretty good. I don't really have an analogy. I haven't tried to make an analogy. It's kind of complicated to make a Sagnac analogy. But I've thought about using colors to explain it, right? So like you've got a red laser beam. So like if you were to take, for example, a red beam and a blue beam, you were to overlap them, you'd have a purple beam, right? Red and blue make purple.
Right, I'm with you.
Yeah, so you shoot this red and blue beam around two halves of a circle, and they recombine at the other side. And what you should see is that they overlap perfectly, and you just have one purple beam, right? That's what you start with when everything's sitting still. But what happens is when you move the table rotates out from underneath the beams, so that it makes, like, for example, the red beam a little bit longer and the blue beam a little bit shorter. So when it gets to the end, instead of them overlapping into one perfect purple beam,
you actually have a red beam up here and a little blue beam right below it. They're offset. And the amount that they're offset by is based on how fast you spin your table. That's it. So that's just like a visual, like that helps me to think about it, if I'm like explaining it in like a visual way. But the shoelaces is a pretty decent like analogy format. But yeah, I mean, basically the hard part is trying to explain the layman's terms on how it relates to relativity.
Yeah. So the significance of that would be, starting from the history that we're given on how they came up with the speed of light, like let's, take that for what it is and just assume that all that's on the up and up. So we've got this measurement of wavelengths and frequency that we can use a diffraction grating to split light into, and we can measure its wavelengths and frequency, right? So we can establish that relationship for different colors, different types of light, etc. They all have their a corresponding wavelength to them, right? We've got this nice library category of all these different wavelength measurements, right? So basically, like from that baseline, we can use that to for ratios of things, right? So when it came to interferometry, there was starting with the hypothesis that the ether would be dragged by a material medium proportional to its velocity, and that could be measured by using light that's split around a circuit to itself, and when it recombines, it'll be out of phase proportional to, and it'll have some proportional ratio to that velocity that caused it to be out of phase, right? So they started with water, and they split a light beam. It went through water, going with and against the water, and it received an acceleration or retardation, depending on whether it was going with or against the flow of the water. And it received an 80, and that ratio came out to be 88% going with, 88% going against, 44% going with, 44% going against, totaling up to an 88% ratio of the velocity that caused it. So they had this, so the way they took the measurements, right, is when the light beam recombines, like Piazza was saying, if it's in phase, the color should go back to purple. But if it's not, they'll be separated by little fringe patterns, because when the peaks and troughs of the waves overlap with each other, it either creates peaks and troughs, where if it creates a trough, it'll be a destructive interference and it'll cancel out the light there. It'll be like a little black spot. And if it's constructive, it'll be an illuminated spot. So what you'll have when the light beams recombine is little sections of illuminated spots and little sections of dark spots. Now, if you measure the distance between the dark spots, that's called a fringe pattern. That fringe pattern measured in wavelengths, because we're starting with the wavelengths of light, that distance in wavelengths is proportional to the square of some velocity. So when they did that with the moving water, it came out to be a ratio of the moving water. So they've realized that using this square relationship to the fringe pattern, that you could determine velocities using light. And that's where they came up with the Michelson-Morley experiment, where instead of using light through a medium to measure the speed of the moving medium, they were going to use a large area for the light to travel in, or to travel across, and they were going to take measurements with respect to the north and south directions for the speed of light. And the hypothesis was that that as the Earth moved through the ether, the light perpendicular to the direction of motion would be retarded as it gets dragged through the ether, and that delay would share a relationship with the velocity of light, and the corresponding wavelengths. So when you do the math for that, you take the total path length that light has to travel, you take the velocity that you're making the prediction for.
There's
So
silence, or is that me?
Can you hear me? Can anyone else hear me? 1 second. Okay. Testing. Can you hear me?
My bad. I'm muted.
Did you hear me the whole time?
Yeah. I heard all your stuff.
Okay, God
So
bless.
basically, yeah. Like it's the faster you spin your table, the further apart the line the waves get. The lines, like the squigglies, right? When it's not moving at all, they're perfectly overlapped. And whenever
Yeah.
they're really, really fast, they're really far apart. That's kind of like the easy way to think about it, in my opinion.
Yeah, and the distance they are apart, the square of that is proportional to the velocity that produced it. So when they have that relationship, they can now make predictions of how much fringes there will be based off of a velocity. So they had the hypothesis that the Earth was in motion around the sun, and they were going to split a light beam perpendicular to itself so that it would make a cross. And the interferometer was going to be constructed in such a way that it could rotate on a horizontal axis. So it could just do a nice little 360. So you would have two beams that would be going north and south, and two beams going east and west. And as you spin the interferometer, you're going to be able to tell if there's a preferred direction for the speed of light, because when it's in certain alignments, you're going to have an out of phase pattern versus in phase, or it'll be out of proportion to itself, right? So what they found was that there's no north-south variance for the speed of light, but when the light is traveling in the east-west directions, it's out of phase. And when they take that measurement and square it, it comes out to 6 to 8 kilometers a second. Now, the issue with that is we already established how they came up with how they determined the accuracy of these measurements, and they found that it shares an exact ratio to the velocity, right? So they needed the Earth to be moving at a fringe pattern that would correspond to 30 kilometers a second when they square the distance, and they got a distance that only comes out to 6 to 8 kilometers a second. That makes sense so far?
Makes sense to me, dog.
Yeah. So when they got the measurements, they had to explain why it wasn't at the velocities that they needed. Go ahead.
Why? Yeah. Okay. So from like a them standpoint, why is what they measured a problem?
Okay, so the entire cosmological model up until this point was wrapped up in physics through mathematical ratios linking Kepler's laws, which are based off of empirical observation, meaning the ratios that determine the distances and velocities of the planets are only a function of the periodicity squared, and that's going to be equal to the cube of the semi-major axis based on the ratio, how it would work out when you use pi to with the periodicity. So all the distances and velocities are derived from that relationship, and they don't necessarily have any physical meaning, but you could conceptualize, concentric rings around you, or, being one of the rings that's in motion as well. If you apply the same periodicity to the sun, you would just say that that's the motion of the Earth to create that motion, because in kinematics, relative motion is true. And if you're just basing it off of a periodicity, it could go either way, the Earth moving or everything moving around us. So anyway, the way that maths out, though, it gives a velocity component to the Earth that has to be specific to comport. Otherwise, it's not going to comport with the distances and values that they've established, right? So when they took it a step further to introduce Newtonian dynamics into it by relating the centripetal force to gravity and then making that equal to G, big G for GMM over R squared, they're introducing like a dynamic prediction based off of actual, forces, right? So the gravitational force potential between two bodies based on their mass relationship. So the mass being the dynamic cause of the gravitational potential between the two, right? So when they started with Cavendish and they got their torque angle ratio, they were able to establish the gravitational potential between the Earth and the two lead balls, and from that you can algebraically work out what the mass of the Earth would have to be to produce that gravitational potential. So they had. Go ahead.
Oh, I'm so sorry. You said there's two sets of lead balls, and they were using that to measure this.
Yeah, for Cavendish, right? The deviation angle produced by the lead balls.
But how do they isolate the effects of gravity from every other object in the solar system?
Oh, dude, they absolutely did not do that. And if the solar system, if gravity was dynamic as the way that they attribute it to be, they would absolutely have to account for the positions of Jupiter and the moon, because those would outweigh, that would like counterbalance the gravitational effects from just the sun. You know, saying that like this is so that we can just like round it to zero or whatever. But like you obviously couldn't do that if you math out the differences in the potential created from those. But yeah, they just treat it as like this unique measurement that's completely, independent to just the Earth and the ball relationship on the ground. Yeah, we're just kind of giving them the ratio to establish that they have this thing, and now they're going to like plug in the numbers, right? Because the Cavendish experiment was done for, what was it, electric charge, right, with coulombs. So there was already one of these done, and it has a ratio for charge potential or whatever. And then they said that because they neutralized charge potential and used lead balls, that the effect that they're measuring now is independent of any other type of effects like that. In this one, because it's a much smaller angle, within the same ratio, within the same angle that's already measured with charged balls, they take it as like the more refined independent measurement of gravity. And like, even if we grant that to them, right, like let's grant it to them and say like, okay, for some unknown reason, right, there's this deviation swinging that occurs, and when you take that angle measurement for the precise ratio that they're given for Cavendish, because all the modern reproductions of this, right, are now tailoring their deviations to what Cavendish had to measure, right? So any deviations outside of that is experimental error, like they don't count it, blah, 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 right? So they got an exact value that they need out of this that they're expecting to get.
Yeah.
So anyway, but let's just give it to him. Yeah, sorry, but we're just gonna give it to him for freezies and see what happens when we math it out.
Right. Because basically the number they're talking about is like the order of magnitude is so tiny. It's like 10 to the negative 28 or I don't even remember. No, maybe it's 10 to the negative 12, but it's like a really, really small force.
Yeah. And then so when they use these constants in the sky, it still comes out to be a ratio of the periodicity, because the mass and the equations cancel out, and it just becomes again a ratio of the constant of the gravitational force over the periodicity, and that's going to share a proportionality ratio to produce the same effect that Kepler did. So when you have that proportionality ratio, they're like, oh well, this must mean that Newtonian dynamics, like the mass attracting mass, is why these bodies are moving. So with that, so once you have that equation and you have the mass of the Earth and the gravitational potential, you apply the periodicity of the sun. Well, now you can algebraically work out what the mass of the sun would have to be and the gravitational potential between the Earth and the sun and all that. And then you could build the model outwards using the mass of the sun as your constant and the gravitational potential between everything else based off of its periodicity, meaning just how long it takes to complete a circuit in the sky. And that will give you all the exact same distances and everything. So that's how they came to the understanding that what they were doing mathematically was like physically meaningful, because they started to make quote unquote dynamic predictions with their equations when they introduced the gravitational constant. So now they're super locked in to a velocity component because of that relationship. So now it can no longer be like, oh, it's just observation, right? They're now asserting physical dimensions and correctness to this. Make sense so far?
Yeah.
Right.
No, definitely, because they can't change they can't go back on what they've already established.
Correct. Especially when it's just built off of observation and ratios. And then they're saying that these ratios now actually have physical meaning. So Michelson and Morley were like, okay, we'll go ahead and see what kind of, we'll go ahead and see if we can measure this velocity that has to be there. So when you look at the derivation that they did, they used 2 times the distance of the path length that light had to travel on the apparatus, which was 11 meters. And then they took that times the speed of the Earth at 30 kilometers a second squared over the speed of light squared, and that gives them the distance and the fringe patterns that would have to be measured. So they predicted that the wavelength displacement between constructive interference patterns would be to the tune of 0.005 of a fringe, which when you square that out would come out to 30 kilometers a second. And what they measured was 0.0, what was it? It was just over 1. So it would have been like 0.1 or something like that. It was just over 1. So what it comes out to is 5 to 6 kilometers a second. I'm sorry, 6 to 8 kilometers a second. So with that ratio being absolute in the measurement, they realized that everything that they had been asserting about the sky was false. You know, and not to mention the airy situation that we went over earlier, right? Because maybe for some reason Hap was right and it doesn't work that way or whatever, right? And, you know, the telescope, maybe it's not a definitive measurement, right? Maybe it's not good enough. But when we're measuring the wavelengths of light and the difference between them, I mean, that's the highest form of, that's the most precise measurement known to man. Like, so that's pretty absolute. And they had to change up the entire paradigm to keep the Earth in motion and to explain why the value was so low. And they ended up just saying that they didn't measure a value at all.
Crazy, huh?
Yeah.
Imagine being like hundreds of years past this lie that someone made up, and then you're so locked in that you'd have to go back on all of the entire field of astronomy and every bit of trust that the public has in you in order to admit one experiment. So instead of doing that, you just say, okay, we'll just lie.
Yeah. Instead of saying like, you know, this is a conceptual model, yada, yada, right? Because when it comes down to like celestial navigation and actual usefulness, they treat everything in the sky at an equidistant web away, which means that it's a fixed distance away from you. That's all the same, no matter what it looks like in the sky to you. In regards to its elevation angle, they treat it as 6214 miles away. So 6,214 miles away above you, and then away from you horizontally, outward in the sky, is the way that they treat everything. So when they tell you the sun's 93 million miles away, when they tell you like, oh, well, when you triangulate it on a flat Earth or any Earth at any distance other than 93 million miles, it doesn't work. Well, that's cool, but you can treat it at any distance. It doesn't matter. And if you're going to use the latitude and longitude system specifically, you can treat everything at 6214 away from you with no distinction for, 93 million miles, etc. All the stars, all the planets, everything in the sky, you can treat it at 6218. Whether or not it's actually at that altitude, who knows? But you treat it at that mathematically so that you can use their ratios and coordinate system. So it's just as good for, all intents and purposes. So if they had been upfront about the ratios and the models, and they had been like, hey, this is just a concept. And I think actually that's what Kepler prefaced in his, can't remember the title of it, but he did preface that, like, the tools of astronomy are not meant to be taken as literal, and any man who does, enters astronomy and departs it a greater fool than when he started, if he believes in it as more than just a concept to express, the motion.
I didn't know Kepler said that. That's interesting.
Yeah, it's a quote. I paraphrase it a little bit, but that's what he said essentially. You'll depart a greater fool than when you started if you believe in the stuff that they're asserting about it. Because his thing was like, his kinematics were in ratios don't assert any cause for why they're moving, and he said that the sun was singing a heavenly song, and that the acoustic vibration from that was, mediating the movement of the bodies, which is just as valid as saying, mass attracting mass. you can derive one from the other. So there's actually no distinction between the two. If you were to still believe in the equations as is or whatever, you would have to also accept the alternative hypothesis that the sun's just singing a song.
Heavenly songs. What if that really is all it is?
Yeah. I mean, it's not that, right?
Not literally a song, but like, it's just got this, frequency of vibration that's, if you
Right.
think of vibration as sound, then that's
Yeah,
the analogy.
a heavenly song.
Nice, nice.
But yeah, that's the significance there, and that's why they had to introduce relativity theory to keep the idea that the Earth is in motion alive, because they had direct experimental measurement that falsified it. It showed the opposite of what they were asserting. And the only way they could get out of that is by saying that they measured no change, and you can't actually use light to measure relative velocity. And that was obviously shown to be experimentally false when Sagnac used his interferometer with a specific configuration that was configured in such a way that it would falsify Einstein's hypothesis about light and how you can't use it to make the measurements that Sagnac made. You got to kind of think about the history of it like this, right? There was this theory that there was an ether background and you could use a V over C relationship to derive velocity. And what you're doing with that is you're essentially using this fixed value as a fixed point in space that all motion is going to be relative to, because that's what you're deriving. You're deriving the velocity with respect to this absolute value here, right? So mathematically, you can conceptualize that as the ether reference frame, as a preferred frame. All units or all velocity measurements, you can just V over C it, or V squared over C square it, and you're going to get the corresponding ratio for the velocity. Now, let's see here. With that framework, they assumed that that the ether was a physical medium, but that it was static and didn't move. Right. So they had a specific type of interpretation for how they conceptualized the medium that light propagated through. And then they had the mathematical concept of which they were relating velocity ratios to. And like I said, they had already experimentally measured it with Fizeau using running water through an interferometer, measuring the speed of the water. And then later, Sagnac showed that you can measure the rotation rate of a turntable in air. And the equation that he uses comes out to be the same one that the Michelson and Morley lads used. So we know, in continuing on off of this same equation, that's the same one that's used for modern inertial navigation systems that use ring laser and fiber optic gyros to determine angular rotation rates. So we know that the interpretation of the fringe displacement with the mathematics associated with the V over C relationship is valid. They didn't get the math wrong. They didn't interpret the fringe measuring wrong. When you look at modern values that are measured, there's a couple people that assert way higher velocity components in their measurement, even though they're all measuring the same thing. But when you read their work, they interpret Michelson Morley as having the fringes done incorrectly, and you have to basically add more distance between them. So they're just essentially adding more space between the fringes, and that is increasing the velocity ratio to give them a more favorable outcome. But that interpretation is invalid, because remember, we know that the ratio works for angular rotation rates that's used in modern navigation systems. So long story short here, we've got a mathematical preferred frame to measure all velocity against. We've got a constant velocity rate to measure it against using the wavelengths and frequency that correspond to that for electromagnetic radiation. So when they did Michelson Morley, they found that their velocity was not what they needed. Now, when Einstein came along to answer this, they had several problems, right? Because the amount that was measured would have to be within the experimental air tolerance to be like a null, to get like a null result. And their air tolerance was, is it 2 kilometers a second, right? And you can find out more about that from Max Born, made some comments on it, but and then Dayton Miller's work when he got into measuring a thousandth of a wavelength. Anyway, just the accuracy of it came out to be 2 kilometers a second. So any value that's not that's above that is outside of their experimental air. And when you plot their data out, they have, you know, from what was publicly given to us, even though they did take more measurements, you have a statistical significance of non-zero values that correspond to 6 to 8 kilometers a second rather than a null, right? But Einstein says that, well, not just Einstein, but moving forward, they had to say that the reading was actually a null and it was experimental error. And when the theory that Einstein proposed was put forward, it was that one, all inertial reference frames are equally valid. And an inertial reference frame is being defined here as relative motion between observers and source emitter. So you're not going to use a fictitious reference frame. You're using the frame of the source and the emitter when you're talking about the relative motion between light source and an observer, right? And then obviously he's applying the laws of motion, like anywhere Newton's equations apply. So if you're in a moving train, right, if you're in a closed system that's moving in uniform speed, you can definitely treat that as an inertial system or whatever, right? You're not going to experience the effects of your motion. Not going to be able to tell that you're moving, right? But there are ways that you can tell. But just for the purposes of continuing the explanation for Einstein here, we're just going to assume that this is valid on the face of it. And then the second assertion he makes is that the speed of light is constant and independent of the motion of the emitter or the source. So in other words, the interferometer moving through space attached to the Earth around the sun is not going to experience a path length change when it's traveling perpendicular to the direction of motion. It's not going to be dragged or retarded. And in the same respect that it's going north-south in the face of the direction of the motion, not going to have any retardation in there either. There's going to be no path length change. What he's asserting with that. And then he goes on to say right underneath that in his theory, there's no need for a luminiferous ether. And he's speaking there in terms of an actual physical medium, right? He's going to say we don't need a static ether or a dynamic ether, meaning one that moves rather than the static. We don't need any medium, right? And then he says that in addition to that, he's not going to require any reference frame that is absolutely stationary or has special properties. And he's not going to assign imaginary vectors to electromagnetic processes, which is extremely important because the only way that you can answer these interferometric experiments is through invoking fictitious reference frames, which is explicitly what Einstein said not to do.
Which one of those did you say that they changed the friendships to a different value?
Oh, great question. I'll tell you in 1 second. Let me reconnect here. All right. So let's see here. Oh yeah. Okay. So Hector Manera in 2003 did a series of measurements over the course of 3 years, where he left his interferometer running for 3 years straight, and he got he measured the same sort of sidereal rotation periodicity that Dayton Miller measured, but the values that Miller measured, were not 30 kilometers a second. They were between 6 to 8 kilometers a second, depending on the altitude he was at. And then when he was at 800 feet above or 1800 feet above sea level, he measured 8 to 12 kilometers a second. So he measured a vertical velocity gradient that shares a relationship with the time of the rotation of the sky. So when you plot the minimum and maximum peaks of the speed of light throughout the day from his measurements, it makes a sine wave for sidereal time. So that's what Hector measured as well, that same sidereal fluctuation. But the way that he was counting the fringes, he was just increasing the distance, to them, or the distance between them, artificially, by like just saying like, okay, when he hits his first constructive pattern where it's illuminated, he's just not counting that, and he's just counting it as what's the word I'm looking for? As a fringe. He's counting it as like a black spot instead. And by doing that, he's now changing the velocity ratio when you square that distance. That's why it's invalid. And there was another guy who did that. His name was Marinov. Marinov came up with an interferometer and did the same thing. And the values that they got out of it were like 270 kilometers a second. And then I forget what Marinov's was, but each person that does it tries to give like the velocity that would correspond to like the whole movement of the galaxy with respect to the cosmic microwave background. So that they're just like, well, we have this giant uniform velocity that's all compounded together, which is like, and the reason that's not accepted either is because that would be, compounding velocity addition, which would show that the motion's not relative to individual sections of, arbitrarily defined observers for space-time mathematics. It would show that there's like, that velocity is absolute. So they can't even really like those measurements would never be accepted anyway under the current paradigm because it would be completely antithetical to them.
Okay. Well, the reason I asked is because I've heard somebody reference, I think they said Michelson Gale, and said that we measured Earth's rotational velocity, not the orbital, but the rotation on the axis.
Mm-hmm.
They're referencing one of those and saying that we've got the rotational axis. How are they getting that?
Great question. So remember the configuration. There's two types of interferometer, but it actually doesn't matter what the configuration is that the light takes in the interferometer. That was shown to be in 2004. That was shown that it doesn't matter. But in the mainstream paradigm, interferometers are divided up into two categories. One is called the Michelson style interferometer, where the light makes a right angle to itself, where it makes a cross. And they say that interferometer is a special type of interferometer that measures linear motion. And because relativity is true and the speed of light is the same in all directions, that when you use a Michelson interferometer to take a differential between the velocity of light in the east direction versus the north direction, there's not going to be a change, even though there was a measured change, but they've rounded it to zero and built a philosophy on that. So they look at that interferometer as a special case, and it doesn't measure anything accurately in terms of velocity. You can't use it to measure translational speed, like, how fast something's moving in kilometers or miles per hour, right? Now, when you get to the closed loop interferometer, where light completes a circuit around itself, so the Michelson-Gale-Pearson apparatus was where light was split into a rectangle around itself so that it can go clockwise and counterclockwise in the east-west directions, as well as north-south. When you take the difference in the north-south versus the east-west, what you find is that there's an east-west bias, which creates a phase difference, which is the same phase difference that Michelson measured. But now, because this is a closed-loop interferometer, they're going to turn around and say that this is a special type that can measure angular rotation. It can't measure how fast it's moving, how fast it's rotating with a translational speed, even though it shares the same relationship with the squares. They ignore that velocity component of it, but they look at it in terms of the angular displacement. So when they see that there's minimum and maximum peaks throughout the day where the speed of light is faster and slower, when they plot those same peaks against sidereal time, that comes out to 15 degrees per hour. It matches the sidereal time, which you would divide up using Earth for 15 degrees per hour, or what is it, for a circumference of 24,000 miles or whatever, right? It comes out to 15 degrees per hour. So they are associating that with Earth rotation. And it's the same exact measurement as Michelson-Morley, except they've now taught people to make a distinction between the translational velocity and the angular velocity. And they try to assert one as, well, we can only measure the rotational value of Earth because because rotation is absolute. It's with respect to the fixed point at the spinning or of the rotating, sphere or disk or whatever, right? There's a midpoint there that all the motion of that rotation is relative to. So they say, well, that's absolute, so we can measure that one, and they make allowances for that. But again, they're the exact same measurement. So does that make sense so far? You have any questions so far? One second, I lost audio. Let me rejoin.
Actually wondering is will those readings also change at altitude?
Yes. Let's see. Sorry, I was reconnecting. I heard, will they change at altitude? Was there anything before that?
Right. Because I mean, 15, if you're actually measuring 15 degrees per hour Earth rotation, it shouldn't change with altitude, correct?
Oh, yes, correct. Because it's with respect to the center of their fixed point, it would, and there's no mechanism for any sort of velocity component to it. It would have to be at the same angular rate.
All right. Yeah, because I've heard somebody bring it up, and I wasn't sure because I haven't read that one yet, and I still haven't read it. I guess I need to go familiarize myself with them because I just don't engage if if I don't know, which is probably smart. I I just feel like I know the answer, but I'm not quite sure. But yeah, all right. That makes sense because I was trying to figure out how they're getting readings or they can't get the reading they need. Getting 4 to 6, and now all of a sudden they're getting readings that match rotation. So are they kind of like just
Same
you
exact
said
same exact reading, except the only thing they're not doing is they're not squaring the distance between the fringes. They're just plotting the time in which the peaks are fluctuating throughout the day.
all right. So they're cherry picking what they want to measure.
They're cherry picking how they're presenting the measurement. Yes.
Okay. That makes sense.
Yeah, because you can't say the speed of light is anisotropic in one configuration, meaning there's no difference in the east-west versus north-south directions. It's going to be the same either way, and then use a closed loop where you have a north-south, east-west, where you would have the same exact thing, and then say that for some reason this one is different, right? Now there is a slight distinction in sensitivity. The closed loop is way more sensitive because there's infinitesimally more points of contact versus the right angle cross setup. where the points of light are going to come to a point and then reflect back. So like your points of contact there are going to be less, but it's literally the same reading. It can't be different, right? It's almost like the telescope, one filled with water, one with air. Okay, we have an interferometer. One makes a cross, one makes a circle or a rectangle. You know, the alignment of the variance that's measured in the east-west directions can't be different in one and not all of them.
Oh, I had my mute button on. Didn't Mickelson his ran perpendicular to one another, right?
Yep. Yeah, it made a
Okay.
cross.
Right, right. Okay. One ran north south, one ran east west, correct?
Yep.
Okay. I just want to make sure I still had that straight. You don't think about it for a while and you start questioning yourself.
Yeah.
So
Yeah.
are interferometers more sensitive today than they were then? I mean, by a lot or a little or
I mean, technologically wise, yeah, absolutely, absolutely. A fiber optic gyro is incredible. You can make nanometer measurements of light. Dayton Miller was down to the what was it? Using a specific configuration and setup, he could measure accuracy down to the thousandth of a wavelength. The um, the configuration that Mickelson and stuff was using by default was down to the hundredth of a wavelength. And yeah, like now you can get down to the nano meter, which is not sure the relationship for nano, but it's probably in the millionths of a wavelength or something like that. Whatever nano comes out to be, it's that of a wavelength. So yeah, you can measure motion down to the nanometer. So the phase difference separation is in the nanometers, you know, for accuracy. That's what Wang showed in 2004. When I said earlier that it doesn't matter about the configuration, if it's a right angle to itself or if it's a closed loop, which is just adding another right angle to itself to make the loop, it doesn't matter. You can still measure motion down to the nanometer linearly or rotationally.
so we're talking orders of magnitude
Mm-hmm.
more sensitive.
Yeah.
Okay.
Yep.
Yeah, because I figured technologically we were better, but I didn't know, like you might have, better equipment and everything. I just didn't know if it was reading that much better.
Yeah. Yeah.
But orders of magnitude's
Yeah,
a
Wang.
huge difference.
Yeah, Wang's got a nice linear graph to show the motion, and then if you let's see, there was a neutron beam created out of a nuclear reactor, and using that, they were able to measure that same kind of angular displacement that Michelson Gale Pearson did. So they made a closed loop out of this neutron beam coming from a nuclear reactor, and when they took the interference pattern from that, the minimum and maximum peaks, it measured the sidereal time. Like it measured just sidereal fluctuations, and that wavelength of what was used there for that is 10 times 10 to the minus 10, which is known as the Armstrong wavelength. It's like one of the smallest possible measurements you can make. So they've got like really precise measurements with these. Now, obviously, you can't hook up a interferometer to a nuclear reactor for like practical purposes and whatnot, but measuring sidereal rotation down to 10 times 10 to the minus 10 is very impressive.
No kidding. So that would validate Dayton Miller then, wouldn't it? With his sidereal time?
So no, well, in the paradigm that it's like viewed in, right? They like attribute Miller to experimental error, didn't know what he was talking about, measured nothing, blah blah blah, right? So they wouldn't acknowledge that. But yeah, any configuration that measures a sidereal periodicity is confirming Miller's work in that respect, because that is what he measured.
Yeah, I just feel like they're really robbing him.
Dude, it's the greatest robbery of all time. It's really, really unfortunate. One of the greatest scientific crimes in history. Wilson Morley and the corresponding cover-up with Dayton Miller's work. Yo, what's up, Dom?
Hello, guys. Morning, everybody. I didn't want to interrupt, but I think it's. I just want to say it's amazing that there's some replacement for Flat Earth Fridays, because as I said it on our Discord, I think now is the most important time to not like stopping Flat Earth Fridays, because this is like only place when people can gather, and this is some kind of a safe haven for everybody, and we can share our thoughts and ideas here. And I think it's now in these days it's super important that this community continues. So I would say it's amazing that Ether Cosmology, as Sue, Alan, Shane, Piezo, Stone, and all other are doing this, because this is the most important. Because imagine if there wouldn't be any Flat Earth Fridays, like where would people share their thoughts? Where would people like gather every week? So it's a most this is like most important, because in Czech Republic and Slovakia we did like this exact thing as Flat Earth Fridays is, and it was major for us. Like the community tied together, and everybody's helping each other, and this is like a way to do. Because if there was something about the final observation, it was to divide us. Like the whole purpose was divide et impera, divide and conquer. And if we divide and stop gathering, they won. So I would say it's an amazing job what Alan and others are keep doing, and I will be keep listening, because I have a guest in today at my home, but I will keep listening, guys. And I just wanted to say it's an amazing job. So props ups. And if you like want to support any of guys from Ether Cosmology, you can find their links. If you just click on Alan profile, you can find his like coffee links and everything, because they will need the support for this to keep going. So if anybody like it's under like possible to support them, do that, because it's important to support each other, guys.
Dude, thank you, Dom, for an endorsement, man. And same to you, and you building up the international variant of Ether Cos, bro. Support our boy.
Yeah, we need to, and this is amazing, because like I was listening for about 2 hours right now, and like everybody needs to realize that if you want to find out something about physics and about Flat Earth from like a physics standpoint, there's no one better than Ether Cosmology. So like if there's any source of new information for this community, it's always from Ether Cosmology, guys. So I think it's amazing that they are doing this, and you can just even listen. Like Piezo had this debate with Happy or whatever his name was. It was amazing. Like everybody who was listening, you can learn so much just like from these I would say debates or exchanges. It's amazing. So this is the way. Like nobody ever measure Earth motion, and we are like squirting and pondering about stupid sun observation. Like Earth is not moving, and we have like measurement for that. So we should be caring about the physics and not about the nonsense that the mainstream is trying to put us into.
Dude, well said, Dom. Unit cohesion works best when everyone has a place to congregate and voice their opinions and stuff. And yeah, that's why I wanted to carry that on while FEF takes a break for a minute.
Yeah, I'll be honest with you. I like how you guys have tackled Aries failure. I told Mr. Xavier, I don't know how long ago we talked about it, that I just really liked Aries failure because it was so simple in structure that, it didn't get, it doesn't get deep into maths and everything else. It's a very simple experiment with a very simple premise that I think anybody can understand. And you guys have reduced it to now it's, it's not just
Is 3
showing
equal to
that the
4? Like,
yeah. Well, I mean, not even that. I mean, if you get past the fact that it shows that the Earth doesn't move, now it's like a tool to see, how much cognition you're dealing with when you're talking to someone. Seriously, it's like a benchmark. If you can't get anywhere with someone with that, they're either stupid or they're disingenuous. I mean, what else can it be? I mean, Piezo explained it tonight so simply, and you guys have been talking about this and talking about it and going over it, and it just gets simpler and simpler. And he couldn't have explained it any better. 1/3, 1/4. What part don't you get? And I listened to Halfro. I listened to him talking, and when he says that, whether you set it with the air or you set it with the water, doesn't matter. When you change mediums, it's still going to hit center. And I said, yeah, the only way that can happen is if the Earth isn't moving, because if that telescope's moving, that angle's not going to be right for it to hit the center. And for whatever reason, he doesn't see that, or he doesn't want to see that. But that's why I quit talking to him about it.
I think that Piezo pointed out most perfectly. Like, I don't think they are doing it intentionally, and it's because like they know that they are arguing about their position and about actually like their whole life, because like everybody have like this where we live. They have to tie it up to their personality, like their worldview is tied up to believing the Earth is globe, which means when they are start arguing about it, they have to like always tell us that we are the wrong, and it doesn't matter what we say, even like if they agree on some point. When the conclusion of the point is that Earth is flat or stationary, then they will start arguing again. Like they can't help each other. Like Piezo just pointed out super well. It's cognitive dissonance, but like in the way that they have to argue. Like it's not about they're like not intellectually honest or stuff like that. Like it's in their DNA. I would say, even like they have to argue for the things that they believe that they live on. And it was funny like listening to this debate. It was amazing. Like I even like heard when he was agreeing with Piezo, because it was the most like logical thing to do. Like when we don't talk about if the like if Airy failure, like the conclusion wouldn't be that Earth is stationary, there wouldn't be any problem with this debate. Like every single astrophysicist would be like, yeah, you're right. Like it would be angle change, right? Nobody would ever like dispute this, but because the conclusion is that Earth is stationary, everybody have to argue about it.
That was my favorite part too, when he actually conceded to the fact that, hey, what if it came out of the box with water in it, right? With the trajectory of that light hit the center. And if we remove it, will it still be in the center? And you heard that dramatic pause and like, oh shit, this is the crux of my my problem here. And as Pietro greatly pointed out, you hit the reset button in your brain somehow just so you can't acknowledge.
Exactly.
No, he accomplished that at least 2 or 3 times, where he walked him right to the precipice, and right when Hapro was ready to step over, he realized he was gonna fall, and he stepped back and reset a couple of times. And I think Alan had it right when he said, "No, no." He just realized it right then, and Alan was right. He did realize it then, because he was literally arguing for a stationary Earth, that it would not change. But if you have the telescope in motion, the 1/3 lined up is not going to hit the center when you make it 1/4. The angle has changed. Piezo just broke it down as simple as it can get. That was just you. I don't know. I don't know how you could make it any easier for anyone to understand. If I can understand it, I know Hap should be able to understand it. He's. I know he can do math. I've seen him do um, the math for because he disagreed with me on Stone's calculations for Earth or the sun having 2.5 times more pull on the moon when the moon is between the Earth and the sun, and so that it should pull off. And he said, "No, no, no, you're wrong." And I said, "Well, the guy that did the calculations is a mathematician." I said, "I can't do them." I said, "But I know he can do them." And he said, "Well, I can do it." And he said, I'll come, I'll let you know." And he came back and he said, "Well, I got 2.6 or something like that." And so he wound up having to agree with Stone's calculations, you know, and it was just kind of funny. I know he can do the math, but he's got to understand that. Hell, everybody in this room could understand what Piezo was saying. The only way that you can change the medium and get the starlight to not move is if the telescope is stationary. It's already coming in at the right angle. So yeah, I don't. You can't. I don't know. I'm gonna say it's Cog Disc because I know he's not stupid, and I don't want to call him a liar. I think he just really needs the Earth to be moving. I think he's spent his life with an Earth moving, and he needs to believe it until the day he dies.
Unlucky.
No kidding. I would hate to think that evidence couldn't persuade me.
Yeah, especially when the evidence is like your own gross misinterpretation of it.
What I couldn't understand is the part where he conceded. It should have been more comfortable to get to that edge where you could be like, you know what, that is very interesting. Let me think about it and get back to you and do some more research. That could have been easily done. And I like to give people the benefit of the doubt too. But as Beasley or who else pointed it out, that he was having technical difficulties way above the statistical average. So it's like right when we get to the crust, we couldn't get to the end of that. But regardless, man. I don't see why he did not want to continue and say, hey, let's just bring it to the timeline instead, where we could just type this out for 3 or 4 days and not get to a conclusion. Didn't make sense.
Welcome, Lily. Not to be confused with Ambassadress Liliana. Different Lily.
Oh, I've got some charts and graphs here to make it clear.
Nice. Welcome.
Would it be too unscientific to suggest that intuition and childlike sense of wonder is maybe how we get the answers we seek?
Probably wouldn't disagree too hard with you there.
You should play devil's advocate just for the crowd.
Oh, yeah, that's unscientific. Oh, yeah, that's unscientific nonsense, woman. What are you talking about?
That's not peer reviewed. That's not modern. Oh my gosh, you're right. Isn't that the thing about intuition, though? It doesn't feel right. It feels uncomfortable almost.
Is anybody talking?
Yeah, I was about to ask the same thing.
Yeah, everybody's audio is still functioning.
I have maybe a question for you, Stone, if you have a minute. Did you see like the Melodome reaction on the sunspots? Like he made a video. I think it was like a reaction on your videos, and I didn't have like time to catch up on it. So did you like see it, and what do you think about it?
Oh,
I've seen half of it. What's that, Alan?
but before we get to that, there was another one that he just put out today. We went over some of his data earlier in the day, and it showed what Stone was saying that it didn't show, in regards to the wobbling aspect of it.
Yeah, there was actually 2 points I wanted to mention. In what I've seen of his response so far, some out of the cave, some I've seen half of the live thing you guys did about 7 hours ago so far. And the first point is that I wasn't aware that he was shooting at 9:30 in the morning. It just seemed natural to me that if you're going to shoot a shot of the sun the same time every day, you would want to shoot it at noon when it's all nice and straight up and looking at you in the sky and easiest to level and that kind of thing. Apparently, no, he was doing 9:30. And I liked his I guess confirmation about one assumption I had to make about that regard to our relationship between the ecliptic plane of the planets and the rotational plane, allegedly the viewed rotational plane of the rotational axis rather of the sun's sunspot movement. And he's saying they're nearly the same and that they oscillate almost like the ranges of each oscillate within each other. And he released his own observational pictures. Let's see, get the date right down here because I'm in the middle of processing them, down to January 17th, which is about 2 months worth of data that I didn't have until now. So I'm adding about 2 months to the analysis, and I'm crossing against our apparent change with relative to the planetary ecliptic using a piece of astronomy software that I always use, so I'm comfortable with using it. And I'm charting the two and checking the angle between them month to month, just like we've looked at for the rest of these things. So kind of, I'll get back to you, but actually right now it looks to be like he's making a pretty good point here. I just need to check the actual angular relation between the two cycles. Do the work that Mello obviously is not doing, when all he does is slow it down for you and see, look, the dots are kind of going ish. You know what I mean? That it's really hard in terms of human visual immediate memory to graph that temporally without any visual aid whatsoever. And it's too bad that Mello can't see that or can't do something about that. So I'm kind of meeting him here at his level of need. And yeah, I'll get back to you. I'm looking right at it real closely.
Awesome.
That's super cool from you. Sorry, Aaron. That's super
Alright.
cool. So
You're good, bro. I wanted to add that he did make the corrections to the images that were taken at 9:30, so that they're corrected for what they would be at the local solar noon. And at the end of the video, he shows some diagrams that have like some nice arrow pointers and like a ruler to kind of show the direction of the wagon wheel tilting that they go through throughout the months. So maybe at the end there, like it'll look a little more apparent. But to me, it looked pretty straightforward. That it does have an axis of rotation with respect to.
It does look kind of convincing, and that's why I'm taking the time to more closely analyze it and give him the benefit of the doubt. And I don't know what he means by he's going to be correcting these shots for noon, because that's kind of hokey. That's just kind of changing their apparent rotational angle all the same and just incrementing them over whatever that's going to be. 3 hours at 445 degrees ish. If he's just going to rotate his images, I don't think that's going to help the analysis. What we need is what he's already got. If he's shooting them all at 9:30 and then with daylight savings 8:30, in the summer, I'm actually accounting for that as well. My astronomy software just allows you to switch daylight savings off so that all of your observations are at the same time of actual solar day. So that's working out. But yeah, I don't know about that correction, but the rest of it, I think he's moving in the right direction. There's just so much more that is necessary to his analysis to feel confident about any kind of angular conclusion you're making.
Nice. Well, I'm glad that the conversation is continuing, and I hope that one day you guys will speak together and have a nice theory crafting session. But yeah, dude, that's awesome, man. I'm looking forward to see how it all plays out.
God, Elon keeps turning down my mic. Is my volume just going tanking as I'm speaking?
You sounded fine the whole time, but Elon is definitely doing something going on tonight.
Okay, so like the gain coming to you, it was like audible, loud enough that you could hear me. Because right now I'm pulling the slider back up. Am I louder now than before?
You sound the exact same.
Okay. Well, then Elon's playing a really magical game with my mic input slider while I'm talking. It's kind of bizarre, but whatever. I just thought I'd check.
Yeah, it's insane. I have no idea what's going on. I've been having the worst issues with it the past month and a half now. Like unbearable. I've had to reset multiple times.
The guy can
tonight.
catch rocket fuselages, but he can't get audio right on his fucking spaces. Like what the hell?
Get it together, CIA.
Well, the guy who are you talking is faking game. So when he's faking like a record in game, why would he like faking another stuff?
I guess that is consistency with form meeting function here. Yes, I will agree totally on that point.
Nice. Yo, what's up, Uvalde police cowards? I see you out there in the streets. What's going on?
Oh, well, I just joined, so I'm just kind of listening to catch up. Is all of whatever you guys are talking about. Sounds like it was a plus with I know Ken being here. Sounds like it might be a pseudoscience kind of flat Earth thing going on, and yeah. So I just wanted to hear what people were talking about.
Oh, okay, yeah, no worries. Yeah, that's pretty much what's going on here. So if you have any questions or anything like that, feel free to chime in whenever you're ready, sir.
Oh, well, okay, I think that okay, guys, let's start a whole other topic. And sorry if I'm derailing anybody else's topic that they were going on, that you guys are going on, but I think that a big part of the flat earth movement is predicated upon people not knowing that in science, you don't prove things, you can only disprove things. And so that's why you see a lot of a lot of flat earth people saying, prove this, prove that, prove this, and prove that, because they don't understand that in science, you disprove things, you don't prove things, because in science, knowledge is tentative. Things change. You can show something one day, and then the next day, something new will come about. That's why science is, can be
Dude.
wrong a lot of times, because it's a process. So yeah, boy, yeah.
Well,
Sorry.
no,
I
you're
guess
good.
I'll
No, you're
stop
gonna,
with that for a second and let you guys
yeah, you're
say
gonna
whatever.
love this space.
Well, a quick question: would it be accurate to say, using that principle of falsification that you kind of hinted to, that you're proving your null hypothesis when you're engaged in the scientific method?
Oh man.
If science is disproving things, then you're proving your null hypothesis, correct?
Proving your no hypothesis. I suppose so, because it can be, considered to be disproven. I suppose if we want to twist words around, can you prove that to be wrong? Then yes,
Right.
you have
The
a point.
principle of falsification is contingent upon the cause and effect mechanism. So if A were to cause B, and later we to find out it's a subset of A that causes B, then it wouldn't be completely wrong. It's just refining your interaction. So it's not really wrong, where you're just getting closer to the truth. So you're proving your null hypothesis to get more accurate to the truth. So however you want to phrase it, when we're asking, did you comply with the scientific method, we're asking, did you adhere to the principle of falsification? Does that make sense?
I think so, and I mean, yeah, I mean, you're not, at least from what I understand from what you're saying, yeah, you're not wrong. I mean, you can disprove something, you can prove something wrong, or
Nice. I agree. Would you like to hear my oh no, it just ended the space. Dude, no way, bro. What? Dude. Rip. That's a real shame. Oh man, gotta get that guy back. It's crazy. Oh, I apologize. We're gonna try and rebuild real quick. What was that, guys? Huge.
Yeah, that was something.
Dude, how unfortunate. Dude, Xavier hit me with the best tee off ever.
Well, at least you still got it recorded on your stream. People can review all three parts.
Man, dude, that's so unfortunate. We might wrap up after that. I'm so demotivated now. Oh, dude, Elon broke my spirit, dude. I'm so demotivated now. I waited my whole life for that guy to join the space and bring up the null hypothesis. Dude, no, no. I must find him again.
Well, if he has superior skills, he'll find us right here.
I hope so.
So like part number 3, which means like it's crash number 3, or
Yeah, so earlier my power went out an hour into the stream. So that's, we're off to a good start right there. And then just now the, space just hard crashed right when we got into a null hypothesis.
yeah, like the null hypothesis, like people love it in Czech and Slovakia. Like so
Dude,
many
it's
people
so good.
like, had to rewatch the episode. Like it's dense, but when you like realize how it's work, it's amazing. It's such an easy way to debate.
Yeah, because that guy was dead right. It was like, you don't prove things, you falsify your null. He's like, yeah, no, I agree. Like, dude, exactly. Yeah, we'll give that lad a couple of minutes. We'll see how things go over the next 10 or so minutes for the rebuild. And if it's dead, we'll just let it die quietly into the night. And we'll prepare for the Czech Prezi at 2 p.m. Saturday.
Right.
There he is. He's back.
Get the man the mic.
Never sent a mic to a man so fast in my life, bro.
Hey, I'm sorry. Boy, I'm having all kinds of. I don't know if it's my phone or what, but I apologize.
The space crashed out of the nowhere. Like I think that Elon didn't like your null hypothesis analyze, but we like it.
Good. Well, I'm glad it wasn't just me. So thank you. But anyway, thank you for giving me the mic back so quickly. And I forgot what I was saying. But yeah, if you guys have any questions, what I was talking about before about proof in science versus disproving,
Dude,
please let me know.
Absolutely. I completely agree with your assessment so far. And I recently came up with a way to present the flat earth arguments in the form of a null hypothesis so that it's a more scientific and academic approach that can provide statistical significance for, evidence for or against the shape of the earth. So my premise to start us off is that using the sky to prove the shape of the ground, you cannot use you cannot use objects in the sky and their positions to tell you what shape the ground is, but you can use it to tell you what the shape isn't, right? Through the falsification method you were stating earlier. So we're going to have a null hypothesis and a competing alternative hypothesis. Everything tracking so far?
Yes, I'm tracking, but I don't agree because you can confirm the shape of the Earth by simply using Polaris and driving 69 miles north or 69 miles south to a 1 degree latitude difference, and confirming the angle of Polaris changes by exactly 1 degree. So I am tracking what you're saying. It's just like I said, I don't agree with you.
And the bromance has ended.
It was so quick.
So what you referenced, right, is actually part of my null hypothesis specifically. So hear me out here. Maybe we can reach an agreement here. So for the null hypothesis, I'm going to say that the Earth is planar and measurements of curvature are dependent on the position of celestial bodies. And then my alternative competing hypothesis is going to be the Earth is globular and measurements of curvature are independent of celestial bodies. So far, we've referenced 69 miles per degree as a deviation for positions of celestial bodies in regards to the shape of the Earth. And I'm not even denying the relationship yet, or making a counter argument. I'm just saying that like what you propose is already in my premise so far.
I would feel more comfortable saying Polaris because by the time you go 69 miles, other objects in the sky are going to be different because they are rotating around Polaris. So I would feel more comfortable saying or sticking with Polaris instead of all other celestial bodies.
Well, any celestial body, doesn't matter any of them, right? This is like all inclusive to any celestial reference, because people will often say the Earth measures flat, and some people will say the Earth measures curved, and you'll have some people say, well, if we make no assumptions and we just look out and we take this measurement and it's the reference point of how high we know, or like how big we know this mountain is or whatever, and how much it's below my theodolite, etc. Like the missing difference would have to be Earth curvature, even if we make no assumptions, right? So we have these different ways that people are looking out optically to determine Earth curvature, but really you have to make an external reference because it measures flat or curved with respect to what, right? So it's going to be with respect to the position of the stars. And now I agree with you that there is a latitude dependent relationship, but is this relationship mutually exclusive to Earth curvature, or is there an optical equivalence there? And if there is, we would have to use another way to falsify that evidence, because we're using the thing in question to verify both of our positions. So it would we would be at like an impasse there. We would have to move to an external source. So if that makes sense so far, I would like to present to you a 69 mile per degree optical equivalence that you can take a look at. Now, I don't expect you to look through the whole thing immediately or whatever, because there's a lot to it. But premise wise, can we agree so far on what I've laid out?
Well, I was going to say no, but if you have something that you would like to present, then clearly that changes things. So I would be curious to see what you have.
Awesome. Give me 1 second. Let me reconnect again because it's doing the echo thing. All right. All right, testing 1, 2. I'm back. Okay. So I put in the Jumbotron, if you're familiar with what that is. If you click up at the top here on the panel, you'll see an Obsidian database link that says 69 miles per degree. And what this shows is the optical equivalence of our radius of vision applied to the sky. So you may have heard things like, the sun is 93 million miles away. The nearest star the nearest galaxy is Andromeda, which is, what was it, like 5-6 light years away, something like that. And then, various stars will be hundreds or thousands of light years away. You're kind of familiar with that sort of thing in cosmology and astronomy?
Yes, but the Milky Way is about 100,000 light years across, and Andromeda is a bit further than that. But I see what you're saying. Your distances are wrong, but yes, I follow you.
Gotcha. Okay. So what if I told you that everything in the sky, all these positions of the stars, all of the planets, the moon, the sun, can all be treated at an equidistant web around us that's the same distance of 62 6,214 miles. Would you agree to that?
Can you repeat that one more time, please? Sorry.
Yeah, you can treat any object in the sky regarding celestial bodies. So sun, moon, planets, Jupiter, like their moons, etc. The stars, any star, anything in the sky that's a celestial body. You could treat that in terms of being at an equidistant web from you, meaning that if it's above you right at your zenith, it's 6,214 miles away from you. If it's at the horizon, it's 6,214 miles away from you.
No, I'm sorry. I'm not following.
Okay. So for the purposes of celestial navigation and how to use the latitude and longitude system, how it was derived based off of the relationship that you mentioned earlier with 69 miles per degree, the way that is derived is based off of taking cosines to stars. But in order to complete a cosine, you need to know two parts of the triangle. So they set an elevation height for everything in the sky arbitrarily set at 6,214 in terms of miles. And then the elevation angle between, you and that 6,218, or I'm sorry, 6,214, allows you to compute a distance as a ratio of that angle. And that unit of measurement that's used for that altitude, that 6,214, that is the linear version of a terrestrial meridian. So a line that goes from the North Pole to the equator, north-south. That distance represented by 69 miles per degree is 6,214. So 6,214 miles from North Pole to the equator if you straighten that out. That kind of makes sense so far?
I'm sorry, but no. No, I am not. I am not tracking what you're saying. I'm hearing a lot of words.
No, I got you.
Cosine, adjacent over hypotenuse. But I'm not following what you're trying to say.
Okay, so in order to establish the 69 miles per degree relationship, right? You would say that it's due to you traversing a curved surface and you're now kind of like at an angle to the original position of the star that you were looking at it at, right?
Yes.
Okay. We would say that there's the same effect that occurs traversing over a plane, with topographical features more or less, right? But in terms of the displacement of the stars with that relationship, this is going to be due to an optical effect. And we're saying that the radius of your vision is the same as the radius of Earth. So in other words, the way that you perceive the celestial sphere relative to your latitude is going to be identical to what you would see if the terrestrial sphere were curved, because the rates would be the same. Does that make sense so far?
So no, I'm sorry. Say that again, please.
Yeah, no worries.
Sorry, man. Yeah.
You're good. You're good. So think about this. Street lights above you, right? You know how they converge into the horizon and they appear to be lower than they are? But if you walk underneath each one of them, it's going to rise above your head and then be at your zenith, and they're all going to be at the same height.
Right.
Okay, so if you apply that same concept to things that are higher than the streetlights, to the celestial bodies specifically, we're saying that relationship that is caused by your perspective doesn't stop at any altitude. It's just a function of your optics. So instead of being curved at 69 miles per degree, the curvature would be due to how you're perceiving it. It would be saying the curvature of your eye, essentially. You would kind of relate that.
Okay. Yeah. Great job in your explanations. Yes, I'm following you, and I appreciate your patience, and I appreciate the fact that you can continually break it down. Because, well, who was it? Einstein that said that if you can't explain something simply, it means you don't understand it. So, yes, I understand what you're saying, and I appreciate that. And yes, what you're saying is feasible, but when you take into account everything else, the evidence seems to stack up to point towards a round, curved surface. The fact that there's 69 miles between 1 degree in difference in angles of, of Polaris, let's say, not any of the celestial body, because they, all rotate, so they'll change, especially if you go from point A to point B, which is 69 miles apart, and they're busy moving in the sky. So that's why it's good to focus on Polaris.
No, well said, man.
Sorry.
Well said. You're doing great. So remember, though, our starting hypothesis is that we're looking for curvature that's independent of the position of the celestial bodies. But so far, we haven't covered any other types of evidences yet. We've only referenced the 69 miles per degree, which we're examining now, and we're discussing, a potential optical equivalence between Earth curvature and ground curvature. And if you can agree to that premise, like, even though, like, it might not be true, or you might find issue with it later or something, but if you can agree to the premise of, like, okay, if these things are the same and there's an equivalence there, then we would have to look at a different type of evidence rather than positions of celestial bodies. We would have to go to maybe ground measurements. We would have to go to maybe geometric properties of shadows during sunsets, because they're going to have mutually exclusive predictions for what will happen due to physical obstructions causing shadows versus the shadows being produced by an object that's always above the horizon as it goes away from you. So there's going to be different outcomes there. So we can look at different things that will have different geometric outcomes. But so far, the evidence that we've examined, there's an equivalence between the two, and we can't use it to falsify either of our positions so far.
With what you're bringing up, yes, I could see how more evidence would be necessary based on the fact that you found a reason to dispute, the confirmation of 69 miles should be 1 degree difference. And, anybody can confirm that by simply driving, an hour north or an hour south. But yes, I'm following you.
Okay, cool. Great. So the next thing that would come up would be, remember, we're looking for measurements that are independent of the positions of celestial bodies. So one may think that geodetic surveying would be, evidence of that, right? Because we're looking off at the horizon, we're taking measurements, we're seeing if things are below our theodolite a little bit, the horizon line. We're looking for, substantiation of curvature based off of a radius, right? So have you heard of geodetic surveying before?
Yes, I'm familiar with geodetic surveying.
Cool. So the baseline for geodetic surveying actually comes from the positions of the stars as well, and all the geodetic surveying projects. For example, the Arc of the Parallel measurements, like the big ones that we're all familiar with. What they did was they took horizontal measurements, and then they would take zenith angles to stars, and then take zenith measurements to them to confirm the difference between what they were measuring on the ground and where they expected the stars to be. Because ideally, if you complete a cosine for a triangle, and you traverse the distance on the ground, you should take your theodolite level it out, and when you look up, that star should be right in the center of it, right? Because you're completing a 90-degree triangle, assumedly.
Yeah.
What they found was that the stars were always off a little bit. And this goes back even further than the geodetic surveying that was done in the early 1900s. This goes back all the way to the Nautical Almanac with the reference ellipsoid model, where in the 1960s, people were asking the British Crown how they came up with the correction angles for the Nautical Almanac. And basically, that was one of the first geodetic surveying projects that they did, where they went around co-signing the stars and taking measurements, and then finding that the stars were never quite where they were predicted to be when they established their triangle. And so they took the difference in the position as due to, you know, the Earth being slightly round or slightly flat in that area, and they came up with the ellipsoid model. So the corrections based off of the deviations from the assumed position where it should be versus where it was measured at, they take that as a deflection of the vertical, meaning that they have to like physically tilt their device because the contour of the Earth is a different shape, and then that's why it's off level, even though it appears to be level. But like locally, you're standing at kind of an angle.
So are you a flat earther?
Yes, sir.
Okay, now for some reason my app doesn't seem to work. Who am I talking to? Because it doesn't show who's speaking.
Oh, you're good. You're talking to Alan.
Oh, the host.
Yep.
Oh, gotcha. Yeah, I don't know why. Sometimes it shows who's speaking and sometimes it doesn't. Okay.
Yeah, Twitter bugs out all the time. It's very poorly run.
Yeah, man, it's frustrating. So okay, Alan, here's what I don't get is you're clearly an intelligent person. Why are you not following what all the evidence that we have suggests?
That is a great question. That's a valid question, man. So I kind of you can think of it like taking the Pepsi challenge, right? Like right now, we're going through different evidences that are assumed to be mutually exclusive to a globe. We got this nice latitude, longitude, spherical coordinate system associated with it. We've got units of measurement that are derived as fractions of the coordinate system itself. So when you do the cosines to the stars, you're confirming the distances, with reference to the coordinate system itself, which is based on the position of the stars at a specific time of year. So when you go through these things, and remember, our null hypothesis was that we're looking for ground curvature independent of celestial bodies, and we go through different mutually exclusive outcomes for different scenarios, like shadow sets, radar beams that airplanes fly through to do bombing runs, projections of north-south circumpolar orbits for satellites, and terrestrial navigation with planes. And what we find out is that none of these things correspond to going north-south over a globe and coming up the other side. We find that the radar beams that were used only work when they're going over a plane, and a plane is flying, parallel to that plane in these radar beams to do the bombing runs based on the distances and the angle of the width of the beams and stuff. We can get into like more of that on the specifics, but there's like geometrically impossibilities if the Earth is truly globular and the coordinate system that we're using is representative of a ground shape that has 8 inches per mile squared associated to it to give us that radius that we're all familiar with. And when I went through all of that evidence, the only evidence that was put forward for globularity came in the form of positions of celestial bodies, and then in particular, like the 24-hour sun situation, which would be like a nice one, right? But when you get into optics and your dome of vision, I mean, I could give an explanation whether or not it's true or not. I can give a logically consistent explanation with my cosmology and optics for it that doesn't require me to use that as the proof of the shape of the ground.
So we have millions of pictures from different sources, not just NASA, different various sources. We have live feed, video, people with iPhones, and all these things can be and have been explained using the globe model. So why are we trying to find different explanations with all the evidence of the Earth being a globe? Why are we trying to find different explanations for all these easily explained things?
Yeah. So one of the first things when I came into Flat Earth was looking at what I call now space propaganda. And that was, these live feeds, ISS feeds, feeds of the Earth, et cetera, from the Discover satellite, from the Himawari. And what I found was pretty incriminating, or at least gave me the impression that, now that reasonable doubt has been created for the authenticity of these images, I can't very well rely on them in a meaningful way. And I'll give you a couple examples of that if you want to hear me out. So for live feeds, you can access the Discover satellite, and you can actually get raw images from it that you can compile yourself. But the data that you get is sanitized. There's no metadata associated with it, and you have no way to confirm the process in which the data was basically turned from, or how it was turned into the image that you're compiling. And what you'll also find is that the data set comes with two sets of images. One set the orientation of the images in their raw form are always vertical. Or no, I'm sorry, they're always horizontal. And you want them to be vertical, but it comes with two data sets in it. One's already been compiled and orientated correctly. So it's like, even though we get this quote unquote raw data set, it's not even raw. And then if you were to try and introduce that into the court of law or something like that, you would have to verify the chain of custody. You would have to have some man testifying to the authenticity of the interpretation between the photograph and the machine that processed the raw data, and the programming that went into that sort of thing to do the processing. You'd have to have someone testify to verify all that. We don't have any of that. We have anonymous images from the media given to us from the organization of NASA, SpaceX, et cetera. And then when we get to the Himawari, right, we're told that this is like a 15-minute time interval of live images of the Earth. Well, when you look at the images, you'll find that they're spliced together through, you can zoom in on them and see the purple line that connects all the images for one. So they're not an image like the way that they present it, as it's like a whole picture of the ball. And actually, there's a public FTP server that you can access. I can send you the link to it, and you can download all of the simulations for the cloud and weather patterns for the next 100 years projected out. And you could see the different simulations of a disc that they have. It's basically like one side of the ball they're trying to present it as, but it's like a flat disc, and it has all the continents on it and how it's laid out. And you could see what weather pattern projections that they're going to overlay over it. And this has all been, plotted out over, like I said, over the next 100 years. So the idea that they couldn't take, that they don't already have this stuff kind of simulated out and then it just gets released, And it doesn't even follow the 15-minute time schedule. It's often 30 to 40 minutes late. But anyway, the idea that, they couldn't do this in real time, et cetera, et cetera. It's like, well, they really don't do it in real time. They've already got it simmed out with different projections. And then nobody confirms the cloud accuracy and the cloud data or anything like that. And I don't even know that you could necessarily for your localized clouds that you're seeing. Like, I don't think people are out there, fighting that. So like anything that they show is probably going to be good enough for everything. And then on top of that, there was the one instance where there was like a volcano erupting or whatever, right? And they had live footage of that. And that was like the one time that they had like really quick footage of it. And it's like, okay, so for this one instance where there's an actual event going on and they have tons of, excuse me one second. They have tons of radar and balloon coverage of it from weather balloons, like not even saying that satellites are weather balloons or anything like that, but just they'd send up thousands of weather balloons all over the world every day to gather data, gather weather data and stuff. So anyway, they've got all this real-time data from external sources. They've got this model that they can overlay the images and stuff in real time. And to say that like that couldn't be faked, specifically or whatever, the one time that came out, I don't think that's a reasonable take on it. But in terms of the authenticity of everything, it's just not quite there for me to give any credence to it.
Okay. I hear you, and I think what you're saying really all falls in line with in real science, you can't prove anything. There's no such thing as proof in science, but you can disprove things. But so when it comes to what do you think, you go off of, what does the evidence show? What is the, there's evidence upon evidence upon evidence. And you remember, knowledge in science is tentative. So, it could change tomorrow, but we have such an insurmountable amount of evidence that the Earth is round. For example, why is it 69 miles? Why is it 69 miles, give or take a mile, between degrees in which you'll see Polaris as far as the angle in the sky?
Yeah. But like I was saying earlier, there's an optical equivalence there. So, and then so like the reference to the unit of measurement, like the mile relationship to 69 miles per degree. Well, the mile and all units of measurement are not actually independent of anything. They're ratios of the terrestrial meridian, which I said earlier was the flattened out distance between the North Pole to the equator. So if you look at an AE map, you'll notice that the only straight lines on that map are in the north-south directions, the ones that are going from the north to the equator. So if you take that straight portion there, that linear distance is 6,214. So that would be our limit of vision. So if you were standing at the equator and you were looking out, or let's say you were standing 69 miles shy of the equator, right? Polaris would be 1 degree above you in the horizon. And that would be purely due to optical effects, and the distance relationship there comes as a fraction of the terrestrial meridian itself. So a meter is 1/10 millionth of that distance of 6,214. And all units of measurement are ratios of the meter, right? Everything goes back to that. And all of those go back to nautical miles, which is a ratio of a circle, which has largely been undefined and changed its meaning, changed its values throughout history. It's hard to track it down, but basically using that as a ratio of a circle, this is how the units of measurement are related to the sky, because circumference and radius are not exclusive to a sphere. You can use them on a plane, on a disk as well, like just a circle, right? So, that's why all of these things work in relation to like for example, using the Haversine formula to derive a distance, because the reason that works is because you're using a spherical coordinate system. You're using a system of the stars that's been merged, in two hemispheres. So if the optical equivalence is 69 miles per degree and we get to the equator, well, now we have, so we have a northern hemisphere. We see in a northern hemisphere, and then we have the southern hemisphere. So you start mapping that out. Well, to merge the two, what you would have, right? Because if you're in the north and you're seeing things go off into the horizon, you could say that they're setting and they're falling around the globe, due to the Earth curvature, right? Or you could say that they're at your optical limit of vision, and they appear to be setting into the horizon because of that optical effect, right? It's bringing it down closer to the horizon as it has to merge to the ground, similar to how the the street lights above you do the same thing, right?
I'm following. Yeah.
Yeah, so that would be why you can use this system and why it works, because it's spherical, and the function of things going beneath your feet due to Earth curvature or optical would be a function of math, where you just use negative values to represent the same thing that you were using for the positive values in the north. So with that, you would have two hemispheres that you could merge together, and at that limit of vision, at that maximum distance optically or Earth curve wise, you would have the same exact relationship. And now you would have a complete spherical coordinate system that you could project onto any different type of map projection, and you could use it for anything, so long as you use it correctly for the projection that you're projecting it on. And it has no relation to the ground yet, because remember, we haven't measured anything on the ground. We've taken measurements from the stars and traversed the ground using ratios of measurements that are derived from a coordinate system that represents the positions of the stars. So we're kind of like locked into this reification of what people think the projection represents, rather than independently verifying what the ground is doing with respect to the stars.
With science, it's a matter of confirmation. That's why they make predictions, right? They'll make a prediction to confirm whether or not their theory,
100%.
was correct, right?
Yep.
So why is it? And I think you should open up to anybody. Why is it 69? Again, give or take a mile, 68 to 70. Why is that the amount that you will see Polaris change a degree in the sky?
Okay, I see what you're saying. Let me answer with more specificity. So, under the premise that we have a radius of vision, that implies that there's curved geometry there, right? So, in optics, there's two fields. There's the spatial field and there's the visual field. The spatial field would be Euclidean. So you could think like train tracks in the distance. In reality, these train tracks will be parallel to one another in perpetuity. They're never going to converge. But optically, right, in the visual field, they diverge, or they converge together and at the horizon, right? So there's a deviation there from the spatial field being defined as like where an object resides in three-dimensional physical space versus where you perceive it in your field of view. Does that make sense so far?
No, I'm sorry. Could one more time, please? Sorry, Alan.
Yep. No, you're good. So think about you have a radius of vision, right? So if you take your arms out and make a cross, and you bring your arms together, you kind of make like a half dome shape, right? But the distance that you're bringing together is the same, right? You're like the length of your arms isn't changing, but you're still making like a dome shape, right? Like a hemisphere.
Okay. Yeah.
Okay, so we see in that, if you were to compress that horizontally, right, to make the dome, it would bring it to like a dome shape. And then if you did that vertically, if you looked up and did the same thing, you would have the same relationship. That's called curved visual space. And the effects of that are noted in the deviations from three-dimensional reality where objects physically reside. Like, for example, if I were to describe a coordinate system to describe where my keyboard's at relative to my eyes, it would be, you know, fixed in 3-dimensional space at X amount of distance between me, right? But if I were to describe where it was at in my visual field, it would be off a little bit. And you can tell the difference between the two more easily with an analogy with train tracks, right? Because the train tracks, they don't converge in reality, right? They're always the same distance apart. But optically, as they get closer to the horizon, you see the train tracks merging together, right?
Yes, but why?
I'm,
Why
I'm,
in the what in
I'm, I'm
in
gonna,
the
I'm
flat
gonna,
Earth? Okay, okay, sorry.
I'm gonna get to that. I'm just trying to establish that we have a radius of vision we see in spherical geometry.
Fair enough. Okay.
Okay, so when we have that, when they took measurements of these deviations, right? There's different levels to our vision, right? There's a near field, a far field, and what you could consider like an extra far field. So basically, something between you and the midpoint of the horizon would be like your near field, and then the horizon out there would be the far field, and then anything that's like even further than that would be the extreme far field. Now, if you're looking up at the sky, you have in this scale of compression, you're gonna like basically the near field, the far field, and the extreme field are gonna have different rates of optical compression. And this is an explanation as to why objects in your field of view will appear at different sizes to one another. For example, suppose you have a building that's in front of you, you know, at some distance, and the building appears larger than a set of mountains that's off in the distance, like much further back, right? You know, in reality, that mountain is way bigger than that building, but optically, the way that you're perceiving it, the mountains are low, the building is bigger than the mountains, right? Like the way that it looks. So the reason for this is that we see in curved visual space, and that's best represented by a logarithmic scale. And what that means is at different distances away from you, the amount of divergence is going to change at a logarithmic rate. So when you're looking up at the stars, right, say you have like the angles between 25 degrees and 70 degrees, right, are going to be the linear portions of your vision. So when we're looking at the streetlights above us, right, and how they converge into the horizon, the ones that are the furthest away are the ones that have the most distortion, right? But the ones that are kind of in the middle kind of are the same height. They look kind of like the same height, you know, they don't look distorted relative to one another as much, right? So you have this linear portion where you would have a 69 mile per degree relationship in the linear portion of your vision. That's what's going to create that. So as you traverse around the ground, you know, beneath the stars, maintaining that equidistant relationship where you know that the stars are, you know, well, you don't know the altitude, but you're considering them at 62.14 as a distance, the same way that you know that the height of the streetlights above you are all the same height, right? But optically, there's going to be like a sweet spot where you have like a linear relationship. And that's what the globe is based off of. That's what celestial navigation is based off of. Those the 25 degrees to 70 has the least amount of corrections needed, where it would be linear to a globe or your optics.
Okay. But I guess here's my point: is the globe model predicts that Polaris should change by a degree every about 69 miles that you go north or south.
Yep. Agreed.
And reality matches that, right?
Mm-hmm.
So just like the same thing as how the globe model can predict when an eclipse is going to happen and where you will be able to see, you know, the eclipse, you know, in the alignment. Thing is, the globe model is able to make predictions that fit reality, which is a way to test the theory. And it seems to me like the flat Earth model, I mean, first of all, there really isn't even a model, but also the fact that flat Earth can't make any predictions at all. I've talked to flat earthers online, and they've made predictions and they've been wrong, flat out. Like there was one guy who made a prediction about an eclipse and completely way off and wrong. And but anyway, predictions are a way to test your theory. And this is all evidence that adds up, and it all comes down to evidence, and that's not what I'm saying with flat Earth, and this is why I'm a globe earther, I suppose, because I like to follow what the evidence shows, and you can test the evidence through predictions, and if the predictions match up, then you're confirming them. It's confirmation, not proof. It's confirmation.
Right. I agree. So in regards to starting with eclipse cycles, right? Eclipse cycles are part of a great cycle. Once you know that cycle, you can start to plot out what they'll be in perpetuity. And you can plot them out or wind the cycle back to its starting point, which goes back to, I think, 6,000 years when you go over the great cycle. So you can definitely use it to unwind, when the first eclipse happened. And then moving forward, you can project that outward. You could look at Fred Espernek, who does all the calculations and predictions for the quote unquote globe or for NASA, right? It's actually determined from data sets based off of observations, because that's all anyone ever has. And like I said, the cyclical nature of it, once you have a couple of observations into the cycle, you don't need anything to predict the eclipse in terms of like globular information. Like that's not what predicts an eclipse, right? It's just cyclical of where it's going to be. It's not mutually exclusive to either thing. And actually, there was a guy who came around recently. His name is Mordwand. And he bet my buddy Shane $10,000 that he couldn't predict. I don't even know what the eclipse was, but Shane predicted out where it was going to be and where the shadow was going to be. And that dude's paid like, $5,000 or $6,000 towards it. So he actually made good on it. But I can get you the specifics on all of that in terms of eclipse predictions and stuff. But that's not a mutually exclusive in the way that we're all kind of taught that it is for the globe. They were doing eclipses predictions back in Babylonian times when they were all flat earthers, flat earth cosmology, the Hebrews and whatnot. So it's not mutually exclusive. And then what was the other thing? The predictions and equivalences. Remember my prediction for the optical equivalence, and then how we have a linear portion that would have the least amount of corrections. And when you look at the cell nav correction tables, at the angles that are 70 plus degrees off of the horizon and sub 25 require the highest amount of corrections. Now you could argue refraction for sure, but it does fit the hypothesis of having that linear segment that's going to be relatable, that you would build, the globe model off of, or any model really, because you would ideally want a situation where you have the least amount of corrections to use. So that's still in alignment with what I'm saying. Now we could get into two pieces of evidence, well, three really, but I'd like to start with just shadow sets to begin with, because I think that's a really straightforward one, because we're talking predictions, right? So if a sunset is impossible on a flat Earth and it's due to the obstruction of physical Earth curvature, then when the sun is setting, geometrically speaking, the light source is going to be below the objects casting the shadows. That's going to cause the shadows being cast by those objects to exceed the height of the shadow of the object itself. Does that make sense so far?
Yeah.
Okay, perfect. So if we take the example of a window facing west at sunset, the shadow cast by the window is going to rise up the wall at 15 degrees per hour. It's going to exceed the height of the window. And in addition to that, there's going to be an abrupt end of all light as a uniform, distinct shadow sweeps across the land at 15 degrees per hour to finally knock out any leftover light. Does that make sense so far?
Yeah.
Okay. On a flat Earth, the prediction would be that the objects in the sky are always above the horizon, primarily the sun, right? And as the sun gets further away from you, the shadows cast by objects will not exceed the height of the object itself. It will actually raise at about 15 degrees per hour, and then it'll slow down, and it'll never exceed the height of the object casting it, and it'll actually stop a little bit before that, and then it'll fade out as the sun's light leaves us, and it'll fade out rather than having an abrupt, distinct end to it. So we have two different outcomes here based on the geometric properties of a sphere versus a plane where the object that's illuminating the ground is moving away and it's carrying its light with it. You agree to that premise?
Yes and no.
Okay. What's your contention? How can I help?
Okay. So it's moving away and illuminating the object still.
Yeah. So the sun's light has attenuation that corresponds to it. Like it only goes, it's not going to go on forever. And in addition to that, like the light that's caused by the illumination from the gases in the sky, right? The noble gases, as the sun's magnetic field, starts to move with it as it's getting further away, we're going to lose light and it's going to fade out. The darkness is going to fade in. The light leaves.
Yeah. I feel like you're saying a lot of things that are not wrong, but still need a lot of additional context that is being neglected. So yes, for what you're saying, but there's several different contextual caveats that are not being mentioned or presented, which are very important in the context.
Do you think of anything specifically that I'm missing, or that needs to be included? I think either way, like on either model, right, you can conceptualize the distance difference and the sun's light being caused by the Earth as it rotates away to cause the distance change, or the sun moving away. I think the only real difference would be, that the source of the light distribution falling off is going to be that it's physically obstructed by Earth curvature, whereas the other one would just be attenuation and the sun not being able to, illuminate or interact with the noble gases to cause sunlight in the area.
I'm sorry, Alan. Can you say that one more time? I know, just so you know, it's
you're
probably
good.
later where you are. It's
Hey,
quarter after
bro.
11 where I am, and I'm like my eyes are getting heavy and stuff, and so I'm sorry. I apologize if I'm not following along with you here as much as I should be.
No, you're fine, bro. So, what I was saying is that optically, I think we would see the same thing. Like, I'm sorry, like mechanistically, right? Except the distinction is going to be you're going to have that hard shadow that's going to sweep across the land, and objects are going to cast shadows that are higher, regardless of uh, why there's illumination or whatever, right? The determining factor here is there's going to be two different outcomes, one based on physical curvature, the other based on the sun being above us at all times. But it's going to lead to mutually exclusive shadow outcomes. That's only going to be supported by one of the hypotheses.
It's going to lead to mutually exclusive.
Yeah.
It's going to lead to one hypothesis. I understand the words that you're saying, but they're not making any sense in the way that you're saying them.
So the globe is going to make a mutually exclusive shadow claim that the object casting a shadow is going to cast a shadow higher than the object. And the flat earth claim is going to be that an object casting a shadow will never exceed the height of the object casting it.
I haven't considered the shadow height difference between the globe model and the flat Earth model, so it's going to take me a minute to
No
try to
worries.
think about to think about which.
Are you on your phone right now?
Yeah.
Or if you can click on my name, you'll see that. 1 second, I'll tag you in it so you can get to it easier real quick. I'm streaming, and you can just kind of follow along with this video, and you can see what the different properties are going to look like. That'll help. Vivaldi. Peace. What's your Twitter name? Your ad name?
Coward Z Uvaldi. I want to immortalize the cowardice of those pieces of shit.
Yeah, that was my least favorite performance from the police.
Right. So I just didn't want it to be forgotten. So that's
dude, mad respect, never forget, bro. The protocols enabled there are insane, dude. So I tagged you in the thing, so you should be able to get the notification to follow along easily, and I can play this video for you real quick, and we can go through a simulation to show the differences between the two, and then we could look at an actual example at the end of how it plays out in reality once we have the context.
Okay.
All right, so videos.
Gotcha. Okay. I'm gonna put on mute.
Okay, cool.
Put on mute here and watch the video here.
Yep. Yeah. Mute. Yeah, you can mute or mute the video because you'll need the audio. I'll walk you through it, but leave Twitter unmuted, and we can still talk on here, and then the video will just be behind a little bit.
Hang on here. The shit is muted.
Let me know when you can see that. Are you able to see what's on screen now? All right, he's muted on here. I'm going to assume, I'm trust falling into your arms that this all is working out. Okay, so we have the globe prediction and we have the flat Earth prediction here. The top
Yeah,
version.
yes. Sorry.
Oh,
yeah,
oh,
I
perfect.
see
Okay,
it.
you're
But
good. You're
my
good.
finger kept fingering the thing. Yes.
Okay,
Yeah, I see it. I'm just trying to figure out how to mute the video. But yeah, I gotcha. I'm following you.
okay, perfect. So what's going to happen here is the sun sets. We're going to see the pillars casting a shadow on this wall, and the shadow is going to exceed the height of the pillars, and we're going to see this window shadow exceed the height of the window. And on a flat Earth, we're going to see these shadows not exceed the height of the object casting in them, and they're actually going to slow down and then come to a stop and then fade out. So we'll see how this plays out, and then we'll look at a real world example of it. So here, as it's getting darker, the shadow has exceeded the height of the pillar. The window's shadow has exceeded the window. On a flat Earth, where the sun is always above the horizon, so there can't be this angle disparity to create this type of shadow. We have the shadow slowing down, window shadow also slowing down, and then it's going to fade out. But pay attention quick up here, up at the top for the globe, because when I press play, the 15 degree per hour Earth curve shadow that's going to sweep across the land at that fixed rate is going to come and sweep everything up. So here we go, and we're about to enter nighttime now. Right, here's our 15 degree per hour shadow. It already swooped up the land. Now it's coming up the wall. And as we see here on the flat Earth, it's getting darker out, right? Which corresponds to twilight, nautical twilight, astronomical twilight, all these different twilights that they give us. Well, those are all in relation to where they're saying that the angles of the sun is, not in relation to the light distribution or intensity, right? So this is what would happen if the Earth were a globe. You would get this hard cutoff here, very distinct shadow that sweeps across the land. And what we see is that these shadows will rise up, they slow down, and then they just fade out. So that was how it's modeled out for the globe versus flat Earth. And now we're looking at an actual scenario where this played out. Now, contentions to this, we don't have the height of the thing listed right here. We don't have the height of the window. We don't have a frame of the two or whatever, but I'm working on getting those put together. And by me, I mean Man of Stone is working on putting those together. So we're going to have a more aesthetically pleasing way to present this so that you can verify all the necessary information that you need. But looking at this play out, we have the window. It rises up throughout the sunset, and then it stops at this height here. It never exceeds this height, and then it just fades out into darkness over time. So we started here, raised up a little bit, came to a stop, and then faded out. So we'll have more on that, but basically if you have a window facing west, you can verify this anytime. I await your return, sir.
Clearly, I need to learn how to use Twitter a little bit better because I was watching it and had both you guys, well, had your recording talking and you talking, and sorry, I must be a dinosaur when it comes to using this stuff and trying to figure it all out. But
no worries.
what would the globe explanation be?
Ooh, it's a great question. So I've never heard it explained really why there's no distinct shadow like that. I only have heard someone mention the differences between nautical and astronomical in twilight, like the different gradients of twilight. But like I said, that's in relation to positions of the sun, the elevation, not the luminosity in the area. So that doesn't really help, So there's no answer to it really, and stuff like this is why I became a flat earther, right?
Yeah, I can. Okay, I can see that, but I also have a difficult time with why would the globe model be wrong? I suppose would be a big question for me.
Great. Well, the globe model is just positions of the stars mapped out on a hemisphere. It doesn't seem to have any ground relation to anything. So, like, how could the globe model be wrong in the sense that you can compute distances accurately, use it to traverse the land, use it for navigation, etc.? Well, it's not. But the distinction to be made is that the latitude longitude system doesn't represent the globe. It represents a projection that could be called a globe, like, just in the same way that it represents an azimuthal projection where the Earth is flat with outward concentric circles. All of these things are equally valid under the use of the coordinate system, but in relation to, the shape of the ground, like we just went over one of the biggest mutually exclusive ones, and there's a couple other ones. And so it's not that it's like, wrong. It's just that it didn't exist in the first place. But because everything is in relation to positions of the stars, we just kind of thought that it was, for a long time. Because of the favored projection.
Okay, well, Alan, I tell you what, you have a, and I'm sorry, man. I'm working tomorrow, and I am super tired, and you've given me a lot to think about, and my brain is not functioning very well right now. But I'm going to be going through our conversation, and I appreciate your ability to explain things from a flat Earth perspective.
Oh, no worries,
But
man.
I think I'm going to color a night here. So
No worries. If you want to go back to the recording, click on my bio on Twitter or whatever, and my YouTube channel's on there. This broadcast is recorded, so you could just play this episode back and whatever you need. And if you have any questions or whatever, obviously you can DM me or email me, and then I could show you more stuff or whatever. It's actually, Twitter's a pretty hard medium to share the kind of stuff that would make it really easier to understand and digest. So,
yeah, very true.
So yeah, if you want to communicate on like a different platform or something like Discord, where we can share, or I can share my screen with you and you can see everything directly like that, be more than happy to do that with you.
Cool, man. Well, I appreciate it again, and have yourself a good night, dude. I'm sorry. I'm like half passing out here. So
hey, no worries, man. Thanks for the back and forth.
All right, you as well, man. Thank you. Bye-bye.
Later. Yo, Zay, are you still there? Stone, Dom, any lads in the chat? Is anyone still here in the audience that wants a mic? Otherwise, we'll probably wrap up soon.
Yeah, I'm still here.
Nice.
Graphicking and plotting away.
Nice.
Yeah, I'm in the middle process of clipping the Epic Ramp by Pizio and the Globy.
Nice.
Hey, maybe I could ask you or Stone, what before he broke up, before Hap broke up for the 7th time audio, he was just about to get to the crux of what Pizio was saying for the analogy of dropping something in the water, dropping a ball in the bucket or whatever it was. He acknowledged the fact that if everything was stationary and you dropped the the ball in the bucket, it would fall straight, as well as if you filled it with water, and how that was not what Aries was about. His misunderstanding was not what it was about. Did he ever get to resolving that it was a misunderstanding because the refraction starts from the water? Because from what I gather, he believes that refraction starts before it hits the telescope. I don't know if that was a mistake in interpreting. What do you guys think?
Yeah, I think that was a mistake in interpreting what he meant. I don't think he said that it happens before.
Oh, okay, cool. Because I remember him talking about the lateral velocity and how PZ was talking about you're getting that mixed up. In reality, it's a cone shape from, if we were to accept the heliocentric model, it's all light coming in parallel, as you guys think. If it's coming in parallel, then you can't go back and forth with that. It's not you're going to get that.
Can't have a horizontal velocity drift to it. Is that what you're saying? How dare you?
Correct.
How
Correct.
dare
Did he acknowledge that? Because he kept on breaking up.
No. Now he must have missed that one.
All right, cool.
By the way, this debate with police guy, whatever, was cool. Like, I love how he like wanted so much disagree with you, but he like just like couldn't. It was such a good work, man. Like the pause that he like always needed to answer and like find that something that he just like wants to disagree but can't. It was amazing. You have to clip it. This one was like really good, and you actually like went like through like his cognitive dissonance like a little bit, because like I think it was honest reaction then when he said he got like lots to think about. So this was like a really good job, man.
Thank you. Yeah, we all went through that moment where we were like, oh, this is going to require more.
Yeah.
I remember my first taste at it, I was like, what? No starlight in the, or the astronauts didn't see the starlight or whatever. I'm like, of course you can see it. And then I was like, well, wait a minute, there's no material. And then I was like, okay, well, and then so I went to Quora, right? And then everyone had a different answer. And I was like, oh shoot, nobody knows, huh? You guys are all just saying different things. And then now we have astronauts that say different things. And it's like, so now, nobody can provide anything that makes any sense, because like now we have contradicting narratives and stories from official sources. So like that was like, that moment where you're like, oh shoot, this is now on me to figure out, we've all been there.
I do like the approach that you're trying to make it for the layman. I think those analogies help out, because anybody could picture a ball dropping in a bucket, and there's always those buckets, man, that shatter mainstream scientism.
Dude, a bucket in a medium, bro, just has completely destroyed all of mainstream physics.
I don't know about anybody else, but I'm waiting for those cat podcasts with you. Are you guys going to do a personality too? Like, hey, that does seem interesting.
Yep. Yeah, it's going to be dope. I'm actually using Yo Stone. Shout out to you. I tried VideoPad. It's incredible. What I was using.
Oh, so glad.
What I was using, full dog shit. VideoPad, incredible. Immediately started doing the thing that I wanted it to do.
Oh, that is awesome to hear. Congratulations. You've arrived.
Yeah.
Oh, that's awesome. Great.
Yeah, so that'll be out soon. It's a nice little hour piece, just kind of breaking down everything, the history, and then like the different arguments that were put forward. And then I'll have a bunch of visuals that'll pop up to recap the significance of what was being said and stuff. So it should be really cool.
Cool. Now, the stuff I've been putting through that software recently has actually presented quite the challenge. Like grabbing 6 already produced pieces of something rotating and then dropping that on a still frame as 7 individual video tracks, if you can picture that on your timeline, right? And it has to render them all at once, so to speak, in the edit window, and the thing is just crashing harshly. So I had to do a little subgrouping.
Oh, am I going to run into an issue because I actually have the same exact thing with what I'm doing?
You might. So constantly save your work. I find that what's really cool is pay close attention to the temporary folder location and your ability to delete everything in that cache every time you're done using the program. Because I find that from session to session, sometimes when you have a lot of content, you know what I mean? A lot of clips and a lot of slides and a lot of audio, and you are hacking and slashing them and putting them all together in a sequence. As you go through that, as it gets more complex, sometimes it just glitches right out. And I find that I can reduce the frequency of that by in between sessions by deleting the cache file. And then it just rebuilds everything from your source files the way it should from the project file, sort of a crisp copy, if you will, to work with. And yeah, it'll actually kind of save you a little bit of bloated space as a habit too. So yeah, I recommend that.
Nice. Yeah. Is my mic on? Yes. I will definitely keep that into consideration because like I said, I just started using it, but so far it's been great.
Ah, so cool.
Taylor back up here. Welcome back, Taylor.
Hey guys, did y'all make any conclusions with that last gentleman?
Yeah, it was awesome.
Yeah, he's got a lot more
It was
thinking to do.
totally
That's his
epic.
conclusion.
Yeah, that was dope. I like when people like that come in here and like open-minded, just investigating. You know, that's what we need more of.
Yeah.
I liked the way he kind of took himself to task on his own generalizations on the fly when he says, well, when there's so much overwhelming amount of irrefutable evidence of the globe, then, for example, and he goes, and tries to think of one. that was entertaining.
Yep. We've all been there. Fucking, it's like that's exactly what it was. It was just like, well, we got images from space, right? Those are real.
And then why would they lie? And I think it's like basically it's most like thanks to your approach. Like if there was someone different who was but like more defensive or like more hostile towards him, it wouldn't like be so nice back and forth. So this is something for everybody else. Like this is the way we should debate Globers. Actually, it was really cool.
Yeah, the null hypothesis is hard to get around once you're, especially if you're on board with that like method of thinking already. You're like, oh yeah, that's great. It makes sense. And then you start applying it and you're like, oh shoot. It definitely can't be a globe now. Dang it. Yeah, it's getting a little late, though.
I think it was successful first Ether Cosmology Friday.
Yep, just filling in for the lads and the cyborg and cyborgettes till they return.
Yeah, it's like 20 to 5 here. I'm kind of wired, but it is pretty late. Got to be honest about that.
I think I'm kind of wired, but I'm like exhausted. Yo, Nathaniel, you want to get a couple of words in real quick before we wrap up, bud?
Yeah, I think I'm here late. So wonder if you could explain the bucket thingy with the water in the bucket. Oh, if there's a YouTube video on it or something. I don't know.
Oh, Newton's bucket? Absolutely.
Oh, so how does that work exactly?
Yeah, so when you apply the equations of motion to the reference frame of an observer inside the bucket, he makes the wrong prediction for the forces acting on the bucket. So when you're rotating a bucket full of water, there's going to be a centripetal force on it that is causing convexity to the water, right? So when you apply that to the moving bucket, you make the correct prediction that that the bucket's velocity is going to cause that like the water to be convex in it. Now, if you were an observer inside of the bucket and you applied the same equation to make the prediction, your velocity would be 0. You would be stationary in the bucket, and you would see whoever's spinning the bucket going clockwise around you. So you would say your velocity is 0, but the water in the bucket would measure a concavity to it. So you would make the incorrect prediction, and it's basically showing that to make the correct prediction for motion, you have to make it with respect to a stationary non-rotating frame.
Oh, yeah, I was going to say the water would go upwards towards the edge of the bucket.
Yep.
Because it's in motion.
Yes, sir.
But of course, the globers will say, "Oh, well, how the Earth's only rotating at 15 degrees an hour." Then what if you had the bucket only moving at 50? Would it still get you? Would you still see the convex? If you did it slow, if you had it moving slowly, because they always try and use that excuse. Oh, it's only the whole 15 degrees an hour thing.
Yeah. So there would be convexity to it, and there's not any measurable convexity to it, to the point where we had a PhD astronomer say, well, maybe if we got some sort of microscope out and looked at the molecular structure, we would see that it's not actually flat and level in the bucket, and that it is convexly going up the bucket. And, that's not even a real position.
Oh, yeah, I guess that makes sense. Because I guess well, I don't have much for life, but yeah. So I guess the main thing is I just try to convert my dad to flat Earth type thing. So I pretty much thought I'll just keep trying until he dies. But he mentioned about like a couple of plane flights, like Johannesburg to Perth, and was it? I think they're Tokyo to San Francisco, and saying, well, shouldn't he's basically sort of saying, well, on the flat Earth model, Johannesburg to Perth should take a lot longer. And then I know that I didn't mention jet streams, but then you go, but so I think one way, but with both those flights, what going one way is 2 hours longer than the other, but it's the same both ways. So I think they are manipulating flights because I think it's like they have a system that's like, are they using different planes in different areas? So so for planes, so is it just simply that the plane flying from Johannesburg to Perth is flying faster than because I don't know how else it really works. Otherwise, are plane flights actually flying faster in
Yeah, I think they are, but I'll give you some anecdotal evidence here in a second before we get to jet streams and how they could facilitate that to make up the differences or create the differences. But remember the graticule, the spherical coordinate system of latitude, longitude that's being used represents the same distances over different projections. So when people show different flight routes in the south, they'll often say that, these distances don't make sense on a flat Earth. It's way bigger by drawing straight lines on the, between the distances. That's an invalid use of the map to determine distances. And then when they draw the curved line to it and they show the correct one, they misinterpret how visually it looks because it's elongated out as meaning that it's going to be a different distance, but it represents, the same accurate distance that it would on the quote unquote globe projection, which they would interpret as globe with 8 inches per mile squared curvature, et cetera. And the second part to your question about the jet streams is Now this is anecdotal, so I don't like use this, in battle or anything, but there was a guy that came by, we called him Model Builder, and he had downloaded some flight data before it had been received by the website that all the flight data gets published at. I forget the name of it, but I can go back and look. But anyway, when he had this data set and he compiled it together, it would show the plane's true ground speed because it used GPS as the reference for determining the plane's velocity. And what he found was the planes were flying, I think it was 150 to 250 miles per hour faster in the south, depending on which directions they were going. So that would definitely make up actual discrepancies between the locations where the coordinate system would be off, but because it's symmetrical through corrections and stuff, that's where these distances would be made up through that jet stream mechanic. But he never published that data that he got, and he never made it like publicly available for everyone. So I don't, I can't really use it, but that would be, can't say I haven't seen it, if it's all legit and real, I can't say that it doesn't not exist or whatever.
I think actually, because I know I guess the Gleason map is a globe projection, but then I always find it a bit confusing because I was like, oh yeah, I guess I think I mentioned this before, but how is Australia, the United States, and so I was thinking like, since there's Australia, east, west, and mainland United States is a similar distance across. Well, logically, wouldn't it the time zones? Because they're saying the eastern states of the United States are 3 hours ahead of the western states of America, and then in Australia, the eastern states are 3 hours ahead of Western Australia. But because if it's the same size, shouldn't like a southern continent? Shouldn't the time zone be quicker? So it should be like if it's the same size, because wouldn't the sun have to travel a further distance to cover? Well, when it's in the southern summer, the sun would have to be moving faster. So would
Yeah.
so over the same distance, wouldn't a southern continent have the time zone be less? So shouldn't it be like, say, in America, what's 3 hours across? Shouldn't it be like 2 hours across Australia? That's what I just that's what I'm just finding a bit confusing.
Yeah, you're good. So the velocity of the sun, I think, increases and decreases throughout the year, and that's actually part of what is measured interferometrically, right? There's a minimum and maximum peak to the speed of light that corresponds not only to the position of the stars throughout the day, but also to the position of the sun throughout the year on the equinoxes, where the speed of light will reach its minimum and maximum velocities. And I think so like the translational speed of the sun would increase, but that would allow it to maintain the 15 degree per hour relationship. And I think that's what's measured. It's the sun speeding up and slowing down, rather than how they tell us the Earth completing an elliptical orbit is speeding up and slowing down.
Oh, yeah. I think that makes sense. Yeah.
Actually, I can send you a video too. I can't remember the specific argument now because it's been a while since I've watched it, but there was a YouTuber named Orphan Red, and she did find some documentation. Orphan Red. She did find actual documentation of them confirming that, the sun, like how it changes speeds or whatever. But like, obviously they would interpret it through the Earth speed, but see if I can find that for you. All right, I just tagged you in another post. So I tagged you in a Newton's bucket post and a movement of the sun post. You can check those out.
Oh, yeah. Thanks for that. Yeah. And hope, hope you can get some sleep.
Yep, no worries. Yo, is that one mic debate? Hola, senor.
Can you hear me?
Sir.
Can you hear me? All right. I also go by Hypothetical Genius. This is my ex account, FYI. I know I've been in your chat a few times. I think we've commented back and forth a few times.
Oh, nice.
Man, that was one of the best. I wouldn't even call it a debate. Just laying out of the flat Earth arguments that I have maybe ever heard, to the point where we should all go clip that. Man, you handled that guy just really, really well. That's really all I called about. I do have some questions, obviously. I mean, I'm not a Glober or anything, but I was thinking about that dome of view, and kind of going back to when we're dropping the ball into the trash can. Let's just start with that, actually. So if we drop two balls at the same time on a moving trash can, one has water in it, or let's call them rocks so they sink. One has water and one has no water. Those two would be different, correct?
Yep.
Okay. I think that's a good way to illustrate that, as if you have two rocks, two trash cans moving below it. You're going to drop them both at the same exact time. And only if you were standing right above it and it was not moving would it hit into the center of those trash cans at the same time. How do you feel about that?
Yeah.
As like an illustration to go off the analogy that you were going on. So with that being said, one of the things I started thinking about was the way light moves through water. And so I started thinking about what's it called? The spear fishermen, where they have to aim below the fish in order to hit it.
Yeah.
Okay, so we know that there is diffraction through water, right?
Yep.
Okay, and so the atmosphere is made up of thin water. Can we say that basically?
We certainly can.
Okay, so the things that I look up above me are more correct in their reality perspective to me than the things that look toward the horizon. Can we say that? Due to diffraction.
Not only can we say that, I would say refraction, but not only can we
sorry.
You're good. Not only can we say that, they measured it with interferometry. The difference between light going through regular air and then like moist air, like for humidity and stuff. And the differences in the speed there.
Okay, so with that being said, like that gal was talking about earlier, if she set up a camera and pointed it out a window at a mountain, almost certainly throughout the day, that mountain's going to bounce. The top of that mountain. If you look at it like from a pixelated standpoint on a digital camera, that's totally stable.
Yeah.
I don't think she even needs to go. I don't think there's really nothing to prove there. Now, with all that being said, okay, I want to draw like a dome picture perspective and just get your thought process on it. So because things refract down toward us, basically, so when I look at something on the horizon, it would almost look like a firework to some degree, right? So like, let's say I'm like, imagine a firework I'm drawing to all the stars around me, just imagine a straight line. But I would curve those lines more and more as I get closer and closer to the horizon.
Yeah.
Okay. Okay. So I'm on the okay. So I'm on the right page on that. Anyway, I mean, I got about a million other things I could talk about, but this is my first time on X, by the way. So
Oh, welcome.
pop my cherry. I'll be
Nice.
back. Yeah, feels good. Feels good. I don't know if you can hear me. I do have a Bluetooth headset, but hopefully
no,
it's sounding decent.
no, you're crushing. Sound great.
Nice. All right, man. Well, I'll mute for a little while. If I think of something, maybe I'll tap back in. I know you're trying to call tonight too, so it is what it is.
Yeah, I was thinking about wrapping it up. I just don't want Taylor to socially shame me for going to bed early, but I think 3 a.m. is pretty decent.
Yeah, no, man. Go get your sleep. You've done what you needed to do tonight for sure, in my opinion. And I hope you don't mind. I'm going to go back and record that whole conversation. I hope that guy does come back.
Yeah, same. I hope he
Because
does.
I do think the more he looks into this, he's going to realize. I will say this, and just to pivot off of this, one of the biggest issues that I've, had is, I think as flat earthers, we need to accept the fact that we are basically saying there is a conspiracy on such a mass level. I know nobody wants to like outright address that because it makes you look like a crazy person. But at the end of the day, if what we're saying is true indeed, then that really does mean they're faking all this stuff. And that's speculation. We could never prove it. And I understand why we don't ever want to walk down that path. But from a, actually trying to change hearts and minds, I think that is the very first thing you need to address.
Yeah, I'll take it into consideration.
And by the way, I think you can use other little factoids on the other side of what the paradigm says, like that you and I at the same time right now are moving 2.5 million miles per hour, spinning at different rates in elliptical circles through a Milky Way galaxy. You and I right now are literally moving 2.5 million miles per hour. I think those things on the front set, this is assuming you're talking to an open-minded person like that guy that called earlier. But like those things, I think, resonate with the normal person that is open-minded to think about this. But I do think you need to address that there is a mass. Yes, we are saying there is a mass conspiracy here. We don't know why, but it would have to be. Just throwing that out there.
Yeah, for sure.
Anyway. All right, man. Good job tonight, for sure.
There.
It was nice listening.
Thank
All right.
you. Yep.
Bye.
Yo, Taylor.
Yeah.
Is it my curfew? Am I allowed to go to bed now? Is that, have I done my duties or whatever?
What time is it? You can go to bed, Grandpa.
Well, Grandpa has a presentation at I think 2:00 real people time.
Yep.
So anybody who wants to listen, tune Alan on YouTube, and he will be streaming Battle of the Beams. So anybody who wants to revisit, just join Alan YouTube.
Dude, not only are we going to be beam battling on later this Saturday with Dom at 2 p.m. Real People Time. That's Eastern Standard for those outside of Real People Time. On Tuesday, the 28th, Dom and I are going to be debating McToon and
Markley.
We're going to be we're going to be debating that guy on Modern Day Debates. So, and I think that's at our normal Ether Cause time as well too, at 8 p.m. So tune in, or there'll be a watch party live on the Ether Cause Discord. So if you guys need a Discord invite, you guys know where to find it.
It's just going to be ugly.
What's the date on that, Alan?
The 28th, Tuesday, 8 p.m. Eastern. Yeah, it's going to be a doozy. But yeah, that should be fun. So tune into that. And then we'll have more TikTok stuff going on during the week, but also Monday night before Tuesday will be game night, EtherCause game night, headed by Taylor and Kat. So we'll be doing some fun activities, hanging out with the boys and ladettes. And then Tuesday will be the debate. And Wednesday or Thursday, we'll be getting into more TikTok stuff. So we'll do some stuff over there. And then Friday, of course, will be another EtherCause space if Flat Earth Fridays is still on vacation.
Andrew's doing trivia on Sunday, don't forget.
Right. Trivia on Sunday. So yeah, get in the EtherCause Discord if you're not already there. Discord.gg/EtherCosmology. And you can come participate in all the cool stuff we're doing.
Hey, real quick question, if you don't mind me asking. On those modern day debate shows and stuff, do you mind sharing what the profit share is, or you don't have to? But
Oh
I'd be
yeah,
remiss if I didn't ask.
absolutely, brother. The profit share is 0.
Are you serious?
Yeah.
Yeah.
Why I don't? That's
Dude.
Why I'm not staying around for super chats or anything like that. After
Honestly,
the debate,
man?
I'm dipping. Like I'm not. It's retarded.
That is retard. So I had an idea for a debate channel. I called it One Mic Debates because essentially there's one mic, so you have to pass it back and forth. I don't know how that would be enforced. I don't know if you've had a chess clock type thing on it, or I have a whole bunch of ideas on that. But I would absolutely share the super chats with the debaters. That is outrageous. Just saying.
If they
Obviously you feel my pain.
Yeah, if they did that, it would be so cool because it would motivate people to actually perform well and do good, I think. But yeah, there's just no incentive for anyone to give a crap. They just kind of show up and your corner is going to back you regardless of how you perform, really. So your behavior wise is just, it's a travesty sometimes.
So are you saying that I should put a little more effort and time into trying to make a debate channel?
Saying if you made a debate channel, I wouldn't not give it a shot and promote it and debate on it once or twice to see how it goes.
Yeah, sure. And I wouldn't, hold you to that, in the beginning, but
No, I'm saying I would do it.
I know, that's awesome. Thank you. Man, you've convinced me to actually put some effort into this.
Do it.
That's outrageous that they do not share that. That's an outrage.
Yeah. Nobody gets any money on either side.
Crazy.
Hey, one Mike, I just started following. I think that's pretty interesting. I'm actually keeping it on the hush. I am working on something that's centered around that one concept of one mic. Simply because people like to interrupt, and it becomes annoying where there's too many voices, and you have to moderate. This eliminates the need to moderate where there's a time limit for when you get to speak. There is an issue though that just because you have a chance to speak, you can't really force somebody to respond directly to what the other person say unless you have a format that you have to go by. I'll share that with you. I think if you want to brainstorm.
Maybe we should talk. I'm like I say, I'm new on X here, so I can't see who's talking. But man, I've gone back and forth on how you would regulate this thing, and I just keep coming back to you need a solid moderator to regulate it, because I don't know.
Yeah, that is the
I don't
issue.
know how else. I don't know how else you can do it.
There is a well, that's why I say I think you hit the nail on the head, and which is why I wouldn't mind networking and brainstorming with you. But there is another way, but it's you can remove a moderation altogether, but they have to agree to a format of logical structure, which not many people want to do. People like to talk about logic a lot, but you're minding your P's and Q's and putting into practical application is another story. But I'll show you something, and maybe you thought of something, and we could probably have a eureka moment and network that way. You let me know.
Yeah, that sounds great, man. What was your name?
Mr. Xavier. You'll see the yellow Gadsden flag, libertarian flag up top.
Cool. I'll send you a friend request or whatever it is. Or why don't you send me, because I'm not figuring this out. Oh, I
No
see you.
problem.
Okay, cool.
No
Got you.
problem.
Thanks, man. Talk soon.
Yep. Awesome. All right. Good night, everyone. See you guys later today, and then Sunday for Globe Busters, Monday for Ether Cause, Tuesday for debates, Wednesday and Thursday for TikTok stuff, and Friday for more Twitter stuff. Later, lads.
Good night.